Hello, everybody. Good morning. Happy to have you. I'm happy to introduce to you. Oh, the clicker's over there, I think. Mats Mathiesen. Running away. We picked him up in China.
I'm very happy to be opening the stage here at Modular Summit Day 3, last day of the summit. I am Mas, known as Raining Coffee on Twitter. I do research at Maven 11, and the goal of this talk essentially is to tell developers why they should build modular, and why some are doing that already. And the goal essentially is to prove the memes wrong. And there is a lot of memes about modularity being completely pointless. I'll have to say why it's not, and that's essentially what we're going to do today. So the methodology behind this is essentially the modular solids that we do have. So usually we know about the rollups, optimistic, CK, we have based rollups that are sequenced on the L1, we have sovereign rollups that settle to themselves, and we have what we call alt-DA rollups. So a rollup using Celestia, maybe settling to a separate settlement layer like an Ethereum. And there's some nuances here that we maybe don't care as much about, but validiums, app-specific, generalizable, and so on and so forth. And monolithic setups are great for some things and terrible for others. So some of the shortcomings are specifically fee markets. You generally share fee markets with all the applications on the blockchain that you're on. There's some nuances here, such as Solana, which has local fee markets, which helps with the noisy neighbor problems. There's also state bloat, so you have the state of every single smart contract. That could be hundreds of thousands of applications, and this all bloats the chain as well. And there's a humongous lack of control. This is probably the biggest issue. So you cannot do any upgrades for your specific application that you might need to make on a chain. There's no customization. You don't have any ordering, opcodes, gas limits, and so on and so forth. But you have some pretty powerful powers that you don't even have in sort of traditional Web 2. So synchronicity, you can call any application and make calls to it, swaps, whatever you need. This is super, super powerful. And you do lose that in a modular setup to some extent. And generally, you have a pretty decentralized validation setup. So Ethereum has a ton of validators. The same goes for a lot of other larger sort of monolithic setups as well. And you have users, generally, which some modular setups are still missing at this point. Modular setups and their properties are sort of the opposite. So you have some shortcomings. You generally have to derive some security. And there's some nuances there we'll get into later as well. You also lose generally interoperability. So most monolithic setups, as I said, have synchronized composability. They can call smart contracts and so on and so forth. You don't really have that as much with modular setups unless you have a very homogeneous setup with IPC, for example. And you have the asynchronous calls that you also lose. And this is where we have synchronicity on the monolithic setups. The powers you get, though, are pretty cool. So you get sovereignty. I think Nick White will speak about this later today as well. And you get upgradability. So if I need to make any upgrades about the things we talked about earlier, you can do that. And then I generally also believe that apps have to and are opinionated. So generally, you have some opinion about what kind of things your app should have, what they should be able to say, and so on and so forth. And you also gain ordering and customization. And we'll get into why this is powerful, especially for MEV. And you're also elastically scalable. So an Ethereum is generally only the same amount of power throughout. With a modular setup, you can sort of change things out as you need, which is super, super powerful. Now, one large issue that Solana solves with the local fee markets is this noisy neighbor problem. So this doesn't just extend to gas fees, but also to things like state bloat. And doing inventory risk management becomes extremely difficult because you're essentially sharing a warehouse with a ton of different applications instead of having your own specific warehouse where you set the pricing. And this goes for things like a swap, a transfer, and many other things as well, where you essentially are dependent on what other applications are using at the same time to how much you have to pay in gas. Now, rollups are growing. I think that is extremely clear. We have a ton of generalizable rollups coming out. Currently, we have 58 that are live. We have layer 3s, layer 4s, layer 5, layer 6, et cetera, et cetera, et cetera. And we have a ton of upcoming products. I think which generally is somewhere around 200 that are coming out. Many of these are generalizable, but application-specific rollups are also coming out, which is quite exciting. And there's a variety of methods that are using to derive security. Some of these are more scalable than others. We'll get into why specific shared consensus is not quite ideal. And I think what we've seen is that this sort of move from generalizable to app-specific rollups is happening. And this is sort of a result of this stack and commodification of this maturing, which makes it a lot easier to launch a rollup. You can do that in a few minutes on things like Gelato, Conduit, Caldera, and so on and so forth. And generally, if you look here on sort of how much people are posting to things like Celestia, Ethereum in terms of call data or blobs, we generally see the biggest ones being both generalizable, but we have some interesting ones here that are actually app-specific, for things like proof of play and Psi as well. And also Orderly, which is on Celestia. Now, what has been very clear over the last year is that DeFi is going multi-chain. So developers are more often than not actually launching their applications on multiple rollups rather than a singular one. Now, there are still issues with this. We need things like chain abstraction, but there's a ton of different applications working on this specifically. We also come into an issue where, specifically in modular setups, we might need things like super builders. And obviously, we lose this synchronicity that is super powerful. We also have a ton of inventory risks that are specifically caused by intent-based bridges. So we need solvers to take the risk because of challenge periods, which causes an optimistic setup 7 days before you can get your funds out. As such, we have people take inventory risk, and they'll take a fee because of that. We also have pretty crazy state fragmentation, but things like storage proofs, VM extensions, so things like Risk0's Bonsai, but also plenty of these storage providers are doing a good job here as well. But one issue is that these rules for state are still different from rollup to rollup. But I think there's some pretty cool things coming here in the future as well. We'll skip over these slides. But what we're starting to see is that fast monolithic blockchains are starting to realize that, we actually need modularity. We can't just stay monolithic. A recent example of this is SIDA on Solana. They have specific needs that can only be serviced in a setup where they're modular because they need some sort of customization. This is especially important for DEXs and AMMs. But what we also saw recently was the announcement of CK compression on Solana, which essentially is this sort of based Validium setup where, because of the incredible amount of state that Solana is producing, we need sort of ways to put some of this state off of the main chain, but we still want to be able to update this state. So what is very clear is that Solana, Monad, and many others are probably going to come down to a point where they're saying, we actually need setups. We need setups that can provide us these powers. And I think we're going to see in the next year or so a ton of rollups actually coming to Solana, which is sort of breaking the idea that monolithic setups are going to be a constant thing. They will obviously be powerful for some applications, and it's more of like a funnel. You'll probably start as a smart contract there. Now, the real powers that you get from building a modular setup, as we talked about earlier, was the customization. So here are things like precompiles, block times, gas limits, also the ability to change VMs. We're seeing SVM rollups, move rollups, WASM rollups. We're seeing blended rollups using all the above. And if you need specific things like CK, you can also do this. So an Ethereum only has a BNS 128, which is not the most secure sort of way to verify CK. You might want to change these things. You're also able to specialize specifically for your purpose. So this could be you want to be able to scale elastically with the amount of users that you get without needing to sort of make crazy upgrades or cause problems for other people on the chain as well. You also be able to do things like in-protocol data sources. So this could be things like Slinky from Skip, which is super powerful Oracle. This can cause things like Oracle extractable value. You might also want to do things on a database level. So a lot of people think of execution, consensus, and those things as the bottleneck, but things like reads and writes to the database is also super important to optimize. People like Sovereign Labs are working on this, obviously Monad, but also MegaETH. And maybe you want to do things like monitoring and response. Maybe you are a real-world asset rollup, and you want to be able to choose who can actually access your rollup. If there's an exploit happening, you might want to censor this. We can call this good censorship. Now, one of the most powerful reasons for people wanting to build modular is because we want to internalize our MEV revenue. So a Uniswap, for example, creates a ton of MEV. We might want to actually be able to control this, or maybe provide fair ordering. So generally, MEV, for example, is extracted by a leader, and where the leader proposes a block, you can extract value because you decide what gets put into the block or not. And this makes monetization extremely easy as an application. Or you can also do things like set ordering rules. So you could do verifiable sequencing rules, frequent batch auctions, intent-centric applications. And as I said earlier, you can do things like good censorship, if you believe that's a thing. Now, as mentioned, MEV is extremely powerful. So as a modular application, you tend to get to the point where the monetization you're having here is priority fees. That we call MEV. You might also have some base fee that you're able to collect as well. That's probably higher than the amount of cost you're paying in call data and to make state updates. And the cost of a modular setup is generally just DA, maybe storage, and maybe compute. And there's some nuances here if you're like a shared security setup. Now, one of the most powerful things, I think, is that, as sort of Ken alluded to yesterday in some of the panels that he had, is that Uniswap has quite a few problems with sort of creating value for the LPs. There are things like LVR, and there's a ton of MEV that is sort of created on Ethereum, but it's all going to Ethereum validators rather than Uniswap token holders or Uniswap LPs. So they create a large amount of inefficiencies. Searchers are paying a lot of money to extract these profits, and these are being paid to the proposer rather than actually to Uniswap itself. So if they can control inclusion, they can extract priority fees. And this is essentially something I think, especially things like Uniswap, Maker, Aave would benefit from extremely. Now, there are some issues here. They probably want synchronous composability, especially in a base rollup type setup, where they can get this and keep this while still having auctions to extract MEV. We'll get into this a little bit later as well. But I think Uniswap is a perfect example of somebody who would have an incredible advantage of being actually in a modular setup. Now, as we talked about earlier, one of the things that you do need to do when you're a modular is you need to derive some degree of security. Generally, there's three ways to do this. There is data availability, so things like Celestia, Avail, EigenDA, and this is generally the last bastion of truth. And then you have settlement, which is generally censorship resistance of dispute resolution, so things like challenges for optimistic rollups, CK verification, and what have you. And then you have consensus, which is sort of this shared security model. You have an interchain security, but you also get this with things like EigenLayer. Generally, the cost of consensus sharing is extremely high. So generally, if you have other validators, they're going to be opinionated. And if you're opinionated, you're going to want to be paid a specific amount of money because you're taking on some risk. So you have a cost of flashing. And generally, opinionated security is generally not the way to go. The costs are high. You have to incentivize and maybe give away fees. But if you're big enough to create fees, why are you giving away the fees? That's generally the way I look at it. And generally, all the way down, I think DA is the only thing that is scalable in terms of derivable, because of the fact that with DA, the DA validators are not opinionated. They'll take your data, they'll order it, they'll put it in a block, they'll sample it, but they do not care about what kind of data they actually have. And it's an extremely powerful way to actually derive security. Now, one thing that we've also been seeing with this commodification of the modular stack is the fact that, and we can see this in TradFi and Web2 as well, is that when the demand for a product increases, it's generally because the prices of it decrease as well, the complements that they're reliant on. And when that happens, we see a great amount of innovation. And we're starting to see this specifically on these app-specific rollups, which is super, super powerful. And generally, we hope to get to a point where we have this commodity price, where you have the indistinguishable goods. And generally, this is probably going to be way further out. Crypto is generally more BD attention-driven at this point. But I do hope, and I think other people hope as well, is that as the industry matures, this becomes more of actually the thing that's going to happen. But what we are seeing is this API economy that we know from Web 2 coming into Web 3 as well. So you can plug easily into data availability layers. You can use rollup SDKs. If you want shared sequencing for some interoperability or easier ways to launch your rollup, you can do that as well. Maybe you want some MEV alignment. You can do auctions. Maybe you want some intents, whatever have you. Or maybe you want this economic security, although we just covered why this might not be the best idea. And then generally, you can have a ton of different type of CKVMs that are generally open source that you can use as well. Now, as mentioned, the apps are not quite here yet, but it does seem to me that they're actually on their way. We're having this mass commodification. We're seeing things like light nodes and wallets, which means we can increase the amount of light nodes that are sampling blocks, and as such, we can increase the size of them. We're getting things like CK accounts on Celestia, which will enable some really, really cool use cases as well. Chain abstraction is coming to the modular setups as well, which will make utilizing different types of setups throughout these modular rollups a lot easier too. And we're seeing an incredible amount of outsourcing. So no longer do you need an application. If you want a rollup to do all this work yourself, you can simply outsource these to other people as well. And what we're seeing is sort of this rise of these global state layers and things like storage providers that are creating this state and liquidity uniformity, also driven by intents as well. And if we look at Selenium, which is a great block explorer where you can see data posted to Celestia, you can see that the amount of apps here are actually growing. So you have things like Orderly, Avo, and so on and so forth. And I expect this to grow a hell of a lot more over the next couple of months as well. Now, as mentioned earlier, we probably need some kind of base setup specifically for applications like a Uniswap. And the reason for this is that specifically Uniswap needs to be able to make synchronous calls to L1s, and other applications need to be able to make synchronous calls to them as well. And this is because a ton of applications depend specifically on Uniswap for the application. This could be intent-centric ones. There's also just a lot of people just calling Uniswap smart contracts. The same goes for a Maker or an Aave as well. And there's generally a spectrum with these base rollups. So generally, either we need based execution. This is a lot more difficult because it's very hard to scale this up on a decentralized blockchain like Ethereum, for example. So generally, the way this is going to happen is probably going to be some sort of based inclusion, where you have inclusion guarantees from the validator set of Ethereum, and you might get these super builders that are building or buying flow for these rollups. And this would be extremely, extremely powerful. And what happens when you are included in the same block as all the other transactions that are happening on Ethereum is that you can start to have these synchronous calls. You can actually start to have these auctions to extract MEV. And this means that these super powerful, super cool applications can now start to internalize this MEV revenue that they're creating instead of giving this away. But it also does mean that we're going to have these super builders. And these super builders are already extremely powerful. We have 3 major ones on Ethereum that are generally building most of the blocks that we're getting. This could probably get even worse in sort of a base rollup world where we might have maybe a Beaverville building for 15 rollups, maybe an Rsync building for 14, but because these 15 rollups are creating more MEV, they'll not be able to win every single Ethereum block building bid, which is pretty problematic. And generally also now, the Ethereum block times are quite slow, so 12 seconds. This is pretty bad UX if you're depending on this, so we might need things like pre-confirmations as well, so you won't have to wait for 12 seconds before your transactions get pushed through, which makes it pretty unusable for most applications. Now, as many have been saying over the last couple of months, is that it seems like most people are essentially building the same thing. We're seeing these auctions for flow and write to sequencing. We're seeing base rollups come out. And we're seeing this hyper-specialization specifically on these modular setups, specifically on application-specific ones. And what this is causing is that we're seeing also this on shared sequencing. We're seeing this on things like Suave. And essentially, the cause of this is that many of the things that we realize we have to build, everybody else is realizing the same thing. So it seems like we're all in a world where the things that we are calling different things are actually the same thing after all. But it's probably going to be extremely exciting when we get these base rollups. And it's usually going to be happening out of protocol first, especially in these extremely large decentralized setups where we talked earlier about the fact that it's very difficult to make upgrades, and you need a lot of people to agree on these things. So generally, things like base rollups are probably going to be happening together with pre-confirmations out of protocol. We might get this coming to in protocol, but it might take a couple of years for this to actually happen. But it's probably a world that's going to be quite cool for you like Uniswap. We heard Ken yesterday. One thing I do want to touch on before we end here is the fact that it seems that we need to take this idea of global state further if we want to keep this synchronicity. And sort of go for this idea of a protocol to a state. Because if these global offset laws are completely different from rollup to rollup, we might want to set up where we have state that is sort of uniform in the laws that they have. So think like a Solana account model, and having these state laws being the same from rollup to rollup, maybe on like a uniform layer, maybe with super builders in this case. And this would make interoperability extremely, extremely easy. And that's all for me today. Thank you so much for having me.
Maybe any questions from the audience? No questions? Then another hand for Mats Matthiessen. Next up is going to be Harry Halpin from NIM Technologies, speaking about modular anonymity. Let's give a big hand, everybody. Big hand for Harry.
Thanks for waking up so early after the big party last night. Okay, so I'm going to present modular anonymous networking, what it is, why it's important for the future of modular blockchains, including Celestia. And the general concept is that we can add noise to data to make it unlinkable. And so even very powerful adversaries are easily defeated. So what most people don't think about, you can think about your execution level, you can think about your data availability level, and these are all great, but the Achilles heel of every single blockchain project is actually this often very 90s peer-to-peer protocol, which no one really bothers to look at. And having that protocol work properly is just taken for granted. But actually, in reality, it's very easy to monitor and attack these protocols. Machine learning in particular makes it trivial to look at your traffic, establish a unique fingerprint for what you're doing, either if that's web browsing or data sampling, identify your node, and then basically either block that node, like a denial of service attack, or make that node believe something that's not true. And that's quite dangerous. And luckily, there is a solution. Even though the internet was not really built with security or privacy in mind, with TCP/IP and UDP, we can add what's called an anonymous networking layer, sort of a modular, better networking layer to the existing network. So we built something called a mixnet. What a mixnet does is it adds noise. It's like a noise-generating network to obfuscate patterns in the network traffic. It does this similar to a VPN or Tor by adding multiple hops to the traffic, but also, quite importantly, adds application-specific noise, which you can think of as like fake traffic or dummy traffic, which scrambles the peer-to-peer or other network patterns. And then timing obfuscation. What that means, because it's a mixnet, is that the traffic at each hop, we'll illustrate this in a second, is mixed together with other traffic. And just like you can use different execution layers and different consensus algorithms, you can take mixnets and you can tune them to your apps. Let's say I don't really care about being anonymous, but I want to hide my IP address. I can scale that mixing down, and I can make it much faster. If I really want to be anonymous, I can take a hit on latency and add more mixing. If I have a lot of bandwidth, I can add more noise. If I have less bandwidth, I can add less noise. But the general lesson is, no matter what you want to do, the existing peer-to-peer networks are a bunch of shit, and you can actually add in something like a mixnet to strengthen your network, including your peer-to-peer network, including, importantly, making that traffic unlinkable. So that means that if I send out traffic, I'm, let's say, checking data availability sampling, the particular peer or light node client, which is doing that data availability sampling, cannot be linked by an adversary back to its network traffic. So you can basically link, check, be unlinkable, and check data availability anonymously. The same holds for email. If you were going to use an email with a mixnet, I want to send an anonymous email out. That's what the original cypherpunk use case was. You can't link that email back to the sender. And even an adversary as powerful as the NSA with all their AI technology who's watching the entire internet with a kind of godlike view, couldn't effectively do that linking back. So this is what it looks like. You have your kind of standard VPN down here, which is shoveling traffic back and forth. And you'll notice that the packets have like different sizes and times. Like you don't send all the packets out uniformly when you use internet. Internet traffic is bursty. And in that way, your traffic unfortunately kind of leads you to have a unique fingerprint. That's used to identify you and link your traffic to your computer, which website you're going to, even if you're encrypting the data using TLS, so forth and so on. Same with Tor. So Tor is obviously better because it's not centralized, although the directory authority is. But Tor kind of works like a 3-hop VPN. But you can see the packets still have that same pattern, and that's quite dangerous in terms of trying to make your traffic anonymous, or as I prefer to say, unlinkable. What you can see what NIM does, which is a bit different, is the traffic comes out your computer with that pattern, but then it's shipped through layers of what we call mixed nodes. And those mixed nodes, we add this kind of noise into the traffic, and the mixed nodes delay the particular packets. So you can see all the packets come out the same size and looking the same. And that's quite cool. And this works today. So we're going to talk about data availability and noise generating mixed nets. So if you're on the Celestia research forum, you can read this nice little thing by Dimitris Karakostas, I think, a research post on what's called a selective disclosure attack. So the selective disclosure attack is quite dangerous. I'm running a Celestia Lite client. I'm randomly sampling the network, the data. Via the network, I'm randomly sampling the network using these erasure codes. But someone could be watching the network or watching my computer, and they can basically cause me, even if I'm honest, to either believe an unavailable block is available, or a block which is unavailable is unavailable. And you do this simply by monitoring the IP address and censoring or altering the network flows. And you can see that it's really easy to do. This attack has a pretty high probability of succeeding if there's like not many queries. And the more queries you do, you assume that you can get by the attacker. So it's a pretty dangerous attack, and it really effectively destroys a lot of the value proposition of data availability sampling, which is obviously a cool technique. We want to keep using data availability sampling. And so Mustafa, who I've known for many years, has another cool blog post on Celestia Research called Security Levels of Data Availability. So I'll just summarize it briefly. Mustafa has much more detail in his blog post, but effectively says there's different levels of data availability sampling. And if I'm just like copying the data from a full node or just sampling myself, it's actually completely insecure because the statistical disclosure attack can basically make me lie even if I'm honest. So it's sort of pointless to even do the data availability sampling. So he said the simplest thing you can do is you basically have to have a committee, and that committee kind of gets consensus on data availability. But the problem is, how do you prevent the committee from lying? So you need slashing or some kind of cryptoeconomic security with the committee. He considers that level 2. But slashing with a data availability committee doesn't work too well because of this thing Mustafa calls the fisherman's dilemma. So what he recommends that you have to do basically, rather than a data availability committee, this is what most people assume now, we do kind of an honest minority of light nodes. But if you don't have that group of light nodes, and what you need is an unlinkable data availability sampling. And unlinkable data availability sampling, how do we do that? So the unlinkable data availability sampling says that all these techniques can be attacked, so we really need to make that sampling unlinkable so an adversary can't like zoom in on my light client and either knock it offline, give it fake traffic, give it a fake view of the network. And we need to make that traffic unlinkable, and that's why we need what we just described, a motherfucking mixed net. So here, this is kind of how data availability sampling works. So I have all my light nodes, you have Alice and Bob, and they're going through this peer-to-peer network, which everyone kind of forgets exists, and they're sampling the block, and they're continuing to do that. And what you can do is you can put a mixed net in between the light clients and the peer-to-peer network. We already do that with Monero, we do that with Bitcoin, we do that with libp2p and Ethereum validators, and there's no reason the mixed net can do that with Celestia. We haven't done the integration yet, but it should be fairly straightforward. And effectively, you just put the mixed net, again, between the light node and the blocks, and that makes particular light client sampling unlinkable. And what's like the property you want, a bit more formally, given a query for the same recently disseminated block, an adversarial server cannot tell which user it belongs to amongst a set of users who were recently made aware of that block. And that's this is from another blog post, Evaluation of Private Networks for Bypassing Selective Disclosure Attacks and Data Availability Sampling. And while I like Dimitri's first post, this post is completely wrong because essentially Dimitris just read a bunch of papers and didn't look at any running code. So he's kind of like confused how the papers work. So he's like, well, maybe we could use Tor, maybe we could use this thing that doesn't work, maybe we could use an imaginary thing. And that's fine for researchers, because researchers can read papers and not actually look at code. But, as I'd like to point out, the NIM mixnet works today. It's solid Rust code. It's been running for like 3 years, used by quite a few people. You can use it today upstairs if you're interested. So we would recommend that rather than wait for something that doesn't exist to exist, or use a technique like Tor or VPN where you don't actually get that unlinkability, you would just use NIM there. And so you might be like, what is this NIM, and how can I use it today? So if you're interested in trying out a mixnet, Sarenko, raise your hand. This man will be upstairs on the second floor, and he will let you install and try out a mixnet. You basically get a free super VPN just for waking up and having your coffee and showing up at this ungodly hour. So what the NIM VPN is just the mixnet, but with a nice little interface on top of it. And it gives you the best privacy by generating noise to defeat, and it's a decentralized network, so you can run nodes and get NIM tokens. We're not going to talk about that here, but essentially you make noise in a decentralized fashion together, and that makes everyone more secure and more anonymous. And effectively, it works across all major platforms, all major mobile apps, whatever. You can just download it in TestFlight or F-Droid, and it's obviously more private than Tor, and has about 700 nodes, so you have a lot of places you can pop in and out. It's a real-world network. It's been running for a few years now, and looks more or less like this. So when you start up your phone and you want to use a mixnet because you want to really be anonymous, I don't want to know what exactly you're doing. Don't tell me. But if you have a reason to be anonymous, that could be something as innocent and completely legal as data sampling. You just click mixnet, and you're super anonymous. And if you're like, oh, I want to download some videos, I want to be faster, like I said, you can turn the mixing off, and you can just click fast mode, 2-hop. And then you can choose, oh, I want my node to come in Sweden, because I like the Pirate Bay or whatever, and I want to come out in France, because, I don't know, I want to fool the French government into thinking I'm coming in France. Most people probably go to the US for Netflix or something. But you can basically choose exactly where you come in and out, and you just hit the connect button. Now, it's not available to the general public right now because we're still beta testing it. We're still trying to get the network is solid, but there may be some flaws. It may be a little bit hard to install. With iOS, you got to like install it, turn off, turn on again. It's irritating. Some other minor issues, but most importantly, we of course, because it's an anonymous networking tool, we don't want you to log in with like your name or your username or password. So you have to log in with a zero-knowledge proof. And those are not public right now, but again, talk to Sarenko over there, and he will, up on the second floor, and he will hand you your own custom one-time zero-knowledge proof that you can use to log in. And the zero-knowledge proof shows that you're not a spammer, because obviously if you have an anonymous network, you can get a lot of anonymous spam. And then delinks your kind of identity, which is given via zero-knowledge proof, from your usage of the network. You can download it now, but it won't work until you install that zero-knowledge proof, but feel free to give it a shot, and just talk to us. I'll be here afterwards, and we'll be happy to install it on your phone. I'll probably have to leave around lunch, but Sarenko here will be here all day. And again, I want to just end with a note that this is really like mixnets, noise-generating mixnets are a really useful way to make any traffic secure and anonymous. If you read academic papers, it's called an anonymous channel. For many years, people have just assumed that they exist. You assume it exists with data availability sampling. Zcash, you read the Zcash paper, it says, oh yeah, just assume it's all running over a mixnet. But they haven't existed. So we spent many years building one, and you can use it for not just a VPN, you can use it for data sampling. It works on WebSockets. You can install it on web pages. If you're living in China or whatever, it might be useful for accessing the internet. All sorts of stuff is going on with it. So I do recommend, if you're interested, just talk to us. We're happy to show you the full plan. But just so you know, we were testing it mostly in Ukraine, Turkey, Germany, so forth and so on. We launched the beta chaos of the VPN app at Chaos Computer Congress last year, which is an awesome place I used to party with Mustafa at back in the day. And then we have launched the alpha testing, so it's not public. But if we don't build on Polkadot, we do coordinate the mixnet using a blockchain. We use Cosmos, and we're interested in continuing to make it more modular. But we are going to launch at the Web3 Summit the kind of paid usage, so you can download the VPN, pay for it using TIA tokens or whatever, and that's awesome. And then you can basically, that TIA token or credit card just lets you use the network for as much as you want and converts and pays the decentralized nodes using NIM token, which just kind of does a little conversion between. And then we're going to kind of launch the whole thing, including a lot of focus on making it more censorship resistant against the Great Firewall later this year. So you've got a few months to just play around with it, and we'd love your feedback because we know we have a bunch of awesome hardcore hackers today. So again, VPN information here, general information about the mixnet here. That's our Twitter. And we're also, all the code is free software. It's on GitHub. And just contact us. We're around all day. Hope to see you. I love Mustafa. I'll just tell you a funny story, because I have a minute or two. So back in the day, we were like, I wasn't working at NIM. I was a research scientist, paid for by the French government, because the French government was like angry about all the Snowden surveillance. They were like, build us something that can defeat even the NSA. I was like, okay, we can do that. And I was working with a professor called George Denises. And I was always interested in anonymity and supported political prisoners like Julian Assange and whatnot. And and I was at this solidarity dinner for this group called LulzSec, because I knew some of the LulzSec people. And I met I was like, oh, that's this. I never met quote unquote T-Flow before. I met T-Flow at dinner. And I said, oh, so you're not in jail unlike everyone else because you're too young. What do you want to do with your life? And he was like, I would like to do a PhD in like blockchains and decentralization. I was like, oh, that's a good idea. Like I did a PhD. I support young people, rehabilitating themselves from a life of hacking and crime by doing a PhD. Did so myself, support younger people doing so. And I said, well, who do you want to do the PhD with? And he said, oh, George Denises. I was like, ooh, I'm staying on George Denises' couch because I'm a broke academic. And so I go back to George's house. I said, motherfucking T-Flow applied for a PhD with you. And I said, Mustafa, like, did you write that you are T-Flow from LulzSec on your PhD application? Oh, no, I didn't. So we had to go through the PhD applications, find Mustafa. So I was like, that's T-Flow. You should definitely, he'd be a great PhD student. And he had a great record, so he got in regardless of my commentary, but it definitely helped bring it to attention and did an absolutely wonderful job on his PhD, which led us to the wonderful world of Celestia. So I'm very happy to see all these things work out 7 or 8 years later. And everyone's doing awesome stuff. So I can't wait to see what you guys are doing. Any of you do need a PhD in sketchy anonymous technology or decentralization, do get in touch. I'm happy to help out there. And to answer any questions, because we have about a minute. So any questions? Go for it.
Great talk, and a very cool anecdote as well. In the mixnet with the noise creation, does that create a significant amount of latency into the system, for example, for sampling?
It depends, right? So how paranoid are you? So if you just basically turn off the mixing and you have a lot of bandwidth and you just add noise, the cryptographic operations only add 500 milliseconds, right? So I think Celestia's block time is like 30 seconds. So that's kind of barely noticeable. If you want to be more anonymous, we recommend you ramp up to about 7 seconds of mixing. And if you want to be really, we don't tell you can be as anonymous. The more you mix, the more anonymous you are. But it's not quite that simple, because also, you remember, you can only be anonymous in a crowd. So if there are many, many different people using a network, you actually can be faster and more anonymous. And if no one's using the network, you just add more noise. So that's how it works. Last question, and I think we have to run.
Yeah, other than the latency, what sort of like resource overhead do you think this introduces? Let's say the Celestia network wants to sort of subsidize people actually using the mixnet for accessing DA sampling.
I mean, right now it's free. We would love for you to slam our network with lots of data sampling traffic. And if it really gets out of hand, yeah, someone will have to pay for it, but then it's like tiny network fees that basically would be. I think we calculated that if all of Celestia was like slamming our network right now, this is the existing Celestia, I think it'd be like, it's like $50 a network fee, so it's like pretty small. The hard thing is actually doing the integration of the current mixnet against Celestia. So it does work over SOCKS 5 and some other like proxies, WebSockets, but we have to glue it together a little bit.
Awesome.
Rock and roll.
Yeah,
Come upstairs. You get a free hat like this if you can install the VPN.
All right, thank you very much, Harry. Thank you. Round of applause. And next we have Ryan Quinn Ford to talk to us about E2E encryption on Celestia.
Good morning, everybody. I'm Ryan. What's this? Oh yeah, clicker. Need that. Thank you. So I'm here to talk about end-to-end encryption on Celestia, or how we can fix it. Before I get started, I'd like to say I'm actually giving this talk on behalf of Sebastian Pusch, who couldn't make it to the conference, but he's been leading this internal effort and has written the vast majority of the code, so you'll all meet him soon. But what am I talking about? So we all use these end-to-end encrypted chat apps like Signal and WhatsApp, and we see ads about them all the time about how secure they are. I mean, WhatsApp, iMessage is also end-to-end encrypted. There's Signal, but they all have a problem. So these services generally consist of two components, if you simplify them down. There's the messaging server, which is actually, there's nothing wrong with this. So only encrypted messages ever hit the server. They can't read anything. Signal doesn't collect any metadata. That's all fine. But they also consist of a key directory, because if you want to talk to me over Signal, you need to ask Signal what my public key is. And there's no cryptographic guarantee that the person you're actually talking to then is me, because Signal could provide you with a key directory that they don't provide me. So they provide you a Merkle proof that you are talking to my key, but they could also just give me a entirely different tree, and I verify this Merkle proof, and it doesn't mean anything. So why would they do this? They can do a machine-in-the-middle attack. This is what the UK government proposed in 2018 with Ghost, and it's pretty malicious. How does it work? Well, this is how it works in a trustworthy service, so this is what we kind of expect. If Bob wants to talk to Alice, Bob requests Alice's public key from the key directory. The key directory returns Alice's public key. You encrypt your message with your public key, and then that gets relayed to the message service. Then the message gets relayed to Alice, and then Alice can decrypt it, of course. And the machine-in-the-middle attack that they can do is really trivial. Instead of returning Alice's public key, they return you one of their own key pairs. And then when they get the message, they can simply decrypt it. And so in the best case, this is just eavesdropping. They can read all of your messages, they decrypt the message, but they can also modify the message. And so when they get it, they decrypt it, then they just encrypt it again with their public key, with their real public key, and she can decrypt it. And if you know a little bit more about the Signal protocol, this works pretty much the same with double ratchet. It's left as an exercise to the reader. So yeah, this is a huge problem. But don't worry, guys, they fixed it. Everybody knows about these things called security numbers. I mean, maybe you haven't seen these screens because nobody actually uses them. But you probably have seen when you're using these apps that your security number has changed with a person. So what does this actually mean? You might know, I mean, there are engineers here, but general public does not really understand what it means. And so they fixed it, but they didn't really. I mean, The issue with this is that it doesn't scale. There was a study done in 2017 that only 14% of users were even able to find the security number in the UI after previous education of what an authentication ceremony is. They were able to find the information after, I think, 4 minutes, and then complete the ceremony after another 5. And they still had no understanding of what this even did. I mean, really what you're doing is comparing that the Merkle root they gave you is the one that they gave your conversation partner, and you have to do this in real life. You need a third trusted communication channel to do this, and they recommend that this is done in real life, of course. It's the only true third trusted communication channel. And what if you're on the other side of the world? You can't really verify it with them. I mean, you also can't verify it over Signal, of course, because they can just modify the messages, like I said. So this is a huge problem. And so this means that all current end-to-end encrypted messaging services are not trust minimized at all. You're needing to trust the service provider to provide you with the correct keys to the service provider. We can look at a few examples here. There's Keybase. Keybase is pretty interesting. They actually write the Merkle proof and all the operations to this key directory on the Stellar blockchain. But the issue is that the client does absolutely nothing with this information. And even if it did, Keybase would just be running some RPC to Stellar that you're then needing to trust when they serve it to you. So you're not actually getting rid of any trust assumptions. I mean, technically, Keybase is then unforkable, whatever that means, but they can still trick single users that they don't expect to check this. They provide like a script you can run on your computer to kind of verify against what they post to Stellar, but nobody does this. They can still trick you. Yeah, and WhatsApp is a little better. They spent a lot of money in researching this problem space, key transparency, and have some custom solutions. They have something called the auditable key directory. They publish audit proofs to Amazon S3 bucket, which obviously isn't that much better than, well, it's obviously not better than Stellar, it's a bit worse. But the client also does nothing with this information. So they can still trick individual users. And even worse, WhatsApp is closed source, so you don't even know what they're doing. And yeah, so not really any better than Keybase. And the protocol that everyone's probably interested in here is Signal. What does Signal do? Signal's the best end-to-end encrypted messaging app, right? The issue is that they have absolutely zero solution for key transparency. They don't post it anywhere. You have absolutely no idea what Signal is doing with like where the Merkle roots are, what they're serving you. At least they're open source. The social consensus is, of course, that we can trust Signal more than WhatsApp. But from a purely technical standpoint, you can actually trust WhatsApp's key transparency more than Signal. And this really surprised me, obviously. And iMessage is also similar. Like, they have zero key transparency. They offer security numbers, but they're worse than Signal and WhatsApp because they don't even show you that your security number with someone has changed. It's off by default. So yes, very bad. And so fuck Signal, fuck WhatsApp. All my homies hate unauthenticated end-to-end encryption. It's really terrible. It's really a problem that needs solving. So what do? I mean, in order to talk to someone over the internet, you shouldn't need to verify a security number with them in real life, especially if you're not an engineer and have no idea what it's doing. Like, this is terrible UX, and everyone uses these apps. Everyone should be able to have the right to talk to someone securely over the internet without needing to understand some obscure cryptography. Well, it's not obscure, but for them it's obscure. So end-to-end encryption doesn't cut it. We need authenticated end-to-end encryption, and by default. And so how do we solve this? So the question is more like, what does an ideal key directory need? Well, one of these things is if your client needs to be authenticating or verifying proofs, like for example, I said that WhatsApp posts proofs to an S3 bucket, you need these proofs to be small. You need low bandwidth to the chat client. The compute overhead needs to be small. This is also a big problem because WhatsApp, for example, they post tens of thousands of Merkle proofs per minute. And obviously your chat client cannot keep up with this, let alone then verify the proofs. And then you also need somewhere to post this. So instead of AWS or Stellar, you should probably post it on a DA layer. And while you're doing that, you actually can't trust an RPC, like I said before, because the service provider is probably also running this RPC themselves. And then it doesn't get rid of any trust assumptions. So you should integrate a node that can communicate directly with this. This key directory should also be WASM compatible, the client at least, well, the client, so that you can build it into web apps easily. Everything that needs an identity layer, which is kind of what a key directory is, zoomed out, are mostly web apps. And these chat clients are also all web apps. So it needs to be WASM compatible. And most importantly, it needs to be abstracted away completely from the user. Users should not need to care at all about this. They shouldn't need to do any ceremony. They should just be able to chat with someone and see that their connection is secure, that they're auditing this service provider, like basically just a check mark or a red X if you're not caught up, something like that. So the good news is that it's real. So this is how we solve it. Every epoch, so this is like a block for us, like a minute or so, you generate a snark over all of the operations that were done in that epoch time. So instead of tens of thousands of Merkle proofs, you have one succinct proof that's very small. We don't really care about the ZK property here. I mean, you can use it for other things. If you're interested, you can talk to me afterwards. But the main point here is that you have a really succinct proof. And then we publish that snark to Celestia. The WASM client that we have just downloads that snark directly from the DA layer, verifies it. And what this means is that just by running a light node in your chat client, you are automatically verifying the service provider, and you no longer need to trust them. It's user verify, and it's by default. So this is really nice. So this is kind of how it looks like. Essentially, Signal publishes the user's keys to the key directory. Your app talks to Celestia to download the snark, verifies the snark, and then it knows that the keys it gets are real, and so they can trust the messaging server when they send messages that they're not going to be able to decrypt them, that they're not their own key pairs. But you can actually take this one step further. So you could even make a global identity layer out of this, right? You could say that all chat apps use the same key directory, because right now they all have their own. They all have their own Merkle tree of public keys that is siloed off completely from the rest of the world, can't interact with them. Signal developer like Moxie says there's no place for this in the modern world. There's no reason to have a blockchain, but this is obviously bullshit. And their reasoning, of course, is that their infrastructure costs are very high. They can't allow access from third-party clients, but this would allow third-party clients to interact. And these are just messaging apps, but there are tons of other uses for such an identity layer, and they can share it, which is really nice. So some use cases. Obviously, in this talk, I focused on authenticated end-to-end encrypted messaging and file sharing, but the whole web actually runs on certificate authority. So for all TLS connections, everything, you have a certificate authority saying this server has the right to advertise themselves as this website. And certificate transparency, which is what key transparency came from and what this runs on, runs on this assumption that there are some big companies that are running full nodes that are monitoring the certificate authority's behavior in their own trees. But you could technically just integrate the client into the browser, and you no longer need to trust the certificate authority. In fact, you don't even need to call it a certificate authority anymore, because it's no longer an authority. You don't need to trust them. You could automatically be verifying them. You can then also kind of make a crypto-native alternative to Keybase. You could link social profiles together and make identity proofs. This is really nice because next time Mustafa writes you on Telegram, you can just simply click on his profile and see, okay, this is a scam. He doesn't have his Twitter profile linked and this and this and this. This would be obviously very nice. You can make a key store rollup, which is a big topic right now. Has been a topic at this conference quite a bit for cross-chain key and identity management to improve UX in our ecosystem. And there are other emerging technologies right now, like TLS Notary, that you can integrate with. This is really cool because then you can make a proof that you have some ownership over a resource on the internet and only trust a notary. And this is better than even if we just build into an encrypted messaging on top of it, because you're still needing to trust somebody to do, for example, the phone number registration. Like it's still a centralized anti-Sybil mechanism without TLS Notary. And you can also use TLS Notary. We can make an instance of TLS Notary ourselves where you can prove selective information about yourself from the server and without disclosing everything about your identity, and that's really nice. And then you can also, like I said earlier, use the ZK property of the snarks if you have a second instance of this key directory to do some pretty nice privacy-based applications. So how far are we now? We actually have already finished the stage 1 sequencer and prover. The light client's finished. The WASM client is like a week out from being done. We're just trying to get some PRs merged. State access is still whitelisted because the API sucks right now and it's really immature. But yeah, and we actually are already live on Mocha on Celestia. There was no announcement. We're just engineers. We kind of need some marketing help, but we have a testnet already. And so this is really nice. You can already use it. You can already verify our key directory live with our client. So yeah. But this isn't actually enough still. So right now we just post the snark to Celestia, but this creates some attack vectors. It's not very decentralized. It's not really helpful for services like Signal because they would still all have to use this API to get the state from one of the servers, so we need to enable full nodes. By doing this, we just post all the operations to a secondary namespace in Celestia, and this would enable these apps to run their own full nodes that have the state that can serve their own technology stack. It enables future prover decentralization in case prover marketplaces end up not being a meme. And it also provides censorship resistance, of course, some other stuff. So that would be stage 2. There's further stages, but that's kind of the idea we have going forward. We also need contributors. We're a public good. We have no funding. We cannot pay you. Please come help us fix things anyways, please. This would be nice. Yeah. If you have any questions, you can find me on Signal or Twitter. We're on Twitter as well, on GitHub. Yeah. And I will also post some very interesting papers and blog posts if you're interested further reading. This one specifically, the Hey Signal, great encryption needs great authentication, is amazing. Everyone should read that and offers very good insight to like even current culture around signal development and why this is a problem, how much of a walled garden it is. Yeah, that's it. Thanks everyone for coming, and yeah, I'd love to answer some questions.
Yeah, thank you, Ryan. So we have time for one question. Does anybody have one? All right, another hand for Ryan. Thank you very much. All right, and next up, you might not recognize him, but I promise you, this is Nick White from Celestia, rocking the mullet, and I believe we're here to talk about sovereignty. So, sovereignty. Thank you, Nick.
Thank you. What's up, guys? Good morning. I'm stoked to be here. I want to talk to you guys about sovereignty, and I want to explain why sovereignty isn't some, techno mumbo jumbo or some philosophical thing, but actually a really key feature for building powerful blockchain applications. And I think it's going to define the next era of blockchain infrastructure. So lately, there's been no shortage of FUD about the modular stack on Twitter. You have people saying that modularity is just an excuse to issue more tokens, that there's more infrastructure apps and L2s than there are users or even applications, right? And meanwhile, in modular land, we are debating the definition, the semantics of what it means to be a sovereign rollup. And the result is that we get dunked on yet again Mert says, no one gives a shit about your dumb nerd lingo and politics. If you're so smart, build something people want. Now, actually, I think that there's a synthesis here, right? Which is if you think about this phrase, build something people want, right? The people are users, right? So who are the users when it comes to blockchain infrastructure? Well, the users are developers, right? So we should be building something that developers want. And what I want to convince you of today is the fact that developers want sovereignty. And the reason that they want sovereignty is because sovereignty is equal to power. And when you give developers sovereignty, they have the ability to build better applications compared to your normal standard crypto developer. So to introduce this concept, I'm going to borrow something from psychology, but adapt it to crypto. So instead of having Maslow's hierarchy of needs, we have the crypto application developers hierarchy of needs, right? And the idea here is that there's a core set of needs that a application developer has to have fulfilled from the infrastructure they choose to build on. And the infrastructure that fulfills these needs the best is the one that they will choose to build on. So at the bottom here, we have security, right? So this is about verifiability, censorship resistance, liveness, all the things that you expect when you're building an application on a blockchain. If you don't have these things, then what's the point of even building Web3? You should just build a Web2 application. Next up, you have composability. And this is about distribution and interoperability. So you don't want to build your application in a vacuum. You want to easily onboard new users and liquidity, and you want to interoperate with other applications people have built. You also have user experience, right? So depending on the infrastructure, it can either be slower or faster or costly or cheaper, and that impacts the user experience of your application. And finally is developer experience, right? Developers are really lazy. We all know that. They want it to be very easy to build and deploy and maintain their application. And I think that so far in the history of blockchain infrastructure, we've been focusing on solving these 4 core needs, right? And Solana, if you think about it, does an extremely good job of solving these 4, right? It has a very secure and decentralized validator set. It has really good composability out of the box with the entire ecosystem, really good user experience that's fast and cheap. And the developer experience in the SVM has really improved and is now the second most adopted platform after the EVM. Right, but the thing is that there's something missing here, right? There's yet one last need that has not been fulfilled, and I think will define this next era of blockchain infrastructure, and that is sovereignty. So by sovereignty, I mean specifically customizability and economic ownership. And this is where, of course, rollups and the modular blockchain stack come into play. So as far as customizability, what I mean is that you want to have the ability to control and customize the infrastructure stack, right? If you're building on something like Solana, all these decisions have been made for you that set certain constraints and define aspects of your application. When you build a modular and you use a rollup, you have a whole menu of different components that you can choose from to mix and match and build something that's really custom, tailor-made to your application. And then when it comes to economic ownership, I mean controlling the value that your application creates. Right? So aside from just capturing the base level application fees, there's also the congestion or execution fees and MEV. And when you build a rollup as opposed to a smart contract, you're actually able to capture those fees. And this is like a very significant amount of money, right? The top L2s on Ethereum make millions of dollars in monthly revenue. And even if you look at Solana itself, it makes millions of dollars in daily revenue. And 90% of that is MEV and congestion fees that actually could be and probably should be captured by the applications that are generating it. And so rollups give you these 2 really powerful properties of sovereignty, but the issue is, of course, composability. So we all know that there's a significant amount of fragmentation in the modular stack, because when you deploy a rollup, you're deploying fundamentally a new blockchain, right? And so in order to interoperate and onboard users and liquidity, you need to go through bridges, and bridging UX sucks. And frankly, it's just not very secure. And that's why L2s exist, right? The benefit of an L2 is that you anchor into an underlying L1 that has a ecosystem of users and liquidity and things like that you can easily onboard. So you get better distribution and composability by enshrining this bridge in the L1. But the thing is that L2s are just fundamentally not fully sovereign. So there's actually more to the sovereignty story that we haven't covered yet. And that is specifically 2 things: technical independence and social independence. And this is where sovereign rollups, as opposed to L2s, come into play and give you this additional power, right? So what do I mean by technical independence? Well, when you build a sovereign rollup, as opposed to an L2, you make very minimal assumptions about the underlying L1, right? You just treat it as a dumb, simple DA layer that you publish data and you retrieve data from, right? And this means that you have really minimal switching costs. Like you can just point your chain to a different layer in case that underlying L1 that you built on fails to scale properly, right? So then it becomes more expensive. Or maybe that L1 tries to extract more value, right? It gives you more power in this relationship of the infrastructure that you've built on top of. And so you minimize your platform risk, as opposed to an L2 where you are actually part of the application, like the logic of your application, your rollup, lives on the L1. There's like a much tighter coupling. And so you can kind of think of this as a double-edged sword, right? When you deploy an L2, you do get the upside of composability, but then you're sacrificing, you have greater lock-in that kind of limits your power in the relationship. And then next is social independence, right? So an L2 is specifically has the canonical chain of your rollup is defined by the bridge that's deployed on the L1. And that means that you can't fork independently of the underlying L1. And forking and via social consensus is actually a feature and not a bug of blockchains, right? It's all about, blockchains derive their legitimacy from the social consensus of the community that uses them. And when you build an L2 as opposed to a sovereign rollup, you are sacrificing that ability. And then next, social independence is also about the community culture and brand, right? When you build an L2, you are associating yourself, affiliating yourself with the culture, community, and brand of the underlying L1, right? You're an Ethereum L2, or a Solana L2, or Bitcoin L2, right? And fundamentally what that means is that you are inheriting and sort of tying into this pre-existing community culture and brand that kind of limits you from being fully independent and owning your community. When you're a sovereign rollup or a sovereign chain, that the community is yours, right? And you have sort of this separation, this clean separation of your brand and your culture. And it sounds kind of silly, but we're actually already seeing this happen, for example, in the Cosmos ecosystem, where there's a lot of chains that are built using the Cosmos stack, but they specifically don't want to identify as Cosmos chains. They want to identify just as themselves, right? As DYDX. And so I think Antonio actually articulates this really well when he says apps should transcend any particular technology they are built on, right? He's talking about social sovereignty. But then the issue with sovereign rollups, right, is that now we've given up that composability benefit of L2s. And if this weren't solvable, then they might not be viable. But fortunately, there's a whole movement called chain abstraction that is solving composability and solving the fragmentation of different rollups. And there's tons of different projects building. There's different bridge interfaces, there are bridging providers. There are asset issuing chains like Noble. There are intense protocols. There are APIs like Skip that kind of integrate this all into one easy user interface. And the promise here is that we can have this modular mullet, right? That's why I'm wearing the mullet wig today, which is that we can have this unified, seamless user experience on the front end, powered by chain abstraction, that abstracts away all the complexity and fragmentation of the underlying modular blockchain backend. And so what's happening here is that modular blockchains and the sovereignty that they enable are teaming up here to provide developers with the power to build sovereign, fat applications. And when I say sovereign apps are fat apps, what I mean that in three specific ways, right? The first is that sovereign apps are fat apps from an infrastructure perspective, right? They don't just control their application logic like a smart contract. They have a say over every single component in the stack. So they're owning significantly more here. Sovereign apps are also fat apps from an economic perspective, right? They're not just capturing application fees, but they're capturing way more of this economic stack, the MEV fees and execution fees. And last but not least, they're fat apps from a social perspective, right? So they own their own social layer, and they own their own independent community and culture and brand. So really the vision of the modular blockchain stack at the end game is that we can create a world where every developer gets to have their own fat application, right? They can have as much power, and their application can be, like super powered. And now there's two like main criticisms to this vision that I'm laying out, right? The first one is that people often say, well, if you want to maximize sovereignty, why not build an L1 with the Tendermint and the Cosmos SDK, or maybe Avalanche, or whatever other toolkits exist to actually build an L1 instead of a rollup? And the answer to me is that the trade-offs are likely not worth it, right? You could argue that you have more technical independence because, as an L1, because you have literally you fully own top to bottom your whole infrastructure stack, and you are not relying on any external protocol. Some people argue you have better customizability, but I kind of struggle to think of applications that you can build as an L1 that you can't build as a sovereign rollup or rollup. But you end up, so those are the pros, which are minimal, and then you have this really massive cost when it comes to developer experience, right? So instead of something that would take you maybe a few minutes or a day to choose all these modular components off the shelf, plug them together, and deploy it, now you're talking about something that is literally a multi-year endeavor to bootstrap and launch your own consensus network, your own proof-of-stake token, and trust me, like launching your L1 is not a simple thing. And last but not least, when you're in L1, you sacrifice a specific aspect of composability with other applications, which is trust-minimized interoperability. Only rollups that share a common DA layer are able to have this advantage. So you're also kind of like distancing yourself from the rest of the blockchain ecosystem by being in L1. The next criticism of this vision is that modularity means that there are more middlemen, right, and more extraction. Because if you think about it, you have more protocols, each of which wants to take its own cut, right? Take its own pound of flesh from the application and from the developer. But if you actually examine this, you realize that the truth is actually the opposite, which is that if you wanted to have more power and more ability to extract and more leverage over applications, you would want to vertically integrate the stack and own as much of it as possible so that you could extract more value, right? And what's happening in the modular stack is exactly the opposite, which is we are making a competitive market for each layer of the stack such that the protocols that are going to win are the ones that provide the most value and extract the least value, the most developer and application aligned. And so it's really the opposite of what Tully is saying here. But then you might be wondering, okay, well, if modular chains are minimally extractive, right, then maybe they have no economics. Like, how are they going to be sustainable, or are they going to be valuable at all? And I think he addresses this really well by saying that even protocols that are minimally extractive can actually be very valuable as long as they produce their good and sell their good at scale, right? And this is really what modular blockchains are trying to do. They're very thin protocols that produce a very specific service, and they try to solve that problem at massive scale. And so if we take Celestia as an example of this, right? Celestia is a thin protocol to enable fat applications. It has very thin functionality. It just does data availability and consensus and tries to do that extremely well. And it's meant to be minimally extractive, right? So Celestia is trying to produce block space and make sure that block space is very cheap and abundant for everyone, right? But it wants to do that at maximum scale. We want to reach gigabyte blocks and even beyond, right? And last but not least is the ethos of Celestia underneath. What does this mean? It means that Celestia is not trying to be the main character. It's trying to play a supporting role and elevate the developers and the applications built on top. It's trying to empower them as much as possible, right? So Celestia is a thin protocol to enable fat sovereign applications. And zooming out, the three ecosystems we talked about today, there's a sovereignty spectrum that emerges, right? In Solana, all the applications are kind of minimally sovereign because they're meant to be built as smart contracts on a single global atomic state machine, right? So this is like minimum sovereignty. Ethereum's vision, and even Emmanuel came and gave a talk yesterday, is that layer 2s are cultural extensions of Ethereum, right? So they do want to give you more developers more sovereignty, but there's a limit. They still expect you to sort of like pay back and tie into the underlying social and technical layer of the Ethereum L1. And then we have Celestia, where blockchains, rollups, applications are considered sovereign communities in their own right? And these differing visions result in very different technical stacks and solving for very different needs for the developers, right? And I believe that in the long term, prioritizing sovereignty and the platforms that give developers the most sovereignty are the ones that are going to win. And so we're faced as an industry with this choice, basically, of like continuing to build monolithic infrastructure, continuing to build smart contract applications that fundamentally limit the power of applications and developers and the communities that use them. Or we can build modular infrastructure and build roll-ups, sovereign roll-ups, that give the power back to the developers and the communities and the applications where it belongs. And so to me, the choice here is very clear, and that is that we should build modular and be sovereign. Thank you.
All right, thank you very much, Nick. Do we have some time for questions? Does anyone have any questions? All right, well, I got one for you. So you talked a little bit about how building on Celestia gives this unique property that allows composability to be easier than, say, building your own L1. Can you talk through what about data availability is kind of fixes that composability problem that exists in L1 world?
Yeah, it's a great question. So in order to have trust minimized composability between two chains, whether those are rollups or L1s or whatever, you need to fully verify that the state of the other chain is valid. And the only way to do that, well, there's actually another thing, which is sharing consensus so that you know that the ordering of that chain is not going to change. But for the DA part, why that's important is that the only way that we know how to verify the state of a chain on another chain is via some kind of light node and light client, right? So you need to verify either a fraud or validity proof of the execution of that chain. And in combination with that, you have to verify that the data for that chain is available. So if your chains don't verify each other's data availability, then fundamentally you're stuck with making a trust assumption on the other chain. For example, that the validators on that chain, the majority of them are honest. And so long term, if we want to have truly trust minimized, fully very economically rich and varied interoperability between chains, they're going to need to share a DA layer and verify that each other's data is available.
The data availability, it expires, right? And it's gone from the Celestia blockchain. In that world, aren't you still just kind of trusting?
So yeah, so the question was, when the history of the Celestia ledger expires and is pruned, right, which is coming to mainnet soon, does that mean then all of a sudden you revert back to trusting someone? So this is a good question. This kind of gets to the difference between data availability and data storage, right? So in data availability, you're trying to make sure that this new data that's critical to the validity of the state of another chain has been published to the internet, right? And then, and so it's most relevant in the, when it's recent. When it's history, it's more about, okay, now making sure that I could recreate the state later. And the thing about storage is, so data availability is data withholding is about an honest majority being malicious and trying to fool you, right? So you have to actually actively verify it, whereas data storage is an honest minority problem. You just need one person to store that data for the long term, right? And once data has been available, there's going to be the archive node storing it. There's going to be service providers like indexers or block explorers, even maybe data providers like Dune, et cetera, who are going to have that data and serve it. There might even be a specifically just an archive service for Celestia that emerges, right? So it's an honest minority problem, so it's not really that dangerous.
All right, thank you so much, Nick. Another round of applause. All right, and next we have Adrian Brink. Here? Somewhere? Yeah. Oh, got it. All right, well, I don't know. Let me vamp for a minute while they set up the table. How you guys doing? Huh? Good? Yeah? Excited for the last day of Modular Summit? No? All right.
All right. Cool. Thank you, everyone for coming. Today, I'm going to talk about sovereignists versus globalists. And here you can also read globalists as effectively statists. So do you want to be sovereign, or do you want to be sort of in a single global security model? And I think fundamentally, the goal of the space is to be sovereign, right? Like, I think very few people came into the space under the idea that, well, we should all rely on the single one world government to control everything we do. It is rather, how do we give users choice about what kind of systems they actually interact with on a very specific day-to-day basis. And I would say that a single decentralized network, no matter how decentralized it is still centralized, right? Like, because we're still in this world of now we have a single failure point. And it doesn't actually matter whether the single failure point is sort of a single server or an actually distributed network of validators. Fundamentally, as long as you have one of something, this is a centralized thing that can be captured, corrupted, can extract rent, and sort of, I think a very good example for why this matters here is like, actually, yeah, just quick show of hands. Who here thinks that a one world government is a good idea? Great, one guy, -1. Fantastic. I like your honesty. This is kind of like if we do not design sovereign systems, but if we design a single decentralized network and then everything checkpoints into the single decentralized thing, we are still living in this one world government, because fundamentally our trust assumption has to be that hopefully the single decentralized network actually remains decentralized and remains capture free, but we have very little guarantees for this, and we have very little choice if something happens to it, right? So I think sovereignty is all about choice and giving users the realistic ability to exit a system. Yeah, so a single decentralized network is still centralized. From a physical perspective, and we'll talk about this sort of in the later half of the talk, I would hazard a guess, and this may piss a bunch of people off, that Bitcoin will not survive World War III. This is sort of like, I think on the eve of World War III, we'll lose most fiber and most satellite connectivity, and global consensus is going to become incredibly hard, right? So like the fully global decentralized consensus is actually not super resilient, because it relies on this idea that you must maintain physical connectivity to reach global consensus, right? So in order to actually have truly decentralized sovereign systems, we need to have the ability to sort of be as local as required as well as global as possible, given the underlying networking conditions that emerge sort of over the coming years. From a social perspective, we can always say, well, there's no governance system, there's just rough consensus. Rough consensus can be captured. I think we've seen this mostly in Bitcoin, that Bitcoin has become incredibly stale and doesn't evolve to adapt to sort of the challenges it faces. And especially once you start having on-chain governance, single centralized things, if they do not face external pressure points that compete with them, even if they're decentralized, tend to stagnate, right? So like, you want to give people the ability to move around and to actually like, keep the market pressures going in order to sort of like keep everyone improving at the same time. Yeah, and I think this is sort of, especially my thinking around like a lot of the, well, we should all checkpoint into a single security model. This is sort of with the state channel discussions, a lot of the L2s are like, well, should we really design our security model fundamentally around a single one world government that we all checkpoint into? And I'm not saying that certain amount of standards and interoperability aren't a good idea, but your fundamental economic security maybe shouldn't all rely on the same thing. Because a single security instance can extract rent and harm users. And you must always give users the ability to leave. And I think this is, and so I live in Switzerland, and this is by choice, not sort of by nature. So I like Switzerland a lot because it's a real world example of how credible threats to exit can keep a system that is good for end users. And so if you ever come to Switzerland, we know, because there's a cool thing where 2 cantons still do hand signal voting in the town square. So once a year they meet up and it's a public vote. They do not have secret elections. It's a public vote where they all stand in the same town square and sort of like decide on the government for the next year, decide on the tax rate for the next year. And this is all like just by hand signal. Also, no one counts. There's a guy in the middle who estimates. And goes like, yes, I think the ayes have it. And if he isn't certain, like if it's an even split, he just gets 4 other guys. And then 5 dudes stand on top of a tower in the middle of a town square and go like, well, we think the ayes have it. But this works fundamentally, right? Because the democracy is so close to the people that there's really not that much unpopular things that sort of a central government, the cantonal governments can do here, because, well, if they do something super unpopular, they can get recalled in the next 6 months, because any sort of referendum can recall them. And so, like, the population has an incredibly effective threat that they generally do not have to take, because sort of the governance system as a whole just is aware of the credible threat of A, being sort of like recalled, and B, you also have this credible threat of exit because you can go to many other places, and the Swiss population is highly mobile. So it's like, and I think this is really what it comes down to. You never want to have to pull the thread, actually. You never want to execute on the threat. Mostly, having the credible threat that you could do something is enough to keep most governance systems in check. And this goes away. For example, if you look at a US election cycle or a German election cycle or a European election cycle, well, because your cycle is 5 years. Like, you can do vastly unpopular things like in the next 4 years after your election, because by the time the next election rolls around, most people will have forgotten about the thing, right? Like, there's no credible threat that keeps everyone in line all the time. And I think this is the other very important thing. Different people want different security models. There's not a single best global security model, and I think this is very important to understand. My parents will never trust global Ethereum. And I would assume this is true for most older people in this room. And to be fair, there's a bunch of special things around, like, my parents trust their local government, they live in Germany, so like they have a good local trust zone. If you live in Argentina, I understand why you may actually trust global Ethereum more than you trust your local Argentinian government, right? But this is not to say that like Argentinian or global Ethereum or German governance is better. It's more different people will have different trust requirements. Because it depends on their specific circumstances, right? And I think we should be designing systems around this, where my parents will want a homogeneous architecture in their local security model. Argentinians will want ideally the same homogeneous architecture, but in their local security model. Yeah, so trust is just fundamentally, it's a very personal thing. For example, I very much trust the Swiss government, and not for everything, right? But like, it's a very broad range of like trust models here. And I think actually this is why, especially sort of in like the less stable parts of the world, we're seeing a lot of traction for why blockchain systems are a good alternative. And we're seeing very little uptake in sort of, let's call it sort of the NATO bloc of countries, because fundamentally, most people here trust the local government, whereas most people outside of sort of the West don't trust the local government. And so like, this is like where I think blockchains are starting to be a very appealing security model. Like, my parents do not want a system that the local court system cannot overrule. This is a bad idea for them because they fundamentally trust the local court system. But what we want to enable here is that it is a bad idea if everyone runs their own architecture, because then our applications cannot roam. Like, think about the real-world example of phones. Phones are super nice because I can buy a phone in Switzerland and I can fly to Belgium and it just works. I can fly to China and it still just works. Like, but I'm now roaming different specific security models with the same hardware, with the same app stack. And so this is, I think, kind of the goal of the space of all, that we allow many different heterogeneous trust models, but have a relatively global homogeneous architecture, which is not an intermediary, but rather an interface that we can start sort of developing applications against, so that users, when they want to decide, well, today I'd like to be sort of like use Celestia for DA, and tomorrow I'd like to like do some settlement globally on Ethereum, the same application can just work, and people don't have to buy a new phone in order to use the new settlement layer. Yeah, so don't split the UX. If we start splitting the UX, we'll like arrive in this horrendous world where we all need to carry around like 500 different wallets, because sort of as we roam the world, none of our infrastructure is interoperable anymore. Yeah. So this brings me to sort of the second section of the talk, which is scale-free networks. And this sort of fundamentally comes down to local security models, which is state should only be co-located when it's valuable together. State co-location is really expensive. You're paying for global rounds of consensus. You need to get a global total order over that state. Most state does not require A, a global total order, or B, needs to live in the same security model, right? Like, in the sort of the simple example here is like the financial transactions in Brussels do not need to be globally ordered with the financial transactions in Zurich. It's absolute nonsense. And co-locating the state in sort of like a single global thing just makes it incredibly expensive and slow for everyone involved. It is a much better idea that you sort of co-locate all the state that's relevant to Brussels in one instance, co-locate all the state that is relevant to Zurich in another instance, and only when you actually want to have an intersection between these two states, as in like database state, do you actually start co-locating this. So yeah, this is also like the other thing. Once you start having heterogeneous security models, you want to think about how do we build systems that allow you to opt into co-location only when it's needed. As in, you want to have an on-demand chartered system where you go, well, there's like one ANOMA instance running in Zurich, one ANOMA instance running in Brussels, and like whenever you want to do like want to do a synchronous thing between them, only then do you opt into making the relevant state synchronous with the other side. The simple example here is, again, financial transactions. Most stock exchanges are set up this way that there's a total order to the London Stock Exchange, there's a total order to the New York Stock Exchange. There's no global total order that we enforce over all these states because co-located state is fundamentally expensive. So this is also one way to think about who actually owns what state. And fundamentally, always one controller is the controller of a specific piece of state. And generally, you can either have created some state, so then you're sort of the creator, the controller of that created state, or you can currently control a state that someone else created. And the simple example here is actually asset routing over blockchains. In the case of Ethereum, right? Ethereum is the creator of all ETH. Ethereum can always sort of inflate the supply, slash everyone. Ethereum has full sovereignty over what happens to the asset of ETH, over this database state that we have assigned the semantic meaning of being ETH. If you start moving ETH to another system, to a rollup, well, now it's in two places. But what happens when you actually want to move it from Optimism to Arbitrum? Well, honestly, you should route this back via Ethereum, because this is actually the fundamental controller that's going to determine what is the correct state of ETH anyway. And this also comes all down to scalability. If everyone routes their own state and is sort of the final controller for their own state, this is an incredibly scalable model, because we don't have to have like these large routing points that everyone trusts. It's rather, well, if you want to hold ETH, I assume you trust the global Ethereum is secure. And then so you have that trust assumption anyway. And if you then start thinking about doing this routing via sort of the thing that created, the controller that created that state, it just makes your security model much easier, and it makes it much more scalable. And yeah, again, then users and applications can actually roam between these many different instances. So yeah, this is sort of the point. Every community, and this is really communities here, whether physical or digital, right? Like people think about communities really in the physical sense, but you should also think about this in the digital sense, where like the World of Warcraft community is an actual cohesive community that should probably co-locate their state. We already sort of covered the blockchain. Oh, damn, I'm also running low on time. Great. So the super nice extension of scale-free networks is that everyone can end up being their own chain. Because fundamentally, if you create valuable state in these systems, you should become sort of the control, like you are the control of the state. And so this means that we can get rid of this like weird abstraction, which is like there's some blockchain in the sky over there, and I interact with this blockchain in the sky via some RPC nodes, to rather, well, we all sit on the same level. I'm just a one-on-one blockchain that controlled some local state that is like relevant to me, that is my personal data. And whenever I want to route this to the rest of the world, I can route this on exactly the same underlying sort of software protocols that we also use on a chain-to-chain communication basis. So individuals are really just controllers of their own state. They're one-of-one instances. They're effectively single instances with a single validator. And this is incredibly powerful once you start like thinking about this in a generalized fashion, that we get rid of all these weird abstractions where, well, users are a different class. They have different levels of access. They must run like RPC nodes. They can't just interact on the same P2P network that actually all the validators interact on. Like they must sit on a separate thing. And once you start thinking about this in terms of scale-free networks, you end up in this world where really you just have a homogeneous group of people that all just like that you can describe really well in the same abstraction. And coming back to this, fundamentally, right? The goal of the space is to build World War III resilient infrastructure. I think, at least I hope, Because I think when a lot of people think, well, we want to build decentralized systems, what are we actually doing this for? And I think the honest answer is we want to be more resilient than right now, because our current systems are incredibly brittle. And this comes down to a couple of things. Mostly, all our existing infrastructure was built around this Pax Americana idea that, well, we have a single global security model and the US government is going to secure our entire financial system. This is clearly breaking. And by the way, I'm not in favor of this breaking. Pax Americana is great, and we should all pray that this lasts as long as possible, because the alternative is incredibly messy. But we should sort of think about what are actually decentralized systems for? How can we build infrastructure that makes sort of this probably future outcome less messy for us? And this really comes down to the infrastructure we build around Pax Americana, especially around the financial system, will not survive World War III. It will not survive a global internet outage, because especially in Europe, if we lose most North Atlantic fiber cables, the European financial system just grinds to a halt. I also assume that the Swiss financial system is not going to survive a dedicated cyber attack, because it was never designed with that model in mind. This is sort of just something that came on later. So yeah, my assumption is that on day 1 of World War III, global connectivity is immediately lost, and all global consensus is shot. So we aren't going to live in the world where it's well, everything broke around us, but we can still totally get to 12-second block times on global consensus to move some magic internet money around, right? This seems very unlikely to exist in practice, to actually happen in practice, mostly because most fiber is going to get cut and most satellites are going to drop out of the sky. So you really got to start thinking, well, we want to have infrastructure that is as local as required, but as global as possible, so that, let's say we lose connectivity to everyone outside of this room, we can still have the same infrastructure, the same tech stack to do local settlement. And this is, I focus here really on the point of resilience, but it's also the point of latency. If we in this room just want to do trading, no global consensus will ever be faster than a local connectivity. Unless you can violate the laws of physics, you will never get faster than local fiber-to-fiber connectivity, right? This is just a fundamental point of physics at the moment, at least, that no matter how fast Solana makes global consensus, it will never be faster than us running things locally. And in trading, this really matters, right? It's about latency as well as about sort of state co-location. The other thing is, when you think about World War III resilient infrastructure, you got to be thinking about privacy, because fundamentally privacy is needed for community defense. And sometimes I talk about this in terms of privacy for national defense, because I think this is a much more positive way to think about privacy guarantees. It is not that you're trying to hide from the government. It's more as a government, you do not want to leak all your data to North Korea. This is very much the case that I think no sane country is going to support a completely transparent global financial system. Because sort of on day 2, everyone goes wait, what? North Korea is just doing massive amounts of data analysis over everyone's financial transactions? That actually seems like a bad idea, right? So we need infrastructure that is both local as required, as global as possible, as well as that has decent privacy guarantees at the base layer. And then the best case really is for local connectivity. And once you start having this, the way you should start thinking about these protocols is you actually want the ability to make this very transparent from a user perspective, again, where users can easily roam depending on what the physical connectivity practically allows you to do, right? If you happen to have global consensus, great, then you can use global instances. If you only have local consensus, also fine, your same infrastructure works. As a side note, if you're sitting in this room, most likely you're in charge of providing local data centers to your local community. And this is sort of, I think, just going to be a hard requirement going forward if you want to have resilient infrastructure. We can't be relying on some RPC server will be available to someone to host me a front end, right? So if you're in this room, please start running local Ethereum nodes, start running local Celestia nodes, host your own Uniswap front ends. And this doesn't have to be big, right? 2 Raspberry Pis in a closet somewhere is actually already the right step. But really in this space, if we actually care about decentralization, we should fundamentally care about not all relying on the same inferior RPCs, because this will just not work in the future. And this is really run everything over LAN. Oh, this is actually the coolest thing. I will quickly talk about this. Every community must run their own infrastructure just because you need to be fully decoupled from global state. And yeah, please self-host. So in Zook, I was bored at some point when I moved there. I was like, oh, I should like find out some local, I should meet some local people. And so I looked into the ham radio club. And ham radio is just amateur radio. And so you go to the website, and the first thing on the website is a charter by the Canton of Zook that says, you must provide backup emergency comms within 6 hours of an outage. So the local ham radio club in Zook is charged with dedicated infrastructure, like with an emergency response in case Zook loses power. So what actually happens is all the members of the ham radio club just have backup generators in their cars. And like when they get power outages, like if they get like a Canton-wide power outage, the idea is that they drive up to the mountain peaks to like provide local area coverage that's independent of any centrally run infrastructure to get emergency backup comms for emergency services. And like this is really the right way to think about this. This is why I think Switzerland is a great example. The Swiss are fucking paranoid. And like honestly, the blockchain space should learn more from the Swiss because they've been paranoid for way longer than we've been around. And they thought more about like, how do you actually get resilient infrastructure going? And by the way, if you're into shitcoin trading, that's great. But I think this is like not the talk for you. I'm very much into like how do we actually build like long-term resilient systems here using some of the cool distributed systems tech that we're building out at the moment. Yeah, so quick TLDR. Single decentralized networks are still centralized. We want to have choice. We want to have we want to have optionality so that single things can't get corrupted. A single global security model is fucking terrifying. We should not be building for this. Single things of everything are going to get corrupted. They're going to extract rent. They're like not going to do the fun, nice cryptography that you actually like, right? Like it's also about user choice and adaptability. Fundamentally, different users have different preferences for their own security. And we need many independent security models that actually can compete with each other. Fundamentally, you want to be thinking about building scale-free networks that have homogeneous architectures as well as heterogeneous security models because you want to give individuals the ability to roam. Also, I didn't speak too much about this, but like privacy really, really matters. If you aren't thinking about how to build privacy preserving, like how do you give the ability to have some amount of privacy within a system at the base layer, I think that base layer will, like, it's very difficult to get global traction because most users fundamentally care. Like my parents will never use a system where their neighbors see their bank account balance because this is just like something incredibly alien to them. Yeah, we should also learn from the internet. The internet was actually designed really well. And if you're in the audience and thinking about decentralization of DNS, I know there are problems with the internet that we didn't solve back in the day. But fundamentally, like I remember the internet not as a like I remember networking not as a thing like I reach out to the internet, but I bring my computer and a switch to a friend's house, and like we run things over LAN, like without ever touching the internet. Like this is sort of the model that I grew up in, and I think this is the model that we should learn from in terms of being able to run physical infrastructure. Fundamentally, we should be thinking about how we build World War III resilient infrastructure, not because we want to bet on this happening, right? Like, but because it's the right mental model to actually build truly decentralized, truly resilient systems. Yeah, and architectures, protocols must work, even when there's no global connectivity. Thank you very much. This was sovereignty versus sovereignists versus globalists.
All right, thank you very much, Adrian. And now we have a panel, so I think we have a little setup, but thank you. Very interesting and a little bit terrifying. Very good. Actually talking about what the space is supposed to be about. Thank you. have a mic? We good?
Test, test. Hi.
Test.
All right. So thank you, everyone. Welcome to this panel on the different VMs. My name is Rex Kirshner. I am a host of the Expansion podcast, which is Blockworks' latest podcast on the modular ecosystem. And before we jump into VMs, let's just do a quick round of introductions. So if everyone can say their name, their project, the VM they're working on, and then let's maybe do 1 or 2 sentences on why you think the VM that you're working on is the one to bet on.
Sure, I'm happy to start. Thank you all for coming today. If I were you, I would be in bed. So I'm impressed and honored that you're here. Some of you look like you might still be in bed mentally, even if not physically. I respect that too. I work on a project called Anoma, and I have a confession to make, which is that I am greatly underqualified for this panel because I don't know what a virtual machine is. So I'm hoping that maybe we'll figure that out. I'm also not convinced that they should be competing with each other. So, you know, yeah, maybe not sure about the frame of that question. I mean, the closest to a definition that I've found is that virtual machines are ways of representing functions. And I think it's not really possible to speak about which is the right way to represent functions without speaking about which function do you want to represent. So perhaps different virtual machines would suit different purposes, but we shall see.
Hello, my name is Dmitry. I'm from Fluent. I totally agree with your point that what the hell are virtual machines? Yesterday I tried to figure out what's the proper definition of virtual machine and why we have such huge amount of virtual machines. And let's figure out how it works, why it works, and actually how Fluent is trying to solve this problem.
Hi, I'm Eugene. I work at Ellipsis Labs, and I guess I'm the third guy in the panel who doesn't have a formal definition of a virtual machine. But as a company, we are core contributors to Phoenix, which is a limit order book DEX on Solana. We're pretty familiar with the Solana virtual machine and the tool set around it.
Hello, my name is Keone Han, co-founder of Monad. Monad is a high-performance EVM layer 1. And the reason why we built for the EVM is because we feel that the network effects of so many developers, so many libraries, so many existing programs is just really powerful.
Okay, well, I was not expecting to just have debate on the concept of VMs, but we'll power through and we'll come to conclusion by the end. But we should start with the EVM, and let's start with the vanilla EVM, the classic EVM. So today I'll summarize kind of like the complaints with the EVM in 3 pieces, right? We have scalability, we have security, and we have developer experience. So can we talk through each of your projects and except for Keone, who is using the EVM, but kind of in a modified way. Can we talk through which of these 3 pillars do you think is the biggest problem, and how is your project kind of addressing that issue that you've identified? So why don't we go reverse order? Keone, why don't you start us off?
Sure. Would you mind just saying the 3 different?
Sure. So scalability, security, and developer experience.
Oh, sure. So Monad is fully bytecode compatible, so any existing EVM application could just be redeployed on Monad without any changes. All of the changes to the VM that Monad has implemented are just related to making it a lot more performant. For example, introducing a custom state database for storing Ethereum Merkle tree data. That's completely under the hood. Optimistic parallel execution for executing many more transactions in a unit of time, but also completely under the hood. So just, regards to the scalability aspect, I just think that there are a lot of areas of improvement relative to the current implementations of the EVM, for example, in Geth or Aragon or other clients. And our team is a team that's really focused on just making some of these fundamental improvements that don't actually change any compatibility or any considerations for developers.
Solana and the SVM are really designed for performance, and that's sort of been the goal for Solana since 2018. And so at the VM layer, there's some constant factor improvements just in really just in the implementation. where we don't use like U256 because they don't work super well with computers. Today's computers, let's say. Solana has a couple of other things like native access lists, although this is not like a VM detail necessarily. This is something you could slap on the EVM if you wanted to, and allows you to do a particular type of parallel execution. When it comes to like which VM is going to win, I mean, I think in the same way that it's relatively unlikely that a single blockchain wins like every single use case, wins every single user, I think it's pretty unlikely that a single VM or a single execution environment is going to win every single use case. Kind of going to the original question of what are these things useful for anyway. Some applications are going to be really, really performance sensitive. Some of them are going to really rely on being extremely, extremely censorship resistant, and probably the right tool is going to be different for different types of applications.
You highlighted 3 main areas, and that's a bit tricky because at the same time, you cannot design solution by, for example, ignoring one of these, and you also cannot focus on one specific area. In Fluent, we try to build a product that combines all these 3 main aspects. But if someone asks me what's the most important and beneficial, for example, in terms of Fluent, I'd say that it's a developer experience. And I have a reason for this, because there is a giant problem, and maybe I think it's even a giant gap in misunderstanding of what is VM, how it works, and why do we actually need to have these tens of different VMs? Because they're all designed for specific needs, for specific tasks. In Fluent, we don't want to invent new VMs. Actually, we do, but we don't expose it to developers. We disallow developers to interact with our VM internally. Instead, we say that you must use only toolset you know, only toolset that already exists on the market, and you can combine all these toolsets together by translating into our special VM. And this is how we try to enhance developer experience. And at the same time, for example, scalability is extremely important for projects starting with, let's say, like Fluent is ZK-based, and it brings scalability opportunities for chain to be semi-centralized and be scalable simultaneously.
So I think we've been psyoped. Maybe by the editor of the virtual machine Wikipedia page. If you go to the virtual machine Wikipedia page, it describes a bunch of these designs from the 1960s. And in the 1960s, computers were all mainframe computers. They were in like university laboratories. And there were very few computers. They were like big, and they consumed a lot of power, and they were expensive. And universities, being nice, wanted to allow their staff, many different staff, to use these computers. So they created these kind of time-sharing services, particularly time-sharing services for computation, where people who wanted to do compute jobs wanted to run them on the mainframe computers, maybe even have those compute jobs interact with each other, would submit job requests, they would send them all to the mainframe would like schedule them and execute them in order, because it was trying to share this resource of computation. And even if you look at something like the EVM or the SVM, they are modeled after the same basic understanding of the problem. And I think that understanding of the problem was perfectly suitable for 1960s mainframe computers, when what you wanted to do was share computational resources. I'm not convinced that it's suitable for our problem. I mean, we haven't really defined what our problem is, but to take apart the EVM for a second, to me, the EVM consists of 3 things. It consists of a state architecture, how state is stored, how changes to state are authenticated. It consists a state architecture. It consists of an instruction set. This is like how computation is represented. So add, multiply, 256-bit integer types that I would call part of the instruction set. And finally, it consists of a message passing model, which is how programs send data and messages to each other. And in the EVM, this is accomplished by the call opcode and its various variants. And these 3 things are coupled together in the EVM, but it's not clear to me that they're necessarily coupled together at all. So one thing we've done with our project called the resource machine is split these 3 aspects apart. The resource machine is a state architecture, but it doesn't fix a particular instruction set or message passing model. So you could still use the resource machine with the EVM or the SVM just as an instruction set to represent functions, and you can pass messages, I don't know, however you need to pass messages on the intent gossip network through solvers to figure out a satisfying solution and just publish that as a transaction. I don't think the resource machine is the only way to split these three components apart. You could do a different architecture. You could do many instruction sets. You know, when you split them apart, they're not tightly coupled. They're not one-to-one coupled like they are in the EVM. And you could probably do many different kinds of message passing models. So I would be interested to see a lot of investigation in that direction. I think it's really hard to say like what the right VM is without defining a problem. To me, the EVM's problem right now is that it hasn't defined a problem. Like, you know, apart from the world computer, which is a meme, it's unclear what the EVM is trying to do. What is the machine that it's aiming to virtualize? Is the machine one blockchain that wants to share, you know, that wants to provide abstract computational and storage resources? That's maybe what it originally was. But with rollups, with kind of layer ones being used mostly for proof verification, with a lot of computation happening off-chain, and with just the very structure of the gossip network implying that no one other than the person actually, you know, proposing the block can really guarantee the results of execution. You know, absent some more complex models, but still, like random nodes in the gossip network can't. I think the EVM has a sort of definition that's like misfit to its actual deployment scenario. And if we want to fix it, we first kind of need to clearly define the bounds of what the machine is that we want to virtualize and to whom.
Keone, did you want to say something?
Yeah, I mean, definitely appreciate that kind of breakdown of the EVM into several components and the effort to try to reimagine like what it would look like if we, you know, took the burrito apart and made a burrito bowl instead. But I think just to state it very clearly, like the way that, and we all know this because we all interact with Etherscan, and we see like a block and we look into the block and it has a bunch of transactions, and then, you know, we look at one of the transactions and it's interacting with a particular smart contract. You know, I would just say that you know, at the end of the day, like that's a pretty easy to understand computational model of just like transaction-based execution, where a transaction is like, you know, depositing money into your like virtual bank account, like a lending protocol or something like that. So it's not like totally abstract what a VM is. Like a VM is a sandbox for executing a program using a standardized instruction set, like you said, and then, you know, this gives us building blocks. We can build up more complex, you know, an entire Lego castle from these individual bricks.
Yeah, I mean, just here, gotta take that off. Just to like, I did not realize the concept of a VM would be controversial for this panel. And look, like I come from the, I don't know, school of VMs that like I learned what a VM was from Parallels. I have a Mac. I wanted to play Windows games, and like that's how you did it, right? And so you could say like, well, what's the point of this virtual machine? And like, it doesn't have a purpose, and it's just like general purpose Windows. But like, the point was that I had access to it, and that I could start like putting my actions and transactions into it. And so. And you had applications that you wanted to use, right? That were like written for this VM in some sense. Parallels written for Windows, right? Sure. Yeah. So again, what I see of the VM is, and maybe like we need to come up with new vocabulary, like there's a good space for new vocabulary, but like it is just like the environment on which your like smart contract, or sorry, your blockchain actions just happen within, right? So in the EVM, that is this like well-defined space. The SVM has a well-defined space that are not exactly the same, but you know, like they're the computing space.
By the way, according to, you called it vocabulary, I think this is the perfect term that can describe the problem we have right now. Because what we know today, we even cannot call EVM a virtual machine, because technically it's not a virtual machine. I'd name it specific context-dependent execution environment with specified instruction set. Because from the, like you provided an example of parallels, it's more about like emulation. It's a hardware emulation problem, and it's quite different because in blockchain we don't have a hardware emulation problem. We have a sandbox execution problem, and the way how we can pack it efficiently into one place and execute. And the question is, why do we all develop on EVM? Is it the best solution, or we have to do this to support all developers that already persist there, like in the community, or we have some alternative choices?
Yeah, I mean, I think to your point about, parallels, users want to use applications. And if those applications are written for, tied to a specific virtual machine, I mean, users will want to use that virtual machine in virtue of allowing them to use those applications. I suspect this is part of why you guys at Monad want to support the EVM and implement it in a more efficient way, make it better, because there are already all of these applications. And that totally makes sense to me. But then, to me, the question is, can we make it easier for some users to make different choices while retaining the ability to interoperate, right? These VMs, if we take them, there are many specific choices, let's say, specific choices of state architecture instruction set. They have different trade-offs that make sense for different applications. And, developers are like quirky, and maybe they will just be attached to particular VMs. There are a lot of people who really like this language called Knock, used by Urbit. And, it's interesting, it's very quirky. So maybe we should let developers have their diverse preferences, keep them happy. But how can we allow that to happen at the same time that we don't force users into this question of mutual incompatibility? So just like with Parallels, well, you had to install this whole separate environment. You had to, make a virtual desktop, and I haven't done this in years and years and years, so you're testing my memory here. But to me, this is a pain in the ass. Wouldn't it be nice if you could just run the Windows applications in Mac, right? What if the operating system handled this compatibility and interoperability for you? So to me, it seems like we're having a question about virtual machine design, but also to your point about a sandbox execution environment, I think we're asking more or less about the wrong problem. We're not trying to build a virtual machine, we're trying to build an operating system.
Okay, that blew my mind. I do think this is a good opportunity, and we'll borrow from Fluent. And so, Dimitri, I'd love you to speak on this. But can you talk through this new concept of blended execution? And we'll just give us a little bit of a definition, and then we'll have some questions for the panelists.
Yeah, the concepts of blended execution is to try to find a way. It's literally a way how we can represent all VMs using only one function, using only one VM. So is it possible to create a VM that can solve and emulate or simulate all these environments in one place? So
yes.
Yes, it's possible, yes. And we also think that it's possible, because if you try to imagine how your application works, if you try to support EVM, SVM, and all these other VMs, all this standards language, your mind is blowing, because you understand you must implement thousands different standards. It takes years to implement, and it makes no sense, because during the implementation period, new standards appears, new versions appears, and you cannot support the circuits, you cannot support this code base. It's super complicated. But what if we try to define a new way how you represent your application through a transition? And if there is a language that can simulate everything, that can run everything, then you can use this language, for example, to simulate itself. We call this language RWASM. It's an internal tool inside Fluent. It works under the hood of the Fluent, and it used to formalize how we prove ZK transitions for all languages, and we do so-called downcasted ahead-of-time compilation from all these binary representations into one binary representation, and we use this binary representation to prove itself and to prove all and simulate all execution environments in one place. So developers can take any tooling they want, any language they want, any virtual machine. Actually, we don't care about languages. We care about execution environments. And if you have Solidity, Viper, etc., you have some standards. We don't care about standards at all, because we support execution environment. If we have something that is on the lower level than standard, then by implementing this layer, you have standards as a default feature. And also, of course, all the languages like Solidity, Viper, etc., it's like a side effect of your product.
Do you handle, or do you try to handle, program interoperability? And how do you do that, if so?
So this is the giant, I think, question about how this model works. Because the most difficult thing is to handle interop between these different execution environments. And in Fluent, we don't know what execution environment you use, actually, entirely. We have only one language, RWASM inside. We have only one virtual machine. that is absolutely closed for developers and they cannot use it and they cannot interact. It's a side effect of the development process, of the compilation, of the translation unit. And we create our own tree representation, our own storage layout, and we create special, let's call it loaders, for applications according to the execution environment, where we define how they interact with this tree, how they interact with this state transition, and what allowances they have and what restrictions they have. Because we cannot allow these applications to do everything they want, because they can, for example, corrupt storage, get access to another execution environment somehow. And we, during the compilation process, we inject all these restrictions, all these constraints into the loaders of the execution environments. So, yeah, let me add one thing. You can build something like you can create application using EVM, using Solidity, let's go. You can create application using SVM, and they can share same balances. You can do native interop between these apps. The only thing you need to carry is ABI encoding. So we don't care about ABI, of course, because it's. I can explain why. Because it's specifically developers' problem. They all think that, these chains, these platforms, execution environments has different API, developers cannot interact. But if you develop an app using Solidity language, how do you interact with other apps on Solidity? Of course, you specify API. You must know the language you use to interact and what language developer of the application use if you want, or for example, some specific library you want to interact. And what's the difference if I specify Solidity compatible API or some other API, for example, Borscht compatible API, or some like Solana compatible API? So there is no difference for developers. Syntax may changes a bit, but it doesn't affect the development experience significantly.
Great. So my brain doesn't have very many wrinkles. Let me try to like regurgitate back to you what you said. Tell me if this is right. Or the effect of what you said, which is, as a developer, if I want to deploy into Fluent, I could write my code in Solidity, or I could write it in Rust or another language, and Fluent in the background takes in all of these binaries and then presents the users that this is one unified computing environment, correct?
Yes, correct.
And like that, incredible, thank you. And like to me, this is like clearly where the industry is moving, right? We just, whoever was here yesterday saw Ed Felton, I believe, from Arbitrum, talk about Arbitrum stylists, and this is like the exact direction that they're going, which is to realize that, like, there's not that many Solidity developers. There's a ton of Rust developers and a ton of C developers and C++ developers. And so I guess my question for all of you guys is, like, is this, for me, this is the clear trend of where the industry is going, but is that how you see it? Do you see that these execution environments are kind of this, like, developer weird thing that we have to deal with now as just growing pains of blockchain computing, or is this like an important paradigm that will exist in like 10 years and 50 years, and like we'll understand what the EVM versus the SVM and be having those debates when we're grandparents? So why don't we start up from Keone?
I mean, I'll just mention that JavaScript is still like, the backbone of most interactive web apps. And, we have like nicer frameworks on top, TypeScript, and then frameworks on top of TypeScript, but everything under the hood is still JavaScript. So I think if you're kind of trying to project like 5 years into the future and say like, what does the smart contract landscape look like? Is it just like a jumble of all these random like, Solidity things that, are floating around in different GitHub repos, all verified in Etherscan? I think that's likely, and we just see like a proliferation of more complex applications built on top of the existing ones, similar to how like what we see in the internet landscape with JavaScript.
Yeah, fair.
Yeah, I think this is very path dependent. There are also previous web frameworks, web languages before JavaScript, and I don't think it was clear a priori what was going to reach escape velocity. And there's like a lot of these sort of constant factors that matter here. One of them is the hardware itself, the computers, the browsers now have access to so much more resources than they did before, to the point where like the average shitty JavaScript developer like myself can still build a web application that mostly works. And the tooling has also seemed to reach some sort of escape velocity, which is where, in my mind, the EVM has the biggest advantage today. I think the total number of developers just doesn't matter whatsoever. If you're bullish at all on crypto, you should expect the number of developers in the future to be at least 2 orders of magnitude higher than it is today. And then where you're going to get the runaway network effects potentially is going to be on the developer tooling and developer onboarding.
I think one very important statement from my perspective, we cannot fight against developers' needs and requirements. No matter what tool set you provide to them, they all the time use what they want. And you cannot limit them with a number of VMs and say, oh, you must use this, and this for your needs. Because you cannot, like, the number of, so if you can create all these VMs, you also can create an app that doesn't fit into one of these VM, and you'll need new VM. You highlighted the great example of JavaScript. I like to call JavaScript a machine code, because in some way of how you think about Chrome, it's an operating system, and it has its low-level machine code, it's JavaScript, because it's the simplest thing you can develop and use inside your Chrome browser. And Google tried to replace JavaScript for several times. They tried to use Dart as a foundation language for development, but under the hood, they literally translate all the time everything to JavaScript, and JavaScript is the most weird machine code ever created, because it's not natural to have JavaScript as a machine code. It makes no sense. But this is what we have. And today, if you want to create new solutions, you must always worry and think about developers and about execution environment you have. Like Google Chrome developers, or like all browser front-end developers, they are locked to use JavaScript, and there is no ways how they can get away from this. They're trying to mix it, for example, with WebAssembly to let developers develop, for example, UI using JavaScript and develop highly loaded apps using WebAssembly. This is very similar, for example, what Stylus is trying to achieve. And you can use EVM. That is, like, let's say, an important legacy to have. And also you can expand functionality using WebAssembly. But we're trying to think even further, because what if we don't want to limit developers with 2 languages, with 2 execution environments? What if we can let them define the execution environment they want? If they want to develop something that is not supported by, for example, Stylus, they are limited with functionality because they need to wait Stylus to develop this. But using our translation approach, we can let developers to create their own execution environments and create apps for these execution environments. If one new VM appears, they just create translators into our low-level representation. They create simulation toolset, and that's it. Developers can start using this, and we think it can be the future, because we don't want to limit developers. We want to help them to use the same environment, to use the same tooling, and we want all developers persist in the same state, in the same place.
I mean, to me, the question is, what are we trying to provide here? And in all of the examples that you've given of parallels of the EVM, of your kind of blended execution environment, it seems to me like what we're trying to provide is interoperability in 2 ways. We're trying to provide, one, interoperability between applications. Applications need to share some kind of environment, some kind of operating system, especially when they don't always trust each other, in order to facilitate interoperability of state, messages, et cetera. And 2, we're trying to facilitate interoperability with an existing base of programs, developers, the stuff that people have already written in Solidity for the EVM, the models that developers already understand. And I think we will continue to want both of those kinds of interoperability. I think this question does not relate to many of the aspects that are often bundled under the term virtual machines. In particular, it doesn't relate to the instruction set. Nobody cares about the instruction set. What's the instruction set? You said that JavaScript is a kind of machine code, which I think is true and funny. But also, Google sank boatloads of money into their just-in-time JavaScript compiler, and it does random things that I guarantee no one in this room knows, unless you work for Google on V8, then I'm impressed and wrong, but probably not. Come find me after. And the reason that you don't need to know it is that they have abstracted the right things. Developers can write JavaScript. I mean, the web browser APIs are not great, but they're there, you know. At least there is an operating system environment. And Google sank their money, which they have too much of, into a lot of compiler engineers to at least try and make your JavaScript run kind of fast most of the time. And, you know, it works sort of well enough. And I think that is much more likely to be the world that we'll see. Maybe there will be some you know, low-level formats that for whatever reason or another are kind of standard just because it makes things simpler, but developers will not need to even think about them if they need to think about them, and we're on this panel in another 60 years as grandparents still talking about minutia of virtual machines. Yeah, then I think we need to re-examine our lives.
Okay, well, you kind of cut off my last question to the legs here, but I'll ask it anyway, which is, you know, a buzzword right now in this point of the narrative is abstraction, right? Like chain abstraction, account abstraction. And I guess like my question for you guys is like, do you believe that we're inevitably gonna reach computational environment abstraction? And to that effect, like how important is the VM, and like can you build a business with your differentiating factor being, you know, your VM or tweaks to your VM or that kind of thing? Or if we are really going down a computational environment abstraction, like a roadmap, like is this stuff really relevant, or is this kind of implementation details that a developer will see on like page 12 of the docs? So why don't we go in forward order? Chris, take us out.
Yeah, I mean, I would say, to me at least, computational abstraction was invented by Alan Turing. So I think we're like doing okay there. We don't necessarily need to reinvent that one. Perhaps we can build some better compilers. What was the second question, sorry?
So do you believe in this computational environment abstraction, and is the VM a differentiating factor that you can build a business around?
Right. I mean, whether or not you can build a business around something depends on what kind of world of money and of finance in which you operate. And I think it's likely that that will change. I mean, it always changes through history, so even absent crypto or even talking about our specific technology, a reasonable assumption is that it will continue to change in the future. I mean, to me, like, compilers are useful. Like, it saves energy to have more efficient compilers. So I would be very happy if we come up with ways of organizing our financial system that make producing better compilers viable businesses, at least for some people, maybe not everyone. If everyone's producing compilers and no one's producing potatoes, we're in trouble. But we probably want some resources dedicated towards that. I think the business models will need to look different than how they currently look, where people like, in effect, raise the development of compilers and virtual machines and the operation of a specific like layer 1 blockchain or rollup or something. These are coupled together in the public eye and the eye of capital allocation. And I think this coupling doesn't work very well. One, it doesn't work well as a value capture mechanism because people want to send intents and transactions based on a lot of other factors, mostly not just like the computation, mostly not just the VM. And two, it doesn't work well in terms of actual capital efficiency because you have a lot of wasted duplicate efforts, and then you try and create gatekeeping effects, so people will send transactions to your chain or whatever. So I think in general that's a pretty terrible system of financial coordination, and we should probably seek to replace it in order to get better compilers and more abstraction.
Yeah, I want to say regarding abstraction, I want to also add regarding modularity, and I think these are quite similar concepts, because I extremely love what's happening with crypto industry today. That happens like 2-3 years. That started to happen 2-3 years ago, because before everyone tried to build like layer one, like the fully monolithic, almost the same blockchains with one tiny difference. But today, developers, they finally figure out, and the entire community, that there's no need to create all these fully independent environments. You can do so-called you can delegate responsibility for specific functions to specific areas. You can try to abstract most of things. Like you can split your blockchain into sequential execution, data availability, settlement, and etc. And you can let different teams to focus specifically on specific themes. This is why VM matters, because VM is a part of execution layer. and let developers create great execution layers and share it across the entire industry and just utilize what we have. I think this is extremely right way because the entire crypto industry is finally on the way to build the giant crypto infrastructure that can be, it's a giant ecosystem that can even compete with Web 2 and to be integrated into Web 2. Because we finally forgot about this extreme decentralization with ASIC minings, where the only thing that is important is to produce your hashes, and this is huge. You have 10 kilo hashes and amazing mega hashes, tera hashes. It doesn't matter. But finally, we can think about more semi-centralized solution about ownership, responsibility, delegation, and actually thanks to ZK, because ZK really helped to bootstrap this process. Yes, it's not super optimal today. ZK has a lot of things to fix, to improve, to optimize, but communities started to think about the problem, and now we can expand the ecosystem finally.
I'd say the economic interest here, where everyone is always trying to commoditize their complement, means you're pretty much always going to be stuck in this cycle where, like in traditional media today, we see this cycle of bundling and unbundling, bundling and unbundling. We see the same thing in enterprise SaaS, and we're going to see the same thing at all these different levels of the crypto stack, where I'm always incentivized to try to abstract away or commoditize the layer above me, the layer below me. They're trying to do the same to me. So I think this is really all motivated by business interests. I think it's pretty difficult to fight against the economic incentives. I think that's how it's going to play out.
Yeah, I mean, I think we need to be very pragmatic. I think that, you know, there's just an incredible opportunity for the crypto space right now to grow substantially and take more share of the market for decentralized apps to become the prevailing standard, but that's not going to be easy to do. And I do worry that, well, in any event, I think what's really important is to, like, you know, we have a couple of standards. It's pretty clear that, like there's traction around the EVM, there's traction around the SVM, and we'll make incremental improvements, performance improvements or feature improvements to those. But really, I think that the growth has to be obviously in the application space, and I think that, you know, to some of the earlier points about like just wanting to like abstract everything away or like give a ton of flexibility, I do think that there's a reason why, like, you know, trains run on tracks. It is because you can go a lot faster when you're on a track. So I would just push back a little bit on some of the other comments about like how developers might want to, you know, run a random language that doesn't exist right now, and like I don't know. I just think that EVM is here to stay. Our team is working on trying to make it a lot more performant. And I think for the entire Ethereum space, it's just really important for us to get much more scale out of what we have and then go figure out how to make inroads into the rest of the like tech and financial space.
Awesome. Well, we're out of time, so everyone, can we get a hand for our panelists? And yeah, thank you guys. Thank you very much.
Thank you.
Thank you.
All right, so who is next? All right, so next we have John Cole from Hyperlane, and we just need to do some setup here. So 1 second. John, are you here?
All right. Nice to see you all. Thanks for coming out. I know a lot of people weren't excited to come to this city, which is fortunate. It's actually a lovely city. I've been enjoying it very much. But regardless, thank you for coming out to Modular Summit for our third time gathering. And thank you certainly for coming out for this specifically to hear what I have to say. So as you think about this event here today, there's been a ton of excitement since what we were doing last year. The modular ecosystem has basically become a household name. In fact, it's become so big, so renowned, so hyped in some ways, that it's become pretty popular to take the counter opinion to it, to now say like, oh, this is all noise, like there's nothing really there, you're just, you don't have to worry about this thing. It's not actually going to produce the results that you think. And I'm here to tell you that actually there is a ton happening, and you don't need to buy the hype about it. There's plenty real that you should get excited about, and that's what we're gonna cover today. So before we do that, let's start talking about why are we here? Why are we here, at all? So the proximate reason why we're here at this event is obviously, presumably everyone here is in some extent excited about the modular ecosystem. But why are we here really? Why are we here in Brussels? Bigger question, why are we here in crypto? Well, that, I think, is because we care about these internet computers. We care about these blockchains. Presumably we think that they could do something interesting, something meaningful, something impactful in the world. And so we put our life energy into increasing the demand for them. Everyone here probably in some capacity works in crypto and works towards increasing the demand for these systems. Well, then we have an issue, right? Because what these systems do, by definition, by virtue of their construction, is they restrict the access to digital resources. They make what have been abundant digital resources, they make them scarce. And so we have a very predictable problem. We have somewhat a counterintuitive problem. It might be counterproductive. It might even be self-defeating. We're all putting all of our life energy into increasing the demand for these systems, but they make digital resources scarce. They, by definition, have a certain fixed supply, and if, on the other hand, we're increasing the demand, well, everyone's had this feeling. Everyone at some point, tried to do something on a blockchain, probably on Ethereum, and you ran into this, and you're like, why the hell do I need to pay $50 to just move $50 around? That doesn't make a lot of sense. I don't like this. And so what can we do about it? And that is what we're all here to try to solve, specifically through the modular ecosystem. By now, I feel fairly confident that this modular approach, if you could call it the app chain thesis, you could call it horizontal scaling, you could call it the many computers approach, whatever you want to call it, all ends up in the same direction, that the best solution we have for the scaling problem, instead of trying to build bigger, faster computers, let's just spread it out. Let's build as many of these computers as we can. And then we can actually increase demand without that counterproductive thing that we were doing before, where we increase demand, but then we were so successful at it that we made the thing that we were increasing demand for completely unusable. And we've ran into that in 2017 and 2021 again. And today, in 2024, this is our best bet for not running into that counterproductive problem. But if you have so many of these computers, you're going to need a way to connect them. And that is where something like Hyperlane comes in, a permissionless framework for interoperability, an open framework for interoperability, something that lets anyone connect any chain. And so this is a lot of the vision that I kind of laid out last year. If you were with us last year, probably heard me talk about this exactly, and a lot has happened since then. That the last few minutes of this conversation have basically been the majority of the talk from last year. And so what's happened since then? Right? The modular expansion kind of begun happening. Now this is real. This is no longer just something that you need to imagine. You can feel it, you can touch it. And let's go straight into that. So I don't think you can pinpoint a single moment in time and say, hey, that was the inception of the modular ecosystem. But I certainly think that there is a moment that you can point to as the beginning of the expansion. And we would have never been able to reach there if not for the work, the culmination of years of work, really, by teams like Celestia, who have been a big driver in this entire effort. Teams like Optimism and Arbitrum, who have built really scalable and extensible roll-up frameworks. All the roll-up service providers, whether it's Caldera, Conduit, Anchor, AltLayer, they make it super easy to launch your own roll-up. But the closest thing to the beginning of this expansion phase, in my view, happened in Q4 last year when Celestia launched. And that is almost like a big bang moment for the modular ecosystem. And from that point in time, we've seen just the number of roll-ups really start to take off to the point that now we're starting to see real distinct roll-up ecosystems forming. And from that launch, that's when really Hyperlane started kind of breaking onto the scene, bridging TIA, the main Celestia asset, to an increasing number of roll-ups, and just evolved from there. So how is this expansion going to happen? Well, a crucial component, really, is that the cost to deploy a chain, the cost to deploy a roll-up is basically trending towards zero. So if you look here, you got, as I was making this deck here the other day, I thought, let's time myself as I go to launch a roll-up using Caldera's interface. So this is Caldera's roll-up as a service interface. It lets you pick the environment that you want, the data availability layer that you want, a couple other customizations, and in just over, it was about 2 minutes, 40 seconds, I was able to launch my own roll-up. And at the same time here, this is another indication of that cost going to zero. Sorry about the resolution. But this is a chart of the leading roll-up submitting data availability to Celestia. And what you'd be able to see here is just how low that cost is. All of these posting gigabytes of data, and the entire cost here, if you add it all up, adds up to about $7,000, which is a fraction of what this had been if all of this had to be posted on Ethereum. So the cost is going to zero both in dollar terms, but also in time, right? We just talked about 2 minutes, 40 seconds to get a roll-up off the ground. What good is it for me if it takes me this, basically 3 minutes to launch a chain, but then I need to spend 3 months waiting for the good graces of one of the permissioned interoperability providers to come and connect my chain with everybody else? It doesn't make any sense, right? So this world that we talked about, where horizontal scaling, many computers are the solution to our scaling problems, doesn't make sense if I don't have a fast, scalable, and permissionless way to connect all those chains. And again, that's where Hyperlane comes in. So if it's not clear by now, hopefully it will be soon, modular blockchains love, I would even say modular blockchains need permissionless interoperability. They absolutely need something like Hyperlane. And so in Q4 last year, when Celestia launched, Hyperlane was there to be the first interoperability protocol catering to the bridging of TIA, the main asset there. If you've used Hyperlane at all, if you've been exposed to it, that was probably the first time. It's pretty janky. Thank you all for bearing with it at that time. It's gotten a lot better since. And since that point in time, over 900 million in TIA has been bridged between different rollups and chains. After that, things really began to pick up. Things really began to move quite fast for Hyperlane. Not just the speed of the bridging, but also how fast things were evolving. A few months later, if you're familiar with Injective entered the fray of the rollup space, launched their own rollup in EVM, and used Hyperlane to bridge the gas token. In the couple of months since that's happened, over $700 million in the gas token have been moved between Injective and the rollup. And things really began to take off from there. So let's look at kind of modular expansion by the numbers. Ever since that Q4 moment, Hyperlane's processed over 4 million interchain messages. Today, by activity, Hyperlane does more messages than any other interoperability protocol short of layer 0, some days even more than layer 0. Surpasses Wormhole, surpasses Axelar. You see here the number of distinct contracts that have been interacting with Hyperlane, the number of distinct users. So over 4 million messages, over $2.4 billion in volume in just the last few months here. Several thousand users, distinct addresses interacting with it every chain. And to me, the most interesting, the most appealing aspect of this is the growth and the permissionless expansion of Hyperlane. So not just the areas where the core team, our team, is operating Hyperlane, deploying it, but rather areas where teams themselves are running Hyperlane. And whether it's Stride, if you meet them here at the event, you can ask them about their experience with their Hyperlane deployment, whether it's Forma, whether it's Carrick, or the dozens of teams that are now progressing towards production with their Hyperlane deployments. So with this indistinct rectangle here that doesn't have a chart on it, what that is a screenshot from the public registry on GitHub, where Hyperlane deployments that are using the Hyperlane CLI to deploy it and operate it themselves can make a pull request with their deployment and the information about how to connect with that. And that is growing rapidly. Just the other day, as I was making this, there were 3 new PRs in a single day from new chains that are going live with Hyperlane. And so this is what permissionless expansion really is. There's more than 45 chains and apps that are already connected through Hyperlane. Over 1,000 in total distinct contracts that are interacted with it. In this registry, it keeps on growing. So I told you before that Hyperlane is the open framework for interoperability. But what does it mean to be a framework? What does it mean to be open? Like, how does that manifest itself? First, in some of those numbers that we've seen before, most notably the self-hosters. These are people who are not waiting on our team or any other team to connect with any other chains. They're taking it into their own hands. They're doing it themselves. They're operating Hyperlane, and no one can stop them. And if they don't tell us, if they don't post on the registry, we wouldn't even have a way of knowing. What's another way that this framework, this open framework mentality is manifesting? It's through expansion to new VMs. So today, Hyperlane is already live on CosmWasm and on Solana, and of course, on the EVM. But perhaps the most interesting part of this is that the implementation of both the Solana and the CosmWasm work, they weren't started by the core team. And in fact, in the Cosmos case, that was started and carried to production by the team at Mitosis, if you're familiar with them. Since then, we've had several other teams begin to build Hyperlane for new VMs. Pragma, which is a large oracle on Starknet, is just about done with their audit for a Starknet version of Hyperlane. Movement Labs built a Move version of Hyperlane. The Cadena team, the Rootstock team, there's a whole host of other teams that are building Hyperlane for their own VM. Why are they doing that? Why would they care? It's because they need an interoperability solution that can scale. They need an interoperability solution that they can control. And if someone was giving this to them, they wouldn't do it themselves. But no one is. So these people are taking it into their own hands, and they're contributing to Hyperlane because they know this is the only tool that they can use, that they could run on their own terms without dependency on anybody else, that they can own every aspect of it. They can own the security, they can own the actual operations, they can even monetize it. Some of these people will be operating Hyperlane themselves and running a business off it, monetizing the transaction fees. And I'd say if any of you in the audience today are familiar with the Telegram ecosystem, we're definitely looking for someone to help build a Telegram implementation, so we can add it to that list there. But so we've talked about, what Hyperlane is. Let's talk about what you can do with it. When you think about interoperability, you probably think about bridging. Well, unlike the standard concepts of bridging that you can see pretty much with every other protocol, Hyperlane does bridging a little bit differently. Of course, you could use it to do whatever you want. But if you want something out of the box, something fairly nimble, check out our warp routes. So where bridging normally is all the people put all the assets into one contract with one rigid security setting, becoming an increasingly large honeypot as that bridge becomes more popular. Warp routes are different. They're individualized on a per asset basis with distinct security settings, so much so even that you as the asset issuer can participate in the security of that bridge, and more on that later as I could show you a live case of this. Warp routes can be used to go to as narrow a set as one chain, say like you want a bridge from Ethereum to Solana, or you can use it to create a very nimble, fast bridge between a collection of chains as large as you'd like, where once you make that initial deposit, the asset can move between all of those chains freely, and it just gets burned and minted each time you transfer it. But that's pretty cool. People are familiar with this. Like, you can do this. You can actually go on our CLI right now and try this for yourself. The cooler thing is what we call yield routes. So everyone's probably familiar with like what Blast did earlier, or I guess late last year, with their native yield bridge. Pretty nice idea, right? Like, we have all these assets. They're just sitting in these contracts. Wouldn't it be nice if we could do something with them? Like, hell yeah, it would be nice. And so that's why Blast became really popular. People wanted to bridge into a chain, while also earning yield while they're doing that, while they're playing around with it. Yield routes let anyone do that. If you run a chain, you can use real yield routes to bring a yield-bearing bridge to your chain. How does it work? You know, in simple terms, because we're running out of time here. Assets go into the route. You, as the deployer of the route, configure which 4626 standard vault they go into. So there's plenty of vaults on Aave, Pendle, that will accept assets in this format. And then you just use it as any other warp route that you would. So you could have something go from Ethereum to Arbitrum, Optimism, Solana, Cosmos, wherever. And while those assets are in, you configure the vault that they go into. And all the while, they're earning yield. Some new features that are coming to yield routes are better customization about how to split the yield, allowing you to decide, like, maybe you want to keep all of it and use that as a revenue source for your business. Maybe you want to give it all to your users. Maybe you want to land somewhere in between. Either way, that upgrade is coming to yield route soon. Now let's take a look at a warp route in action. So on June 19th, just a few weeks ago, Renzo, one of the largest liquid restaking players, put EasyETH, their main LRT, on Hyperlane through a warp route. Coolest thing about this is, before, remember, we were talking about how warp routes can have distinct security modules. So this bridge, this EasyETH kind of thing, Renzo is in the business of providing security. They have a whole set of operators that are involved with their restaking token. Well, in this case, it's not, when you're using this, you're not trusting some indistinct group of Hyperlane folks. It's Renzo and Renzo's operators that are securing this bridge. This can only happen with Hyperlane. Launched with 8 chains, as you can see on the screen here. In those 3 weeks since, already moved $700 million with a single day high of just about 100. And a few chains have already been added in just the last few days, Frax most recently, and a few more that are coming shortly. Then we have the Hyperlane CLI. This is basically your main interface for all things Hyperlane. This is how you manage your Hyperlane deployments, how you make those deployments. If you're in a fun mood, pull up your laptop, try it out right now. You'll be able to deploy a warp route in minutes. You'll be able to deploy Hyperlane on your chain and then manage it. From there, the important thing to think about it with it, this is just your main gateway, your main access point for this open framework for interoperability. Before we go, some kind of use cases in the wild that don't involve direct bridging and use more general messaging capabilities. Most interesting might be Aave. Aave uses Hyperlane for interchain governance. So when something passes on Aave through governance on Ethereum, they no longer have to do a sort of manual process to push that update between Aave on all the different chains. They use Hyperlane, and they use layer 0 too, it's okay. and they propagate that between all other deployments of Aave. Superform is a very cool interchain yield app. You have money on some chain, but you want to earn yield. You don't want to start chasing yield between every different chain. Superform, through Hyperlane, lets you deposit in one place, and then they find the opportunities everywhere else. Mitosis has an interchain liquidity product that keeps improving and has an increasing set of offerings. Perhaps the one that I'm most excited about, and is going live very, very soon, is Everclear, that is using Hyperlane for their interchain clearing layer, which, if you're not, I used to, a long time ago, used to be at Morgan Stanley on a trading desk, and there's a robust network of clearinghouses that help make the system a little bit more efficient, but in crypto, we don't really use that, and so, in effect, we end up bridging a lot more than we actually need to, because there's no netting system, and Everclear is building that first netting system. So if you'd like to learn more about it, check out our docs, join our Discord. You can follow us on Twitter, or I guess now it's X, at Hyperlane. Our website's hyperlane.xyz. Come find me later, and of course, feel free to send me an email or shoot me a text. But I know we're running out of time. Thank you for being kind with me. And that's all we got.
Hello. All right, thank you, John. Next, we have Zahn from Initia. Hey, man. Nice to see you in real life.
Hello, everyone. My name is Zahn. I'm one of the co-founders of Initia. Thank you. I changed up my slide deck last minute. I was originally just going to chill Initia for like 15 minutes, but I instead want to talk about something more interesting. So I think we've seen a lot of infrastructure, all this demand for new apps, a lot of product that's coming out for connecting the modular expansion together. And I think one thing that's often forgotten is incentive alignment across these multi-chain systems. So at Initia, essentially, we are holistically rebuilding how multi-chain networks should look, feel, and operate. And that really comes down to three things: the architecture stack, the product stack, but also the economic systems that tie these together. And so today I'm going to introduce something called Initia VIP, which is basically our incentive alignment mechanism across the potential thousands of rollups on top of Initia. We're going to officially announce it next week, but we'll do a little sneak peek here. And it's all about basically lining up your ducks in a row. So what is alignment? It is essentially an agreement between people that want to work together because of shared interests. We have alignment within the Initia ecosystem across all these three different things. The first is infrastructure. Every single rollup on Initia uses the Cosmos SDK underneath. That means there is a shared underlying thread of infra across them all for things like native communication. There's also asset fungibility across Initia's world. So you never have to deal with USDC-A or USDC-B. We just have one form of USDC across the tens of rollups on top of Initia. The second piece of alignment is product alignment. So what does the UX look and feel like for end users that use one rollup or another? Ensuring that how you connect to wallets is the same, ensuring how you bridge around these applications is the same. And then the last piece is economic alignment. Basically making sure that every actor in Initia's ecosystem is, somewhat moving in the same direction. Even if they're not directly doing the exact same thing, they still care about the same direction for Initia as a whole. And that's why yesterday at a different panel, I gave a pretty saucy comparison that Initia is kind of like the Fed chain. And the reason I said that was because I imagined rollups a lot in Ethereum like the EU. Everyone's a state, but no one gives a shit about each other. But in Initia's world, I imagine Initia a lot to be like the federal government in the sense that we have opinions about how monetary policy should work. We have opinions about how transportation of these tokens should work. And then we leave it up to each individual state to build whatever they want, to ship the applications they care about, but they still care about the collective growth of the entire Initia country as a whole. And so how do we apply alignment to a hybrid layer 1 plus multi-layer 2 system? And that's basically finding a way for one underlying asset to unite all the different domains and applications within Initia's world. Get it into the hands of as many people as possible, and make sure that the init token is one of the denominating assets for invoicing as well as just use cases. The reason I say this is if you look at the first multi-chain world, that's Cosmos, you have Atom, which is the hub. That is nowhere. No one cares about Atom. It doesn't really do anything productive. It's not pushed into the other Cosmos chains. No one's like, I want to set up my liquidity pool with Atom as the base pair. But if you look at all of the rollups on Ethereum, everyone uses ETH for gas. Every single liquidity pool and lending market has ETH as one of the main pairs with the highest LTV. And that's something that's important when you're building a multi-chain system, because in our world, things like gas fees are not going to do much for Initia value accrual. We're in the business of building block space. And so rather, we're looking to create utility for our token across all of the rollups on Initia. And so that's where we came up with Initia VIP. It stands for Vested Interest Program. How it works is essentially, okay, imagine this jar of M&Ms is the init token supply. We take out 10% of that init token supply, and it is now for VIP exclusively. And then we create a stream of this 10%. So just like validated rewards, every block, some of this 10% is emitted towards the Initia VIP program. Now we take this stream and we essentially allocate it to various layer 2s on Initia. So each month on the layer 1, there is a gauge vote. Gauge votes are something from DeFi, where people on the layer 1, they come and they vote and they say, okay, 30% of this VIP stream is going to this layer 2, 30% is going to this other layer 2, 40% to the last one. Now on each one of these layer 2s that is receiving a stream, there are 2 ways to distribute these rewards directly to end users. The first is init balances held by a user on that chain. So whether it be in the smart contract system that exists there or their balances within the rollup. The second is a layer 2 defined KPI. And that's because we want layer 2s to basically incentivize whatever they care about, not just one thing that we declare. And so these streams are basically directly distributed to end users based on these parameters. It doesn't go to the layer 2 operator. They can't rug the users. It goes directly to end users. And this layer 2 set KPI can basically be anything that can be tracked on chain. So if you are a lending market layer 2, you can say something like borrows. If you are perpetuals layer 2, you might say, I want to incentivize my users based on their volume. Maybe it's mints of an NFT or rolls of a dice in a game like Civicia. Basically, whatever you want, we can distribute these rewards to your users based on it. There is one twist, though. We don't directly give users init tokens that are unlocked. We give them escrowed init tokens that are then basically unlocked based on engagement and retention. And so how does this unlock work? Essentially, if I, as a user, earned a bunch of rewards by trading perpetuals on this platform, I have to maintain my init balances on that layer 2, and I must maintain my volume, if that's how it's distributed, over time to slowly unlock these rewards. As I maintain those volumes, I am contributing back to the layer 2 there, and they're earning their fees that way. I'm earning additional rewards, and I'm also earning more escrowed init rewards over time to keep me a long-term, happy, aligned user. And so let's walk through an example because I know it was pretty confusing. So say that this month's VIP rewards are 1 million escrowed in it, and we have a gauge vote on the layer 1 here, and we allocate this much to each layer 2. Then we specifically look at one Minutia. It has 400,000 escrowed inits this month. And we look at one user of 10 uniform users. So they've all done the same volume, for example. So on week 1, if I do $1 million of volume and I have 50 init on that layer 2, I would earn 10,000 escrowed inits, essentially because you have 4,000 for this month divided by 4, 1 for each week, and then divided by the 10 users. However, none of those escrowed inits are unlocked yet. In week 2, I do basically the exact same metrics. I do another million of volume. I still have my 50 init. I would earn another 10,000 escrowed inits, but I would begin to unlock the escrowed init from my first week. So the first 10,000 over 52, I would unlock those and I'll be able to do whatever I want with that, whether that be staking or selling or anything else. In week 3, I drop my volume down to 500,000. And so I only earn 5,000 escrowed inits. But what happens is, because I didn't maintain my full engagement of the 1 million from week 1, I only earn half of the vesting for that week. So I only get 96 and another 96 from week 2. And then in the last week, if I did back to 1 million volume, I would then have the full vest from the first week, the full vest from the second week, and the full vest from the third week. And so how do participants essentially benefit from Initia VIP? Well, for validators, it creates an actual use case for governance to be important on the layer 1. Every layer 2 has to care because the gauge vote is held on the layer 1 by layer 1 stakers. And this can create really interesting design mechanics where you have essentially people bribing layer 1 stakers to vote rewards to their layer 2. And on an L1's perspective, it is very important because there is more in it essentially being locked across all of these layer 2s, and we're building new use cases for them. How do layer 2s benefit? Essentially, Minitias and their operators can choose to take a commission of the rewards from VIP. This means they could take something like 5% of the supply of the VIP reward stream, similar to how validators take a commission of staking rewards. And L2 end users basically get incentives for doing and using the applications they would already typically do. And so this creates a really interesting cycle of momentum where you have incentivization leading to increased usage and increased usage leading to larger incentivization. So essentially with Initia VIP, Initia wins when Minitias win, and that's the whole goal of building infrastructure. You are trying to enable more interesting, more powerful applications, and we essentially only win if layer 2s on Initia win. All right, so enough about infra and our economics. I'm just gonna shill 3 layer 2s on Initia right now that I think are pretty kick-ass. So one of them is called Blackwing Fi. They just won a Binance Accelerator like 2 days ago. They are doing liquidation-free margin trading on any chain. That means I can perform leverage on any asset, on any chain, without liquidation and without Oracle risk, which is like the goddamn best application in the world for the meme coin cycle. If a shitcoin comes off Pump Fund and is on Radium now, through Blackwing, I can trade it with leverage, long or short. If there is a token on Thruster on Blast, I can trade it with leverage, long or short. If there's a token anywhere across any of the Sovereign rollups or the other Initia rollups, through Blackwing, I can trade it with leverage. And that is, basically the end game of what trading should be like in crypto. And how they do it is they use a system called limitless pools. What that does is you can take any concentrated liquidity pool, collateralize it, and then perform leverage on the assets underneath. And by using an intent design with their layer 2, they can do all the cross-chain messaging and bridging for the users without them having to sign transactions. So similar to DYDX v4, you sign on Blackwing once to create a wallet. They create you wallets on 50 different chains, and then they do all the trading in the back end for you. The next one is Milky Way Zone. They are also a layer 2 on Initia. Milky Way is the first and biggest staking and LST platform for Celestia and TIA. And they're also now building a restaking platform for remilked TIA. They don't actually call it that, but I'm trying to force them to call it that. As well as remilked Init, which will be very good. And basically within the modular ecosystem, restaking and AVSs have tons of use cases, especially with people that are long-term aligned with tokens like TIA. And so we can use Milky Way to secure things like sovereign rollups, as well as stuff like IBC relayers across Cosmos's ecosystem, which are notoriously a little suspicious when you have rollups being validated and bridged to with IBC. The last one I want to talk about is Contro. The guys in the audience right there, go talk to him later. He is basically building something called the GLOB, right? Very cool name. It stands for the Gradual Limit Order Book. And what that does is it slows down the time of markets to create basically a TWAP mixed with an order book. And why would you say this is interesting? Well, essentially, it's infrastructure built for prediction markets. If you look at prediction markets right now, like poly markets, which are incredibly popular, people love to gamble. One of the problems they have is front running. If someone finds out information a split second sooner than someone else, they can essentially snipe an entire betting pool and win the full outcome. Now, that's not really the most fair way that betting markets should be placed. It should depend on basically not when you buy into the trade, but rather just who thinks one way or the other. So with the GLOB, there is no front running that's possible. Essentially, the slowed down markets ensure that if I think, Joe Biden is going to drop out of the race and someone else thinks that as well within the same time frame, we both would share in the same outcome, even if some new information drops last minute. So it creates ultra fair prediction markets, which is basically what you want for those types of things. Sweet, that is everything I want to talk about today. If you're interested in learning more about Initia VIP, come hit me up on Twitter or Telegram. You can find me at It's Always Ani. You can follow Initia at initia.xyz and follow all 3 of these layer 2s that I talked about today. They're building some awesome infrastructure with us, and we'll have plenty of VIP reward streams in the future.
All right, thank you so much, Zahn. We have a couple minutes for any questions, if anyone. All right, well, another round of applause for Zahn, and I believe it is now lunchtime, so applause for that too.
Lovely.
afternoon session with Orkin from Citrea, and we're going to start the Bitcoin part of our talk. So, Orkin, thank you very much.
Hey. Hello, everyone. So today I will do my least technical talk, probably. I will talk a bit about the idea of hyper-Bitcoinization and our story and how did we get there and what are our plans to achieve hyper-Bitcoinization through modularity. I'm co-founder of Citrea, Bitcoin's first zk rollup, and I will just start with going a long way back to Bitcoin. And this is the first sentence of the Bitcoin white paper, which Satoshi says, a purely peer-to-peer version of the electronic cash will allow online payments to be sent directly from one party to another without going through a financial institution. So this was more than a decade ago, and Satoshi had only one idea in his mind, and it was single use case, payments, and simple goal, no centralized financial institutions or intermediaries. So, but this was more than a decade ago, and some things probably changed since then. It's a very simple idea, but he solved that problem with the Bitcoin white paper and the implementation. And 5 years after that, 6 years after that, there is an old Bitcoiner now, he supports BSV though, but Daniel Kravitz, he came up with the idea of hyper-Bitcoinization in a very short article and defined it like this: hyper-Bitcoinization is a voluntary transition from an inferior currency to a superior one, and its adoption is a series of individual acts of entrepreneurship rather than a single monopolist that games the system. So he is talking about a world where Bitcoin is the dominating currency, and it is probably not only used in payments, but everything in real life or online payments. It can be lending, borrowing, it can be buying stuff, it can be just some giving money for your friends instead trusting them. And here he also talks about the inferior currencies and puts another thing in his article, talking about hyperinflation. And hyperinflation happens very, very similarly to hyper-Bitcoinization, actually. In these two events, in hyperinflation, the price in the doomed currency will skyrocket. And in hyper-Bitcoinization, it is also not so much different. The price in the doomed currency will skyrocket. So it's a very relevant concept. And he also thinks that hyperinflation will come after hyper-Bitcoinization, but start around the same time. And this is inflation rates from a couple countries, Turkey, where I'm from, Argentina, and Zimbabwe. And we already started seeing signs of hyperinflation in Turkey and Argentina for the last couple of years. And in Zimbabwe, it already happened. But now they just removed their currency from circulation and then pushed again, and now they're experiencing the same hyperinflation. So just as an example, if you want to buy eggplant from grocery, you have to pay more and more each day. So the price of the eggplant in that doomed currencies is started skyrocketing. And at the same time, if you just look to the hyperinflation and correspond to the hyper-Bitcoinization event, you will see that this Turkish lira against Bitcoin now worth 0. Argentinian peso worth 0. So I think now you can correlate the hyperinflation and hyper-Bitcoinization. So the price of Bitcoin in these doomed currencies already started skyrocketing, and it's going more and more. And USD, not so different. I think while I'm talking about in every single podcast, I already mentioned Turkish lira because this is where I live in Istanbul. But people think that, oh, Turkish lira is so bad, and US dollar, it's doing fine. Okay, it's fine, but it's not fine, and it will end up just like Turkish lira. And why we call BTC as the superior currency, but not just any other inferior currencies, because Bitcoin is decentralized, Bitcoin is censorship resistant, and more importantly, Bitcoin is borderless. So all of these countries, they have some kind of capital control. They can control their own fiat currencies of people. They can also control maybe other fiat currencies of other countries for their own people, but they cannot control your Bitcoin. And this is where Bitcoin hyperinflation will be affected, because they cannot control the hyperinflation. They can control the hyperinflation, but they cannot control hyper-Bitcoinization. This is also a graph from a Bitcoin writer, an anonymous writer, and he describes the hyper-Bitcoinization growth model, which is very similar to the crystallization event of a mineral. And he puts these 3 different phases, like equilibration, nucleation, and crystallization. And each phases, this is where actually Satoshi started, and this is, I think, around 2010, where we see innovations, we see small meetups, we see miners joining the Bitcoin, but Bitcoin value is still so low, and his only have like maybe $100 or $1,000 value. But the phase after it, we start seeing engineers working on Bitcoin. We start seeing pools working on Bitcoin, increasing hash rates, increasing adoption and security and conferences. And this is the micro bubble phase where we start to see Bitcoin adoption and the rapid price appreciation started to happen. And I think this is where we are now. Now we are seeing new kind of exchanges instead of empty gogs. And we are seeing layers built, especially for the last 1.5 years. There are a lot of people trying to build layers on Bitcoin. And it has a reason I will come back. And the industry use. This is already happening with some of the institutions that's adopting Bitcoin for their treasuries or for just backing some of the stocks. And there's a tipping point where we see all this curve happening and going to the institutions, banks, and governments. But at the same time, Bitcoin is now becoming more of a medium of exchange and then unit of account instead of staying as a store of value. And meanwhile, there is this rapid price appreciation events and ending up with minimal price volatility. So like I said, we are coming to the tipping point. That's cool, that's fine. We are seeing new exchanges, we are seeing new layers, we are seeing industrial use. But how do we scale there? Like how to handle this rapid price appreciation and then minimal price volatility? Because in there will be tons of activity. There will be people trying to use Bitcoin in action in real life, and current Bitcoin L1 cannot handle it. This is the challenge from just moving from store of value to unit of account. Bitcoin L1 cannot scale to everyone, and Bitcoin L1 cannot scale for all use cases as well. If you want to do all of them, then enable a Turing-complete smart contracts on Bitcoin and put terabytes of blocks. Do you think it's scaling? No, it's not scaling. It might cover these use cases for some time, not for unlimited time, but it is still not scaling because now you are losing your properties like decentralization, censorship resistance, and becoming borderless because now you are putting limits on people's computer. So how to solve this challenge? Like L1 doesn't scale, okay, that's fine, but where is the answer? I think we can just turn back to the definition of hyper-Bitcoinization. Hyper-Bitcoinization will be achieved through a series of individual acts of entrepreneurship. And actually, modularity is a series of individual acts of entrepreneurship. Rather than pushing a single monopolist that will game the system, just like the L1, instead, we try to just specialize on a couple things and do it better than everything else. And we can connect them all to the Bitcoin, so Bitcoin can scale for everyone and all the use cases. We are building Citrea, and Citrea is the execution shard of Bitcoin. With Citrea, you can build Bitcoin applications without the scaling or programmability limits of Bitcoin L1. But I want to talk a bit about the background of Citrea as well. We started our company 2 years ago in Istanbul with my other co-founders, Ekrem, Esad, and Murat. And our idea was, okay, let's build some privacy systems on crypto because there's not enough privacy on chain. And this was just maybe weeks after Tornado Cash sanctions. And we built privacy on Ethereum. We built proof of innocence. Then we built privacy pools. But around the same time, we saw that inscriptions are happening on Bitcoin. Okay, inscriptions are cool because now people are demanding Bitcoin in action. Instead of just keeping Bitcoin as their store of value, they want to use Bitcoin in action. They want to buy and sell stuff with Bitcoin. They want to lend Bitcoin for their digital art. So there's a need of Bitcoin as a medium of exchange. And we realized that, okay, so we'll all love Bitcoin. Why not just build something on Bitcoin and started our journey? Built several API endpoints, indexers, and we realized there's not enough development in Bitcoin happened for the last more than a decade, like last 15 years. So instead of just dealing with the base infrastructure, we said, okay, let's build a rollup on Bitcoin that can enable all these use cases for everyone without getting through the L1 limitations. And this is where Citria idea started around a year ago in last HCC in Paris, actually. I was talking with all these people in Modular Summit, including Celestia guys, including Sovereign Labs guys, and that's where we decided to build this rollup and leave all the other products that we are doing. But this is not ideal. We don't want everything to be built on Citria. We want layers on top of Bitcoin that is specialized in different things, that's all connected through these Lightning channels, chain abstractions. People can seamlessly interoperate between all these layers. They can use Arc for privacy. They can use Mercury layer for just using channels in a private manner. And they can use Citria to build Turing-complete applications, like other privacy applications, just mixers or like private swaps, private transfers. And on top of Citria, now you can build all the other VMs. You can build MoveVM, you can build SVM, and they can use different DA layers. They can use Celestia, they can use Avail, but everything will be connected with BitVM without limitations of the Bitcoin L1. So that's our goal, how we see Bitcoin in the next 10 years, so that with this table, now we can scale Bitcoin for all use cases and to everyone without getting through custodials, centralized financial institutions, or intermediaries. And lastly, modularism, not maximalism. Thank you for listening to me. If you have any questions, I can answer here or outside.
All right, thank you very much. We have some time for questions. Any questions? All right, thank you very much. Another round of applause. Oh.
Thank you. Yeah, I'm very curious about two quick things. The first one is like, what are the trust assumptions that you add? Is it like a ZK rollup built on top of Bitcoin? So you use OPCAT and then you settle. So that's my first question.
Yes. So first, OPCAT unfortunately doesn't exist on L1 today, so you cannot build anything with OPCAT. But we are building a ZK rollup on Bitcoin that inherits Bitcoin's double spend resistance. So we inscribe that ZK proofs. Instead of just sending them to a smart contract, we inscribe them on Bitcoin so that you get this double spend resistance. You simply determine the correct fork of the chain of Citria through L1. So you get this double resistance, reorg resistance, and then censorship resistance capabilities by enabling forced transactions. But this is not enough to have a bridge in between Bitcoin and L2. So in there, we are utilizing BitVM's ZK verifier code. We have a custom software called Clementine, and it's public on GitHub. So it is where we simply optimistically verify the ZK proofs with a permissioned set of validators. So as a security assumption of the bridge, it is very similar to like Arbitrum today. You can think there's a permissioned set of validators that watch the chain and challenge invalid state roots. So in here, there's also a permission set of verifiers that looks to the Citria and challenges if there's an invalid state root on the L1. But instead of challenging the state root, they challenge a ZKP. So we can optimistically verify ZKP in chunks on Bitcoin instead of verifying them all in once.
But then if you don't have OPCAT, you cannot verify ZK proofs on Bitcoin. So I don't really understand how do you consider yourself then if you don't have OPCAT? You're not really a layer on top of Bitcoin because you don't really settle on Bitcoin, right?
So you settle optimistically. So the ZK verification without OPCAT, you cannot build in a single block. So today there's a ZKP verifier script, which is around 5 gigabytes. So it is way over, like exceeds the block limit. But instead of just running that script, you divide that script into chunks, and the prover simply assign each input and output with Lamport signatures, and they are verifiable in Bitcoin script. So instead of running all the computation, you simply run the incorrect part on Bitcoin, so that you still get this Turing complete true or false from Bitcoin. So Bitcoin can now decide whether that state root is correct or not. So actually Bitcoin settles these proofs, but it settles optimistically rather than just settling all in once.
Can I find this code? Is it on your repos? Or?
Yeah. I can definitely send a link to you as well.
Okay, thank you.
what is your hard finality?
Yeah. So similar to, you can think of optimistic rollups where they send the transactional data on the L1 and full nodes get confirmation just after it, but the light client on the L1 get the confirmation after like a week. It's very similar here. So once we proved the ZK EVM, the L2, and then inscribe that proofs on Bitcoin, then people can simply look at the proof and verify them and apply the state diff tier to local so that they can now have the finality of the chain. But for the light client in Bitcoin, which is settled through BitVM, we have now 3 weeks settlement period. It is also like 4 weeks, but we are working to like reduce it to 3 weeks with non-interactive proofs. But right now it is 4 weeks to settle a ZKP on Bitcoin.
All right, thank you very much.
Thank you.
Another round of applause. And next we have Eric Wall from Taproot Wizards. And
hello, everyone. Assuming that you guys are getting pretty tired of watching presentations, I'm going to try to keep this lighthearted and fun. So my talk is going to be about like what's happening with Bitcoin, like really, and is anything happening with Bitcoin for real? And is Bitcoin going modular? And why would it be going modular? And what's the deal with OpCat? Is it even happening? So quick intro about me. I am Eric Wall. I'm the a co-founder of Taproot Wizards. We are accused of running the largest spam attack on Bitcoin in its history. And this is going to be an apolitical and unopinionated talk, except it's not, because there are no apolitical and unopinionated talks in Bitcoin. Either if someone thinks that they're doing that, they're either brainwashed or they're lying to you. Everything is very political in Bitcoin. And on that note, if we had OpCat, this is what the world would look like. This is a completely unopinionated opinion. Some might say that, you know, this looks awesome, this looks fine, but there's too much MEV going on in that image, so we don't want that. And now you're fully caught up to the current discourse in Bitcoin. That's what we're discussing right now. So some recent history about is anything happening on Bitcoin. Well, you all know probably ordinals, of course, caused economic demand for the chain in a new way. Some call it spam, others call it innovation. But clearly there's something that's happening on Bitcoin. Like this is the mempool since 2017. You can see this mountain here. That's a lot of people trying to get their transactions into the Bitcoin blockchain. So it looks like something's happening on Bitcoin. And if you look at this chart, this is the fullness of blocks. And you can see that right here, about 18 months ago, the blocks just got very, very full for some reason. And Bitcoin blocks being full causes these kinds of things to happen in the mempool. $25 to make a transaction. And this led to some pretty interesting results that some Bitcoiners weren't aware about, that if you have a Lightning channel that's open, it might automatically force close once you reach a current fee level. So you had people Lightning channels turning off, and then they were too expensive to turn back on again, and it would cost more money to, if you received a small payment, it would cost more money to settle that on-chain than what you got in the payment. So small payments suddenly didn't work on Lightning anymore, and it led to a bunch of people. This is from Ben DeCarman, who's the developer of Mutiny Wallet, which is a popular Lightning wallet, saying like basically we got to rethink Lightning. What is this system actually like supposed to, like who is it supposed to serve? And this is from Shinobi in Bitcoin Magazine, saying that Lightning, it's not going to be a protocol that's going to work retail to retail, but it might be good for something else. And this is not bad news for Lightning. This is how it's always going to be. So they're like sort of changing the narrative what the purpose of Lightning was. And you have John Carvalho, also a Lightning builder, saying that the design of Lightning is kind of a joke after being like a large advocate of Lightning for many years. So that was one good thing that sort of came out of the spam attack of Bitcoin. And we also achieved some other things. So we finally beat Medicare. We finally beat Ethereum in daily transaction fees. And who would win? You got all your 200 rollups, you got LSTs, dApps, MEV, and we got a dick butt that we put on our chain, and somehow, we're able to compete with Ethereum in fee revenue. So I don't know what you guys are up to, but you can do a lot. Like a dick butt can get you very far. But not to sort of humble that statement a little bit. So these fee spikes in Bitcoin have been kind of irregular and spiky. You see the yellow part here as the ratio of Bitcoin rewards that are comprised of fee revenue versus the regular block subsidy. So yeah, it has increased, but mostly in like these spikes. And yeah, we're higher now, but in Ethereum, you're around like 20% of the blocks are from fee, like 20% of the revenue from blocks are from fee revenue in Ethereum, and we're not like quite there yet in Bitcoin, but we've made some improvements. So yeah, man, is something happening on Bitcoin? Like, I think we can conclusively answer that question that yes, there is something that's happening on Bitcoin. And now we're going to talk about like what's happening in Bitcoin, and this is not going to be news to anyone, but what basically happened, like this is the 28th, like this right here is the 28th of June, where I made an observation that Bitcoin DA at that time was 10 times cheaper than Ethereum call data. So that's interesting for people. So if you want to build a sovereign rollup, okay, you're going to get 10 times cheaper DA on Bitcoin. And Bitcoin DA is also, it's a premium commodity in the sense that we constrain our blockchain to only grow by 200 gigabytes per year, which means that you're going to be able to store a full Bitcoin node with a full history on your own computer, and a bunch of other people are also going to do that. So there will be a bunch of default clients storing the entirety of the blockchain, not pruning their history, because we constrain it so that it's so small that people can run it with the default non-pruning settings. So like 2 days after I made this observation, the Bitcoin blockchain has been completely full ever since. And we also played around with this. We put a Taproot Wizard JPEG around here, and then the chain has been full of spam ever since, basically. And we didn't think about it like we're spamming the chain, and we thought about it like Ethereum people are always complaining about you're gonna run out of fee revenue for your chain, and like the halvings keep coming, and you're not gonna be able to have enough fee revenue to have a security budget for Bitcoin. So we kind of thought about it like we're trying to save like the security problem of the security budget of Bitcoin. We're not like trying to attack. I thought this was the big issue with Bitcoin, that we don't have enough. Anyway, people thought it was an attack. I still think that we're saving Bitcoin. But so let's talk a little bit more about what is actually happening on Bitcoin. And so it hasn't been all like JPEGs. Yes, a lot of people created these meta token protocols. Everyone wants fungible tokens that they can trade on Bitcoin. And so BRC20 tokens did play a large role, but this is the red part here is images. And in May this year, like we still had like 50% was still images. So it's a mishmash of things that people are using the Bitcoin DA for. We kind of dropped off. Like this is here in May where ordinals died again. But that is actually because there's another protocol called Runes, which doesn't use inscriptions anymore, but you can see that like almost 50% of the fee revenue in Bitcoin is coming from this protocol. It's called Runes, and the sort of the trend of using Bitcoin in more interesting ways is taking different forms, but it's still there. Yeah, I think right now, like in nominal terms, Bitcoin produces maybe like a third or a fourth of Ethereum revenue. So like in nominal terms, we're not producing tons of revenue, but still way up from where we used to be. Let's see. Did my clicker stop working? Okay, so what causes it? Super briefly, so some people think Taproot caused this, but Taproot was like a small incremental change that just made it slightly more easy to pack data into the arbitrary blob space, sorry, the arbitrary data space of Bitcoins. It wasn't really like Taproot changed the game dramatically. Like it was a small thing that happened with Taproot. More than that, it was like a social event where like degens and creatives decided that we can use this common protocol and make things and make NFTs and trade them. But even more than that, I think it's people like Udi Wertheimer and Leonidas just tweeting about this stuff nonstop, making people pay attention to this. But even more than that, it's just the fact that this made Bitcoin maximalists so angry that we're using Bitcoin in this way. So that was really the thing that made this very popular, because there's a bunch of people that are Bitcoiners, and then there's like this small clique of Bitcoin maxis that are very angry and they're like very opinionated, and it's you just can't resist like putting a dick butt there and making them get very angry. So we're gonna go into a small segue, like what is Bitcoin actually for? Like what do people actually want to use Bitcoin for? You might think it's like stacking sats, holding, using Lightning, or like buying things on the dark web, transferring stable coins, smart contracts, stored JPEG dick butts, privacy and human rights, Michael Saylor, number go up, SEMcult. Like in reality, it's all of these. It's all people want to do all of these things with Bitcoin. And here's the little secret. So we want to be able to do all those things on Bitcoin, but we have technical constraints. Like our main priority is to make sure that the chain is decentralized and censorship resistant. So the extent to which that we can do all those other things I mentioned are defined by our technical constraints. And the technical constraints informs the social dogma. And the social dogma then kind of informs the technical constraints, unfortunately, sometimes. So like when you see a group of people in Bitcoin, and you're like, okay, those guys are the Bitcoiners, and you see them like eating steak and sunning their balls and complaining about the ETF and Ethereum. It's not that those are it's filtered by the things that you can do and you can't do with Bitcoin. So if the only thing that you can do is like sunning your balls and eating steak on Bitcoin, if that's the only thing, those are the Bitcoiners that you're going to see. So if you can't do smart contracts on Bitcoin, the narrative will be that smart contracts are not good. But if you could do smart contracts on Bitcoin, then the narrative would be that Ethereum is going to be displaced by Bitcoin. So like it changes, and just to like give some example of that, so Taproot, for example, the latest soft fork upgrade in Bitcoin, it was a multi-signature improvement, and made scripts larger essentially. But the narrative in the Bitcoin space kind of became that we're going to be able to do infinite complex smart contracts on Bitcoin. And people will say these things like the things that we're going to do with Taproot is going to blow your mind. So all of a sudden, because it's possible now on Bitcoin in a decentralized, censorship-resistant way, now the narrative is that smart contracts are awesome. Except that what happened in reality was that there was Taproot didn't do anything these things at all, and this is the adoption rate of Taproot during the first year. And then something happened. Can you guess what happened over here in early 2023? Well, that's when we started to put dick butts on the chain, in the form of Taproot transactions anyway. So Taproot did blow people's minds, just maybe not in the way that they wanted to. Anyway, so alongside this, with increased interest in Bitcoin and like higher fees and Lightning obviously failing, there's been like demand for new layer 2 protocols. So in May 2023, something called ARC was announced, and ARC was a way to basically do Lightning, but without the annoyance of Lightning channels. And if your mental model is that Bitcoiners only want to stack sats and they want to use Lightning, then why are people so excited about like this new Lightning protocol? I thought Lightning was great. Like thought that was the thing that you want to use. So like it shows that people are not really satisfied with the current state of Lightning. And then in October, you had BitVM, and Robin Linus drops this banger of a white paper, which basically says the tagline is compute anything on Bitcoin. And like I haven't seen since like maybe the launch of the Lightning Network itself, the amount of interest among Bitcoiners, like actual Bitcoiners, that really thought that this was great and something that we should do on Bitcoin. So that goes back to what I said, like the technical constraints informs the social dogma. So if the technical constraints changes, so does the social dogma. Right. So, and we've had more protocols, like this is a Bitcoin native roll-up thing that the same inventor of Arc has made. That's also like people are like those things. And it's constrained by what you can build that sort of informs what people like on Bitcoin. So you shouldn't think that Bitcoiners only want to do this one particular thing that you've seen them do on their podcasts. Let's see. Yeah, so people sometimes talk about these BitVM, Arc, roll-up protocols. We usually talk about like a 1 out of n honesty assumption that these protocols have in some way, and most people think that that is fine because when you look at Arbitrum, they have whitelisted verifiers, sort of similar, right? But there are more problems with these protocols that we're trying to build on Bitcoin now without making any changes. And this is when opcat comes into the picture. Let's see, I have 3 minutes left. Let's see if I can finish this. How opcat really came into the picture is like opcat is a soft fork upgrade to Bitcoin. It introduces a new opcode that allows you to concatenate elements on the stack. Sounds very, very, very primitive and simple, but you can do pretty interesting things with just that small new added functionality to Bitcoin. So interestingly enough, like Robin Linus, the inventor of BitVM, mentions that you can use opcat to make BitVM 100x more efficient. And I think that has to do with the ability to do Merkle root verification in BitVM. So if we had opcat, then maybe these protocols would start to become more practical. And Brock, the inventor of Arc, is also saying like, he's really looking forward to something like opcat because you could with Arc have instant finality and double spend prevention, and you could turn it from an interactive protocol to a non-interactive protocol. So these L2 designers, like they really are seeing the point of using something like opcat to sort of fix their protocols. But there is a more fundamental issue that's rarely talked about. This is, I don't know how to describe what I'm trying to depict here, but so what is very rarely talked about these protocols like Arc and BitVM is that they require a liquidity hand crank to make the protocol work at all. So in BitVM, the bridge operator has to, like when you make a withdrawal from a BitVM bridge, the bridge operator has to front everyone with the money for the withdrawals that they've withdrawn, and then he can reimburse himself. So he needs like a bunch of cash on hand and sort of spin this this liquidity hand crank to make the system work. The same thing was with Arc. Like Arc didn't remove the Lightning channels. It just said that there's going to be a third party called the operator who's going to make channels for everyone, and he's going to be responsible for maintaining all that liquidity. We can't, you can build a bunch of things on Bitcoin today, but you can't really get away from these. This has to do with the only thing that you can do when you're trying to build these protocols. You have to use something called pre-signed Bitcoin transactions. And those protocols can't really define, they have to when you construct them, they have to define where can these funds go, so you can't really enter a contract and be a new user and make a withdrawal to you. So they're fundamentally limited in their design. Luckily, upgrading Bitcoin has been on the agenda for quite some time. This is from Roastbeef from Lightning Labs, an unofficial roadmap thing that has been talked about among a bunch of people is that we want to get generic covenants into Bitcoin. And generic covenants, the way that you can think about them is that if you have a UTXO in Bitcoin, you have the input side. These are the inputs that you're trying to spend. And then from that, you are trying to make new unspent transaction outputs from that. And we know how to, on the input side, like satisfy the requirements for those inputs. Like, yeah, we can prove that I own those funds by demonstrating a signature or a pre-image of a hash lock. But covenants allow you to restrict what happens on the output side. So we can say this output that comes out of this transaction needs to look in a particular way, so that you can move Bitcoin UTXO essentially from one state to another, sort of like a state machine fashion, and you can create these sort of mini computers inside of Bitcoin, and you can start to create something that actually looks like the traditional withdrawal games that you have in an optimistic rollup or other L2 designs like Plasma on Bitcoin today, if you have that covenant primitive. So if you want to understand like what Opcat is, take a picture of this real quick. This is the best website to like understand what is Opcat. There's also a song by Jonathan Mann. If you haven't listened to this song, I highly recommend that you do. And another interesting thing about Opcat is like Opcat is already in the code of Bitcoin. Like you can still, it used to be in Bitcoin. It was designed by Satoshi himself. He just deactivated it. Let's see, how long is it? Like 14 years ago. So we're not like trying to come up with some new crazy thing. We're just trying to activate a previously deactivated opcode that already exists in the code base today. So our company, we created like in order to get people to draw attention to this opcode, we created an NFT collection that sort of evolves with time as we get closer to Opcat activation. More layers and traits will be concatenated as layers on top of these cats, sort of pay homage to like how Opcat works. And if you're interested in like the process and the progress of Opcat, there's a link here. I'm going to show it later. How far along we are in the stage of Opcat activation. And if you have ever used mempool.space, all Bitcoiners know about this. Opcat is already activated on Signet now, so you can like make Opcat transactions. You can start playing around with it, and it will be visible in this well-known block explorer that everyone uses. So people are already using it on Signet. It's already activated there. And why we want to do that is that we want to get away from this liquidity handcrank thing, right? That's the thing that we don't want to have. We want to be able to build things where if I have funds in a bridge, I can withdraw those funds to me. I don't want an operator to have to send me funds and then he refunds himself, and it creates this sort of liquidity inefficiency. We have a white paper, sorry, a children's book. Yeah, it's so we have a children's book. If you go to catvm.org, you can read about how you take the CAD opcode and build something that looks more like an optimistic rollup without like liquidity handcranks. And so far it's going really well. Right now Opcat is like the front runner soft fork for Bitcoin, and it's not like I don't want to take the credit for like our company or our effort. What we basically analyzed was that Opcat has broad support from the Bitcoin ecosystem. This is Blockstream. Blockstream was largely the company that was involved in the previous soft forks of Bitcoin. They are also fans of Opcat. They only have good things to say about it, how simple it is, and like the extra functionality it provides to Bitcoin, even in like custody situations. So the effort to activate Opcat, I like this tweet. Like 8 months ago, Opcat was like a fringe proposal, but now it's gaining broad support. And if you were at the most recent Bitcoin-centric developer conference in Austin, the consensus among the developers there was basically that we want Opcat. So we already have a developer consensus that Opcat is going to get activated. Of course, there are more constituents in Bitcoin than just the developers, but we're on very good track to actually getting this activated. And if you want to follow along to how this is going, there's a website link here beneath that I recommend you to check out. And I'm way over time, so let's see. Yeah, if you are interested, like
if you're in Ethereum or in the Celestia space or any other space, and you want to, you're thinking that maybe I can, use this thing called Opcat, and I can maybe create optimistic rollups or plasmas or other designs. The competition in that space right now is extremely low. And we're talking about $1 trillion asset, right? Bitcoin, building on Bitcoin. And you can be, like, the competition is so low, like even if you're just a mediocre senior architect building roll-up plasma type designs, you can be a superstar in the Opcat world in Bitcoin right now. So if you're interested in that, this is my handle on both Telegram and on Twitter. Hit me up if you're interested in hacking on Bitcoin. And I think I'm way over time, so thank you guys very much.
Thank you, Eric. Thank you very much. And now we need to set up for a panel, so give us a few minutes. But I will say that Jonathan Mann video, the song, incredible.
I recommend everyone to check that out. I listen to it every morning. I brush my teeth to that song.
Okay, that might be a lot, but thank you. Thank you, man. All right, and our next panel will be moderated by Andy from the Rollup, and should be here. I believe he's here. Yeah.
Hello, hello.
Welcome to the Bitcoin Goes Modular panel. Excuse my voice, it's been a long week doing a lot of conversations. And today, kind of building off of Eric's talk, I think that there's a lot to be discussed on kind of the why side of things as well as the how in terms of Bitcoin going modular. So why don't we start with some introductions and then we'll jump right in. And Connor, we can start with you and go down the line.
Hi, I'm Connor. I'm a solutions engineer at Celestia Labs.
Hi, I'm Rena. I'm the COO of Stacks, the Bitcoin L2.
Hi, I'm Morkon. I'm co-founder of Citrea, Bitcoin's first CK rollup.
Awesome. So I think that we have had quite a few technical conversations, and before we get into some of these innovations, I'd like to lay the foundation for the entire conversation as to why. And so the first question that I'd like to pose is, why is it important that Bitcoin kind of goes away and trends away from this ossification of just being a store of value and payments rail and kind of scales with more programmability into this modular fashion?
One reason I've heard is that there's a security budget concern and that the chain needs more revenue from usage, and L2s are a way to get that.
For me, it's like, why would I leave $1 trillion asset just resting as idle capital? And I would want to deploy it from passive to productive and make that be a productive asset. And by going modular, at least I have the shot of Bitcoin DeFi, which might be the most promising thing in the industry.
Yeah, I think it's like just combination of both, where you need, like, people want to use Bitcoin and Bitcoiners want people to use Bitcoin as well. But if there's no option to use, and if there is a security budget, if you just buy and hold your Bitcoin and usually in custodial wallets, then Bitcoin won't even get the adoption that people want. So we need more stuff to do with our Bitcoin.
And we're at the point.
Their holdings. Bitcoiners have had to use things like Celsius that are centralized garbage.
Yeah, the ETF was like this great enabler of institutional capital, but also simultaneously now like an enemy of these on-chain protocols now.
It's one of the shittiest things to have a Bitcoin ETF because now all the Bitcoin is held with BlackRock. Nobody wants custody to Bitcoin.
Yeah, like the BlackRock BTF, BlackRock Bitcoin is not real Bitcoin. It is just the like representation of your Bitcoin that they hold in custody. So it's no different than holding a fiat currency at all. I think, it's one of the bad things happened to Bitcoin recently, because it makes like people think, okay, I will just like BlackRock Bitcoin, and it's the same Bitcoin, it should be fine. But it's the worst way to onboard people to Bitcoin, because they cannot get out of BlackRock immediately without paying all these fees, and without just like relieving and leaving their Bitcoin to custody of BlackRock.
The purpose of cryptocurrency is self-custody. And it's okay if you want to invest in something without using it, but like it needs to still be able to serve its purpose.
So is it like an education thing, or is it a just the technology hasn't been there for the last couple of years in terms of Bitcoin, and so now it's like with what you guys have been with Stacks, Citria, et cetera, there's we're building the rails to enable this kind of movement from custodied assets to kind of on-chain Bitcoin.
I think it's also social, the community changed a lot over the years, and now everyone was cheering for ETFs, but no one wanted to build stuff. People just didn't want to improve existing things, like didn't want to do another script soft fork, or didn't want rollups, didn't want payment channels other than Lightning, and they simply wanted ETF to be passed in United States, and that's very, very bad for Bitcoin social consensus and governance for the next couple of years as well.
I felt like the culture of Bitcoin over the last, not recent, but like 10 years prior had been pretty Puritan, pretty challenging to work with, but anything that changes Bitcoin was not going to be allowed whatsoever. And with the influx of ordinals and the idea of Bitcoin DeFi, people have actually thought that I should use my Bitcoin and actually deploy it as opposed to just leave it held forever. And as you kind of go further, the more and more of these activities and dApps that are being built, now more and more L2s are coming forward and going, we're going to build the rails and such to make it possible.
I have a question. Can I ask a question, or do you have to ask all the questions?
Please ask a question.
Does Bitcoin need to change to support L2s, or can it just support L2s right now?
I don't actually think it needs to change like fundamentally, like it could stay as is, but if you would want it to have some improvements like OpCat or something like that, ultimately that would be great. But fundamentally it's fine as is.
If it is not extremely like kind of basic talk or document, I don't call Citria Bitcoin L2 because it's not. L2 needs to enable unilateral assets, which only today like solutions like Arc and Lightning enables, but with other soft forks like Cat, we can build rollups with unilateral exits. Citria is still a ZK rollup, but it is not fully L2 if you just accept the like L2 term as enabling non-custodial and unilateral exits.
Do you need OPCat to trustlessly verify snarks, or is there some version of BitVM that is trustless without needing OPCat?
There is a version with permissionless verification, but it's still not trustless. So there's a trustless setup involved in that as well.
And Bitcoin's not really meant to be a data availability layer. I think the block size is 1 megabit, no, 4, sorry. The idea behind using Bitcoin as a data availability layer is the most secure design, but not necessarily the most practical. Like when you're thinking about designing your solution at Citria, how are you coming to the idea of wanting to use Bitcoin as a data availability layer versus something like Celestia?
I think the initial point that I did my talk was also like we came to Bitcoin with like ordinals and started exploring around and decided to build something. And around that time, like BRC20's ordinals were going crazy, but there was no much activity on Stacks, Rootstock, and other existing solutions. And then we think, like, what could be the reason? And I think people don't want an alternative block space. They want to use Bitcoin block space with more stuff. So if you are just creating a sidechain, then you are creating another block space that people pay, and the revenues usually don't go to miners, or they just go to the pools, but not individual miners. And most importantly, they don't get the security, full security of Bitcoin. So using Bitcoin as DA is the only way to get full Bitcoin security if your solution requires DA. If it is Lightning, then you are not using Bitcoin as DA because you don't have DA problem. But if you are building a rollup, then in order to be a rollup, you should use Bitcoin DA. That's the most secure version. It is definitely not the most scalable version. You cannot do 1,000 TPS or like 10,000 TPS using Bitcoin DA because of the true output limits, data limits. But I think we should start with the most secure way and then prioritize scaling afterwards. That's why we have this volition model in the roadmap where we enable off-chain data and on-chain data at the same time, so people have the option to choose. But if you just build a Validium or Optimium on Bitcoin, now you have another security assumption which didn't work out for more than 10 years.
Rana, do you have anything to add about the comment on the block space side of things?
I mean, I would love to see the block space increase, but that's more for my own volition. I don't think any other Bitcoiner would be agreed with that. But from the DA perspective, I do believe for the Stacks L2, we use Bitcoin Core, that layer of DA for our solution. We don't want to go off chain and use another block space per se. So I kind of agree.
I think every rollup should use its base layer for DA. That's the most secure way to do it. But with 4 megabytes, that's just not enough for really high TPS. And so we're working on an initiative to easily integrate Celestia with Bitcoin L2s.
And as far as the technical lift for that, how different is that compared to integrating Celestia with Ethereum rollups?
Well, we have ZK proofs that prove the state of the DA bridge, and we have that for many different kinds of proof system working already. And so integrations to all kinds of weird chains are pretty much just a pretty low lift because we just have to get those proofs verified on whatever the execution layer is.
Got it. I think there's kind of this divergent path happening here with BitVM and OPCat, and as a builder in the space, you're kind of looking at the future of Bitcoin scaling and perhaps even unsure as to when and how this is going to kind of play out from the perspective of building stacks and Citria. How are you guys thinking about the next 6 to 12 months in the Bitcoin space and kind of setting your sights on your project moving forward, but also just kind of the entire ecosystem as a whole developing more?
I think we are not here to just develop a base layer like EVM that people can do some stuff. We are here to onboard developers to Bitcoin with EVM so that they don't have to learn new stuff to build Bitcoin applications. I think, yeah, just building the infra is fine. You should build the best infra, the most secure infra, most scalable infra. But if you don't have the developers to develop on, it's very challenging to get the adoption that you need from users as well. Because people want to use some applications. They don't want to use your chain for nothing. I think for applications, it's very great opportunity because you have all these EVM layers on Ethereum and other L1s, but there's very, very minimal value if you simply, you just count Ethereum as a native asset, but all the native assets of the chains, they simply lock and on investor wallet, on founder wallet, so it's not very liquid asset that you can use, and there is not much market cap for them. But today, Bitcoin has more than 50% of cryptocurrency market cap, and most of Bitcoin is unlocked. There are only a couple in ETF wallets, couple in institutions, couple lost Satoshi wallet, and empty Goxec or whatever, but most of the Bitcoin belongs to individuals. And now we have the ability to build applications, and these individuals now have the chance to use that application so they can simply use their Bitcoin in action. And this is just great opportunity for developers. Now you have more users with more capital, and they never used any of these products before.
On the BitVM side, I think it's pretty well known that Stacks is funding all of BitVM's research right now, and so we fundamentally believe that this would be the solution to bring our L2 from trust minimized to trustless. That's the state that we're trying to get into, and we're getting ready for the Stacks hard fork this fall. This will bring us to having a faster block time to be about 5 to 10 seconds, and so we still 100% use the Bitcoin security budget, so every 1 Bitcoin block, that's the only time that you're basically not confirmed on the L2, but then you roll up back into the L1. And then from there on out, we are working on a kind of generic restaking layer for Bitcoin. So the idea of lock on the L1, deploy on the L2, use the entire security budget of BTC they all one asset, but then all of the other BTC derivatives like BBTC, WBTC, and such, and so that all of that aggregated security budget could be deployed on top.
Are you finding that the community is kind of split in its focus in that sense? Like Eric was just up here extremely excited about OPCat. The Botanics team is pushing that forward, but then build on Bitcoin. You guys, others are much more focused on BitVM. Like how are you thinking about this kind of divergence of focus?
I think there's a couple ways to go about it, but for us, we really wanted to focus on something that brought us to trustless, like in a full decentralized state. OPCat had a lot of functionality that we could use, but it didn't ultimately give us the bridge that we needed. And so we just chose that direction. I'm sure it's a matter of time before we integrate both, but we're starting with one because BitVM is still quite a bit ways out to actually be deployed.
I think there are like a couple of approaches here. Eric and his company mainly like focus on something that we will get in the future. Instead, we just like choose right now we should focus what we have on Bitcoin. And if needed, we can push for other things like CAT or direct ZKP verifier opcode. But right now we have BitVM, and it is the most trust minimized way that you can verify a ZK proof on Bitcoin. That's why we are like heavily working on it on our own fork called Clementine. I think, yeah, our rollup architecture is very agnostic, so the Citria repository in our GitHub is just a sovereign ZK rollup, and the Clementine is kind of external bridge that provides view of the L1 and facilitates all the bridges. So if there's an opcat activated, let's say tomorrow, then it should be easier for us to just convert our Clementine program ZK verifier script from this long BitVM program to a script that verifies Stark using OPCat. So it is very easy for us to integrate OPCat when it's come. It's obvious like Bitcoin governance takes so much time, so we have more time to integrate. But if it already happens like tomorrow, then we can easily convert to that. And yeah, CAT enables Stark verification on the L1 under the block size, so it should be feasible to use to make this rollup trustless. But right now we don't have it, so it is not much of a focus for us right now.
Just a interesting fact. BitVM 2, it has a trusted setup, right? So you have some group of people who create the setup, and as long as one of them is honest, then you can trust it, and you can theoretically make it very big, right? You could maybe get 1,000 people in that. Yeah. That is already the trust assumption of a snark. That's already the trust assumption of a Plonk or Groth16 ZK proof, and a Stark doesn't have that trusted setup, but it's not so bad to have a trusted setup if what you're verifying on chain is a snark. It's the same, and it's not bad. A 1 out of 1,000 honest is pretty good.
Yeah, I definitely agree. Our current proofs are just Stark proofs that produced by RISC-0, but we essentially wrapping them to FF long to verify in BitVM, and it's already a one-of-an assumption. Our challenge is not permissionless. We don't have trusted setup, but we have permissioned verifiers. So it is still the same trust assumption with FF long because it requires only one like universal setup for the circuit. But yeah, if we had OPCat, then we could directly use our already existing Stark proofs to directly verify on Bitcoin without this one-of-an assumption. So instead of trust minimized, it will be fully trustless.
Yeah, and from my understanding, as of now, it's basically the best case is optimistically verifying any ZK proofs until we get to the actual verifier itself. Kind of zooming out a little bit, thinking about Bitcoin going modular, I think we see the supply side coming. I think I've heard there's upwards of 100 L2s or kind of side chains, et cetera. And this is going to keep scaling. But where do you guys anticipate the demand side for these Bitcoin rollups coming from, or these Bitcoin L2s, and who do you guys think are going to be communities and users who will want to participate in these ecosystems? And maybe Reina, you can go first, seeing Stacks is already flourishing.
For us, it's primarily the growing DeFi ecosystem. There really isn't a DeFi ecosystem in Bitcoin, and so we are kind of building all the infrastructure tools in place for liquidity protocols, DEXs and such, all kind of coming in. We've already been early adopters of building for BRC20s and runes and ordinals, but now kind of focusing back on Stacks core. I don't know how many people know Stacks, but we're one of the few L2s that can read and write to Bitcoin native state. And so it's a little bit of a unique value proposition that as you code in Clarity, which is our language that's essentially Rust-based, you always get to read Bitcoin native state and then write back. And very few are able to do that. As we kind of go further, we fundamentally believe that there is going to be hundreds of L2s that are going to go in different directions, but we only want to focus on DeFi, and that's it. We already have about 5 billion locked on chain as is. It's our entire ecosystem because we've been doing this for many years. And we think that there could be hundreds, probably 4 or 5 will stick around to get to the 100, 200 billion mark.
How much of the 5 billion is staked, like active in the ecosystem, and how much is locked in proof of transfer consensus?
Yeah, so for staking, like our version of staking, stacking, whatever you want to call it, that's locked, we have about 3.5 billion locked, and then the other 1.5 billion is locked, or not locked, but deployed directly via contracts.
Okay. I think like from our side, demand is a bit tricky. If you are building just like a roll-up, you don't have to have extreme demand to cover your expenses because you don't have much expense. If there's transactions, then they already paid the fee, so you pay the DA fee, you pay the proving fee, but you don't need anything extra. But the staking is a bit tricky, like stuff like Babylon. There are a lot of Bitcoin and people want to get yield on, and they want to get like 4 or 5% maybe yield with their Bitcoin. But if there is no usage on the other side, who will pay those fees? Like there are many proof of stake chains that is now just inflating their token to pay money to like stakers. And if they want to use Babylon, they should also pay Babylon so that Babylon can pay to his stakers. But it's not the reality. There's not much demand on chain right now. So I think instead of focusing Bitcoin staking stuff, first we need to ensure that there's a health ecosystem that we built and proved, and then we can focus on like this kind of staking related stuff, and people can build applications so there will be enough demand to pay these stakers and kind of securing the crypto economic security itself.
Okay, cool. I kind of want to go back into the technical side of things, if that's all right. And I had a last question about the optimistically proven or verified ZK proofs, and then now with the rise of ZK VMs like RISC-0 and Succinct and others kind of coming onto the market, I'm curious how you think This is going to play a part in the Bitcoin L2 space and kind of scaling Bitcoin in a modular way using these ZK VMs.
I think ZK VMs are like making developments maybe 2 times better than it was before. You had this client, like let's say EVM, and you write the client from scratch, and then you write all of the circuits from scratch as well. So that, and each time you update one, you have to update both. So you're just maintaining 2 different software. But with ZK VMs, you simply have a Rust or C++ code base, and you are only maintaining it. And once it changed, the ZK circuit already changed automatically through this RISC-0 or SP1 or other alternatives coming to market. And specifically for Bitcoin, I think there can be some also product market fit, because ZKP has actually like started talking in Bitcoin during Satoshi's time, but it never got implemented. And the first on-chain ZKP was zero-knowledge contingent payments by Greg Maxwell, I think in 2016. And they simply handwrite all the circuits. But right now, there are not many people on Bitcoin, and developers, they don't know how to code circuits. They usually write C++ or Rust. So these ZK VMs has another special market fit in Bitcoin as well, because it's not so popular. The zero-knowledge is not quite popular compared to the Ethereum.
So I know Sovereign's doing a lot of great work here. I think Jem unfortunately wasn't able to make it. But from what I gather, I think that the ZK VM side of things is going to help immensely on the interoperability aspect of scaling Bitcoin. I think we've talked, I feel like, endlessly at this conference about kind of this fragmentation problem and how ZK is the end game. But I think it's all the more relevant here now in the Bitcoin space, and being able to bring these ZK proofs and generate them fast and cheaply is going to continue to help to scale the space. But ultimately, until we get BitVM, it's still going to be kind of talking about what is happening here. Conrad, I'd like to ask you kind of about Blobstream and how you see Celestia's Blobstream DA solution being implemented into some of these Bitcoin scaling solutions and kind of where you guys are at with that.
The way it's probably going to work is there's probably going to be a Blobstream snark that runs alongside the rollups execution proof, and then when they go to verify with BitVM or something, it'll verify an aggregation circuit that aggregates those two. And to prevent them from needing to all waste data by, or waste fees by like writing the same updates that are Blobstream related onto Bitcoin, we'll probably want to figure out some way that we can just inscribe proofs on Bitcoin once and then let all the Bitcoin L2s create their proofs based on what Blobstream data gets inscribed in the Bitcoin block. And so the idea there is that it's just something that kind of like will provide an SDK for the various Bitcoin VMs and the rollups who consume it.
On the inscription side, are the limitations there mostly the cost of the inscribing, or is it kind of the time to settle those blocks?
I have no idea what it costs to inscribe something in Bitcoin, but we don't have to do it once per Celestia block. You only need to do it as fast as the rollups demand those updates. On Ethereum, I believe this is quite slow. I think we do like at least dozens, if not hundreds, of Celestia blocks before we update Blobstream. Although the rollups can force update as fast as they need, but then they have to pay for it.
So looking at the OPCAT landscape, Eric mentioned this and said that it's been talked about quite a bit, and it's this idea of Bitcoin's ossification and immutability lies in its kind of in its simpleness, in its limited execution. OPCAT brings in a next level of programmability, and there's speculation of where this can take effect on the base layer. I'm curious if you guys are actually speculating that there's going to be centralization of either building blocks or mining pools as a result of OPCAT and any other ramifications that you guys are kind of going through in your minds.
The proposed code for OPCAT is already like preventing all of the DOS attacks that existed before for OPCAT, and you already have this 4 megabyte block limit, so it is not changing much in terms of the effect on builders or effect on nodes. It's the same blockchain with one additional script opcode enabled. So I don't expect it should be add any additional burden to anyone. And I also think building with OPCAT is hard enough. So you have to just write all this 1,000 lines of script to just verify a Merkle proof. So I believe there will be kind of shared Stark verifier built with OPCAT, and people will simply build ZK circuits instead of writing Bitcoin scripts. So instead of just doing all the Merkle tree verification with CAT, then light client verification with CAT, you can simply write them in Rust and use the existed Stark verifier already embedded in Bitcoin as a UTXO. So I think CAT is not very practical to develop. But if you just develop a Stark verifier, then you should be fine. So you can use any other code to just create the proof and verify in Bitcoin.
I think we're already at finer centralization as is after the last halving. I don't think there's more than 8 major players mining, and then you have tinier pools. I used to run a mining pool in 2012, and at that time and point, anyone could be a miner and just run it straight from your GPU, but now it's not even possible. Miners are very excited, candidly, about OPCAT because of the functionalities coming to be a little bit more fully expressive on Bitcoin script to feel closer to smart contracts, what you have in other ecosystems and such. When you have all those transactions coming in, more fees are coming because miners are validating these blocks, and so for them, it's thankful. I don't know. I'm trying to think. I think from ordinals from December 2022 till now, ordinals have generated at least a couple $100 million in mining revenue that miners didn't see before. And so as we continue going through halving cycles, and again, in another 4 years, miners will be depending on these transactions coming through, especially through OPCAT. in order to sustain themselves. Otherwise, the Bitcoin blockchain kind of fails.
Yeah, I mean, as we see more transactions come in, hash rate keep increasing. I think that the argument might actually be that the competition for mining is going to just continue to increase. New players could even come onto the market, which I think is going to be ultimately extremely positive for the Bitcoin ecosystem as a whole in terms of the generation of fees. But yeah, now miners are making more than, I mean, I think it's like in 2017, there was one spike, I remember, where Bitcoin fees were extremely expensive just to send, but now it's like that, you know, throughout each day.
That and it actually made people using the Bitcoin blockchain. If you think about it, it's took until 2024 to hit 1 billion transactions in Bitcoin, whereas Solana hit 1 billion transactions in like 2022, Ethereum hit them in 2021, but Bitcoin, oldest blockchain, not until now.
Yeah, it's interesting. I mean, there's, I was talking about this kind of divergent path earlier and kind of how the community is at a bit of a fork in the road, but seemingly if OPCAT goes through, the expansion of this Bitcoin ecosystem, this Bitcoin going modular will just be, I think, cemented for sure. And I think that the community is still, you know, as I've said, split, but I'm thinking that they're getting a bit more open to it. And recently I saw a proposal from, I think his name is Patrick, I'm unfortunately forgetting his last name, but he proposed basically this idea of a sidecar next to the Bitcoin blockchain that basically after a certain amount of time, it basically copies the Bitcoin blocks, and they've thought to get the Bitcoin core to kind of support that, and then eventually run OPCAT on that sidecar to kind of like experiment with it, and then if core can support it, then the miners would basically be willing to support it as well at some point and kind of put those two together. But I don't know if you guys have seen that or if you guys have any other thoughts on kind of like the proper implementation of OPCAT.
I think it was Paul Source of like author of the drive chain proposal, and that idea looks like you don't have to change Bitcoin Core. So instead, you just run a sidecar to like signal and activate a soft fork, including miners and nodes. I don't know too much details. I haven't taken a look to the code as well. But if there's like not much hash rate required by it, it might be smart. But if there is already like requiring majority of hash rate, it will be hard to use it. I think his main target is enable drive chains, not CAT at all. So it should be like just focused on drive chains for now. For OPCAT, I think we just need like to enable the activation client, just code some activation client and start signaling OPCAT. But today, yeah, individuals are like pushing, just like Taproot Wizards and like a couple of companies, but there should be, I think, some bigger consensus in also like in social places, not only just developer forums, to push OPCAT one step further. But right now, there's no such consensus in Bitcoin yet.
Yeah, I think that the soft fork is the hurdle. And you mentioned that he's from Drive Chains, Paul? Yeah, I think that the idea of doing the soft fork is kind of the community's hurdle, right? And but the community's changing. And Connor, I think you've been in this space for quite a while. More broadly, how have you seen the Bitcoin community kind of change now and adapt to this kind of modular mindset, if you will, of bringing programmability in?
Well, at the beginning of this panel, she said she is in favor of raising the block size as a Bitcoin maximalist.
I wouldn't call myself a pure maxi,
Oh,
but
okay.
realistically, I would like to see it raised.
Oh, okay, cool. Well, that would have been unthinkable a few years back. So I think that it has changed massively. Also, the talk of new opcodes going in is pretty crazy. And it seems like it actually is going to pass, which is also pretty unthinkable, such significant changes. Bitcoin seems wildly different than it used to be.
Like for perspective, our last fork was like Taproot and SegWit, and that was so many years ago, and now we're getting to L2 movement, OpCat, BitVM, all of these soft forks to come, and no one's really pushing back saying don't do it.
Yeah, and that was the Bitcoin Cash 8 megabits blocks or
Yeah, like the block wars from like the early days.
the first airdrop ever, the original airdrop. What's funny though is that I think this is completely off of Bitcoin, but in Ethereum, the base rollups idea was kind of pushed by Ethereum Foundation and Justin Drake and others, and I think it's one of the first things that is kind of being pushed back on quite heavily by the broader community, or at least being topically discussed. Whereas in Bitcoin, it feels like this idea is kind of stemming from some core community members and people that are working in this space, and it's being broadly accepted. So I don't know, just thought that was an interesting kind of paradox happening now.
I think it's like not so accepted on Bitcoin, maybe even forced more than like the Ethereum side, because people simply don't want too much MEV on Bitcoin L1 with miners. It already exists with ordinals, runes, PRC20s, whatever, but they don't want even more MEV on L1. And with just like vanilla-based rollups, they just activate heavily MEV on the L1. So that was the one thing that people told me, like, oh, you are building rollup, then you are just creating MEV on L1. But rollups like us, starting with single sequencer, they don't leak any single MEV to the L1 because all the consensus, the transaction order happened on the L2. And once we implement this sequencer mechanism, the decentralized sequencer mechanism, it will also keep on the L2, not leak on the L1. But if you just build a base, just vanilla-based rollup on Bitcoin, it will enable MEV a lot, and you will receive a lot of pushbacks.
Well, I think this has been a great conversation. I'm thoroughly looking forward to seeing Bitcoin's community and kind of this, what some could have called like a mind virus in terms of the way that people had thought about Bitcoin in the past in terms of the ossification, now kind of expanding it and going more modular and just bringing more programmability. So thank you guys for this awesome panel, and give it up for a round of applause, please.
All right, thank you guys. We need to switch out of panel mode for a second, so just 10 seconds. And then next we have Andrea from Magic Block. So thank you. That's all I do. Don't worry, I've got 12 more times to practice.
Hey everyone, I'm Andrea. I'm the CEO and co-founder of Magiblock, and today I'm going to be talking about how we're using ephemeral rollups to build real-time games entirely deployed on Solana. So fully on-chain games on Solana. So I'd love to give you a bit of the backstory of what got us excited about fully on-chain games and how we got started. When it comes to building games entirely on-chain, I think it boils down to fundamentally these three key properties. If you have state and logic on-chain, your game is a permissionless platform, which means that anybody can build smart contracts that extend the functionality of that game, introduce new behavior for your players, and at the same time, the same goes for new business model. Developers are able to potentially monetize content in new way, either with royalties or with direct-to-consumer sales, but they're able to do that without asking for your consent as a studio. And this game in the middle is Pirate Nation, built by Proof of Play. They are the same team that used to work on Farmville. If you remember, oops, can I go back? Okay, sorry. This team used to build Farmville, and if you remember what happened with Farmville, they were basically building on top of Facebook, and Facebook at some point decided to unilaterally change their relationship with Farmville, and basically rug them. And so the second property that is interesting about fully on-chain games is that they basically represent this unstoppable world, unstoppable digital realities that no matter what happens will persist forever and lowers the trust barrier for developers to build on top of your own platform. And the last property is verifiable compute, which is obviously a great fit for any sort of poker or casino games, but not necessarily only those type of games. Any PvP with some value at stake, think esport, for example, is a great fit. And you also have the ability to create prediction market that doesn't require external oracles to resolve. So if you can run the video right now, we basically start building a fully on-chain game on Solana. We choose Solana because we wanted to preserve the composability of the state. And this was essentially a PvP arena game where you could put down some soul, invite your friends, or compete with strangers, and roam around an arena where you have to kill your opponent. You see there's a spinner in the top left corner, and that is a Solana transaction. So we were basically running this game entirely on chain, and you can see that now I'm trying to kill the other player by blowing myself up and to basically kill the opponent. And you notice that there is a significant amount of lag between these games, these two players, which make that experience basically unplayable. There's no chance that this game could become a mainstream consumer application. And so we were considering whether we should build our own sovereign chain or rollup, but at the same time, we kind of were stuck in this trade-off between composability and performance. We didn't really want to build on rollup in order to preserve the property of composability. Rollups tend to fragment the ecosystem to the point where even if you're sending a simple native USDC payment, it can become this overly convoluted and complicated process, but at the same time, Solana was clearly not enough for us. We only had this general purpose runtime, and we couldn't customize our own block time. We couldn't have sovereign block space to reduce the fees, for example, and we didn't have enough TPS for the moment where we needed to onboard new players. And therefore, we went back to the design board, and we created what we call ephemeral rollups. We published this paper, and here's how it looks. Could you please run the second video? So this is a fully on-chain game that is entirely deployed on Solana and is accelerated with ephemeral rollups. You see the transaction being processed super fast, and at the same time, we managed to reduce all the lag within these two clients playing together side by side. And not only the game is hyper-performant, but it's also composable with Solana L1, because by minting this gem, we're sending a transaction that mint the token on Solana mainnet. This is based on the player position in the ephemeral rollup. So we are looking at the coordinate in the ephemeral rollup, and we're minting that token. And this is fundamentally what MagicBlock is about. MagicBlock is a decentralized high-performance network that extends Solana capability and accelerates state transition without breaking the composability of the underlying base layer. We give developers the ability to run real-time transaction. The latency, the end-to-end latency is less than 50 milliseconds, but at the same time, we're composable with the underlying base layer because the smart contracts are deployed directly on Solana and not on a different ecosystem. At the same time, this system is scalable. We can give them more TPS on demand whenever they might need it, and it's modular, which means that we can give them sovereign block space and the ability to customize the runtime to introduce loops or to have custom fee policies. So to understand how this system works, just keep these two very simple concepts in mind about how the Solana virtual machine works. Solana has this notion of accounts where state and logic is natively separated. You have executable and non-executable account, and so you have the logic that is natively detached from the state. And at the same time, you have PDAs, program-derived addresses. Basically, every account has a program owner, and program-derived addresses are these deterministically derived addresses that a program can leverage in order to sign without a private key. So with these two ideas, we can go through an ephemeral rollup lifecycle. Developers deploy smart contract directly on Solana, and they can delegate account, the PDA, into a delegation program, effectively moving the ownership of that PDAs to the delegation program. And an SVM operator, so a fast Solana validator that we wrote from scratch to optimize for performance, spin up an ephemeral rollup session. The overhead on the validator is between 4 and 10 milliseconds because it's not bound by consensus, we don't have voting, we don't have gossip, and that's why the state can change so quickly. This is the state of the position of the player that you saw in the video before. And whenever we need that information back on chain, we can post a commitment. The active node operator will post a commitment on the base layer, and a network of challenger verify the integrity of that computation. So this is fundamentally a fraud-proof system where you have these parties that act as challenger and can sign off that state commitment before it gets finalized on Solana. And when that happens, we have the position state gets updated, the authority of the PDAs get transferred back to the original program, and we can have conditional operations such as a token mint, as you just saw in the video. The interesting idea behind this design is that we can shard the state of games or application into multiple execution environments and run them in parallel. Because on Solana, you always declare upfront the state that you're accessing in the transaction, you can decide to maintain on the base layer an NFT mint or USDC payment and only move the state position of character, for example, in one or multiple ephemeral rollups. Or you can do vice versa. It's completely up to you as a developer to decide which account you want to run in the ephemeral rollup and which account you want to keep on Solana. And at the same time, with an RPC router, we can abstract all of this complexity away from a user perspective. So with a single RPC, they're interacting with all of these different environments that are executing state transition function for your game or application. So when it comes to the trust assumption, this is my mental framework on how you can basically prove that some off-chain computation is correct. You have validity proof that rely on cryptographic security, and you have fraud proof that basically rely on the assumption that someone, some honest party, will raise a challenge if they detect some fraud in the session, where that probability basically depends on the length of the challenge period. We assume that the longer the challenge period, the easier it is for some honest party to raise the challenge. And it depends also on some sort of bond. So what is the economic incentive for some party to raise that challenge? And at the same time, you need a sufficiently high enough number of parties to act as challenger, because if nobody is watching that session, nobody will raise the challenge. And the more active participants, the more stakeholders are acting as challenger, the higher the probability that at least an honest party will raise that challenge. And so the way our system works is that the ephemeral rollup are posting a state diff commitment, and then there's a challenge period, right, which the developer can specify. They can decide to customize this challenge period, but well, obviously, if that challenge is raised, we have to enter into a dispute game, and that challenge period is extended, and then we have to resolve either with bisection game or with a ZK proof what the state was. But if the challenge is not raised, then by default, the challenge window is extended unless we have this pre-specified number of nodes that sign off that state commitment. And this is basically to ensure that there is at least some party that watch that ephemeral rollup session. And this number is also customizable by the developers. So they can basically trade off some time for money. They can pay these parties to sign off that state commitment, and they can be more aggressive on the security window because they want to settle back the state faster. And there's also optimization that we can do in terms of not having full node computing one by one and replaying all of the transaction, but having light clients or sampling nodes that basically just sample a portion of the ephemeral rollup. So this is are all the scenarios, and when the challenge period is not elapsed, obviously we want to wait for that period to come to conclusion. But even if the window ends and we don't have enough signature, we don't have enough parties acting as challenger, there is the probability that there is potential fraud, right? Because there's not enough challenger, basically. And this could happen especially with very, very aggressive fraud-proof window. At the same time, if the signature threshold is reached, but we are not yet done with the challenge period, we want to wait for the challenge period to terminate. So only in the case where both are true, where the challenge period is elapsed and the signature threshold has been reached, we can finalize the state back on the base layer. So to sum up, why ephemeral rollups is an interesting solution. Ephemeral rollups operate at the account level. So they only accelerate particular state that you want to delegate into these sessions, and any account can natively be delegated into a blazing fast Solana validator that operates at faster speed because it's not bound by consensus. Ultimately, there will be multiple parties running these nodes, and these nodes can be spun up just in time and co-located close to the user. So everything is deployed on the edge to reduce further the network latency. And this gives them the ability to basically access sovereign block space because they can customize the runtime the way they want. They can specify their own gas policies. They can introduce randomness at the node level. This is something that we have been asked, or they can decide to extract MEV if they want. And this only takes an extraction call on Solana. So they don't need to redeploy into a different system. They can just call an existing program, the delegation program, and from there, they can operate in the ephemeral rollup session. So the validator will automatically clone all the programs that are needed to execute that state transition function into the ephemeral rollups. Obviously, we are focused on gaming. We have a whole variety of tooling that we have developed for facilitating the creation of fully on-chain games. We have Bolt, which is an entity component system to basically allow the smart contract to be easily extendable. We have session keys, which allow users to sign transaction automatically and not having to approve every single operation or interaction that they're making in the game. We are a Unity verified solution, so we have a huge amount of SDKs for not only Unity, but Unreal, Godot, Phaser that game developers can use to build their games. But this system is fundamentally a system that can be used for many other use cases. All of the use cases that you see here are either use cases that we are actively exploring and projects that we're working with, or we have projects that have reached out to us to explore ephemeral rollups as a way to scale, accelerate, and customize their own runtime. So if you're interested in understanding more about ephemeral rollups or to get in touch with us, feel free to reach out on my Telegram or follow us on X. Our handle is MagicBlock. Thank you.
All right, we have time for some questions. Does anybody have any questions?
So what do you guys do for the data availability of the ephemeral shards? Since there's like a fraud-proof mechanism to like revert on-chain, what's the plan?
Yeah, at the moment, we don't have a data availability solution, but we're actively exploring Celestia and different data availability layer because users have asked us, what if I want to show my users that the history of transaction happening in the ephemeral rollups? So this is something that is actually very relevant to us. And an option is also to use Solana native data availability. That's another option that is on the table at the moment. We are still actively exploring solution, but you're right. Potentially, we want to be able to show users the transaction happening in this ephemeral rollup session, especially given ephemeral rollups could be run for longer than we anticipate. There's nothing preventing developers to run these ephemeral rollups in a persistent manner and settling back periodically every 5 minutes or every day.
Yeah, but I guess not just for the users, but for the security of the watch or whatever, sentinels or whatever. Or like, why not ZK prove everything? Maybe then, it's a Validium, it's secure without data availability.
Yeah, it's primarily a speed consideration. Is how fast developer want to roll back the state and make that state available on Solana. So we want to give them the ability to basically play around with the fraud-proof window and decide what is the level of security that they need, provided that you could use this system to run a game, or you could use this system to run central limit order book with a matching engine off-chain and the liquidity on-chain. So we want developer to play around with the different security go along the security spectrum, basically. And that's why we think the fraud-proof challenge window with this extra layer of challenger is interesting. You could obviously prove everything by running the VM on RISC-0 or SP1, but at the moment, for this particular use case that I show, is the timing is still a constraint.
Cool, thank you.
All right, round of applause for Andrea. Thank you very much. And next we have Terry from Eclipse. Over here, good.
All right, thank you everyone for staying here 4 p.m. on a Saturday. And thanks for the Celestia guys for organizing. All right, I'm Terry, I work at Eclipse, head of strategy. Talk title is called You Only Need One Rollup, but I'll be talking more about why infra take rate is actually going to zero over time. The trend in the past 3 days at Modular Summit, and I think infrastructure in general, has been that apps want to own the value that they create, right? Imagine the scenario where Pump.Fund could own all the MEV and execution fees that they generated, right? They made 59 million over the past couple of months, but presumably, 1 million a day in Jito bundle tips would have resulted in hundreds of millions of excess revenue. So from a perspective of an application that wants to internalize the MEV and the execution fees that I generate, I have a couple of options that are available to me today, right? I can become a Cosmos app chain and integrate Skip, which allows me to internalize the fees as an application, plus execution fees, plus MEV, times, say, like the foundation stake divided by total stake minus some validator epsilon. In exchange, I give up synchronous composability. I have all these third-party infrastructure costs. These are things like RPCs, indexers, liquidity, third-party bridges, and these are non-negligible costs. If any of you guys have built an L2 or an L1, these are quite significant. Plus, some validator setup costs. If you're using replicated security, never mind. You can become an app-specific rollup through something like a RAS project, Conduit, Caldera, in which case you get the fees as an application. Now, I won't stop talking about that because that's kind of generalized across all these options. You get MEV, you get fees, but you have to pay taxes to your DA and settlement layer. You lose synchronous composability. You also have to pay third-party infrastructure costs. Now, there's these new kind of applications. I think Sorella, Vertex, CowSwap, they're kind of titular here, that are self-sequence apps, right? They have sovereign sequencing, and in the process, they take and internalize MEV, then they redistribute this in a way that is favorable to their users. So in the case of Sorella, they distribute it to passive LPs. And here, you get fees. You don't necessarily get execution fees, TBD. You get MEV internalized, but you also have to pay settlement execution. So for example, in the example in CowSwap, right, you have to, when you settle the batch auction, make sure that the batch auction is optimal on chain, plus pay for execution in the L1. You also lose synchronous composability. There are no third-party infrastructure costs, so take that out. Now, the final option that's quite recent is you can have an app chain, and you can opt into a shared sequencer. Here, everything you get as an app-specific rollup, plus you pay a shared sequencer fee. You always have to pay a shared sequencer fee, right? Because they also maintain their own infrastructure, they also maintain their own consensus set, and some type of shared sequencer surplus, question mark. We kind of don't know what that looks like yet in designs, right? That might be a pro rata distribution of cross-domain MEV surplus, but we don't know that yet. In exchange, you pay for uncertainty in DevX, third-party infrastructure costs, and generally design uncertainty and uncertainty as to when these will ship. But you'll realize that all four of these options, compare that to what you get as an app on a general purpose execution environment, right? You get basically nothing. So why would people move towards app chains? This is the reason why. But the problem with a lot of infrastructure today has been that people have taken this chart as a given. They're like, okay, everyone will move to an app chain because this is the profit structure of applications today. But we want to ask, what if there's a way that we can kind of build for this part and change this equation instead of taking this as a given and making sure we build a strong shared sequencer. So let's further examine the shared sequencer and the profit kind of motivation behind building one. Say I'm an application. So I'm an application, and I'm thinking about, do I want to go towards an app chain that's standalone, or do I want to go towards an app chain that operates into a shared sequencer, right? If I go towards just an app chain, right, then I internalize all these fees right here. But if I go into an app chain with a shared sequencer, then I get kind of these benefits at this cost. So what is the cost of synchronous composability while opting into a shared sequencer? Well, we have DevX uncertainty, we have uncertainty in terms of revenue share design, and we have third-party integration costs, which are also present if you're a normal app chain. So ultimately, the equation that boils down to is the shared sequencer surplus, question mark, larger than the shared sequencer fee plus DevX degradation. And to this day, we don't quite yet know. But okay, now from the perspective of an app chain or a general purpose L2, let's examine the matrix of, do I opt into someone else's shared sequencer or do I launch my own shared sequencer, right? So if I opt into someone else's shared sequencer, I have to pay the shared sequencer fee, but TBD, I might get some pro rata portion of the cross-domain surplus, times rollup divided by n, minus the shared sequencer fee. Now that might be positive, that might be negative, that might be zero. We don't know just yet. Now, if I launch my own shared sequencer network, say I'm Arbitrum or Optimism Orbit, and I have an established ecosystem, I have a lot of users, I have a lot of liquidity, a lot of dApps, then I can charge the margin on the cross-domain surplus, which TBD exists or not, which is always strictly greater than what I get if I opt into someone else's shared sequencer. Which means between domains that we want to interoperate on, right? I won't use Arbitrum, I use Optimism, so I want to interoperate between Optimism and Arbitrum, but they will never have the incentive or the coordination to be able to interoperate with each other by opting into the same shared sequencer network. So interop is a social problem, right? Like Justin Drake said this on a podcast with Toli. Shared sequencing is not a technical issue. It's a social issue, and that is why it's easy. But I want to say, that is why it's incredibly difficult. It's a massive coordination game. Before, we had these groups of sovereign domains, right? And they were not interoperable. And they housed their own applications that were interesting, and we loved transacting on them. Now, each of these are going to have their subdomains, which are interoperable with each other, but at the end of the day, they won't be cross-interoperable through a shared sequencer mechanism. And so, yeah, it's a massive coordination problem. But it is important to note that all of these aforementioned options, even though, with these coordination games, with these incentive issues, all still significantly better than staying on a general purpose L1 and L2. So then, how can we justify the existence of any general purpose L1 and L2? Why would not every single app move towards sovereign sequencing and app chains, then want to interoperate between a shared sequencing layer? Well, how can we change the equation, right? So how can we make it so that the value of being on a general purpose L2 is larger than the value of being on an app chain? For one, you come down and you kind of like list out the profit and the cost of each. You realize, okay, fees on the app are common to both, let's cancel them out. Then you realize down here that the right side of the equation, which is being on an app chain, you always get to internalize your own MEV plus execution fees. And because those are positive and the other side, the left side only has a negative, which is congestion, you need to, by definition, in order to change the equation, move that also to the left side of the equation, which means as an L2 or general purpose L1, you need to redistribute your execution fees and your MEV to the dApps so they have a reason to stay on your chain. Now I put epsilon over there because there will always be some sort of value loss because of composability in a general purpose environment. Then on top of that, you now cancel out MEV and fees. You have congestion minus epsilon, negative congestion minus epsilon on one side. And on the other side, this is kind of the value you get from being in a shared sequencer network. You have to solve congestion. And then finally, you can make this significantly positive if you can actually help dApps make more money. So yeah, I call this doing the easy thing hard because we can take it as a given that the profit matrix on the fourth slide is correct and build towards synchronous composability through shared sequencer networks and significantly complicated additional tech. Or we can change the equation and say, why don't we change the equation on a general purpose L2 and change it so that applications want to stay on my general purpose layer and it is incentive compatible and actually profit maximizing to do so. So how do we get there? Number one, as we went through the equation, solve for congestion. So dApps never lose revenue from fee spikes. never lose users to noisy neighbors. That's number one. Number two is decrease the customer acquisition cost for dApps and help them increase their revenue. So that looks like increasing attention and distribution funnels. A lot of people have talked about these, having a community, et cetera. Number three, help them tap into existing infrastructure, liquidity providers, et cetera. And finally, redistribute your profits back to dApps that originated it. They are first-party citizens on your chain, on your execution layer. They deserve the value that they create. Give it all back. The question is, can we get a synchronous execution layer that retains the dApp that build on it? So what's the end game? What does this result in? Today, the protocol layer is capturing most of the value, right? PBS means that execution proposers, specifically validators, are capturing a lot of the value created by the dApps that live on execution layers. And this is why people have been talking about the fat protocol thesis. People have predominantly invested in tokens of L1, L2 tokens. We think competition in the infrastructure space has become so intense, app chains have accelerated this demand that in the future, general purpose execution environments will have to compete on giving back all the value they create to applications. And they will compete on becoming a thick protocol layer that actually has value of being synchronously composable and large. So what can blockchains do today? They have to compete on scale. Get fast, fast. Give back as much value to dApps as possible and focus explicitly on how you lower customer acquisition value for dApps. And so this is kind of like a allusion to Evan's talk, which said, your margin is my opportunity. So what is the infrastructure end state take rate? It's such that the portion of the margin that you charge on MEV plus execution fees, plus some abstract value assignment to universal synchronous composability, plus liquidity, plus users, minus congestion, which should ideally be 0, is larger or equal to than what you get out of being a sovereign app chain. So MEV plus fees minus DA minus settlement plus some abstract value of sovereignty. So the more value you can raise here, as you mentioned, as you can see, the more value you can get out of universal synchronous composability, the more you can lower customer acquisition costs for dApps, the more you can actually capture value as a base layer. So there are two directions that I think a lot of execution environments, general purpose execution environments can go today. You can become one big rollup, give back all your MEV to dApps, which is itself a hard problem. We don't yet know how to do MEV attribution with composability. We don't know how to do it. There's like complicated fast bundle auction design, which is very interrelated to MEV attribution and composability. There's fast VSR, verifiable sequencing rules, which we don't yet know how to do either, and a 400 millisecond latency. Or you can go towards a shared sequencing route, which also we still don't know, I think, how to solve exactly either, right? We have DevX problems, coordination games, as we explained in slide 3 and 4, cross-domain surplus attribution and redistribution, which none of the teams have correctly figured out either. Thank you.
All right, we have time for questions. So anybody have any questions for Terry?
Thanks for the talk, Terry. Do you have any ideas of how you would give back MEV to applications when there's likely going to be a group of proposers on that L2 as well that probably has most of the power?
Yeah, so it's going to have to be centralized. Like, that is my current understanding. Like, I don't think it is possible to actually do fully composable, fully attributable MEV redistribution today in a way that's fair, right? Because searchers will spin up their own programs, they'll spin up their own accounts, they'll try to interoperate between those, and then that will, kind of leak a portion of MEV. That's why I also put the epsilon there. So in the interim solution, I think verifiable sequencing rules, like that might be something that's promising. But in the interim solution is that, it has to be an opinionated centralized distribution from the sequencer. And then dApps that want to build on your general purpose execution environment are kind of signing up for that distribution mechanism. It is still strictly better than, any other alternative.
Good talk, sir. So at the end, you laid out this end game, but it looked like it was like 2 bad paths, right? So I'm just curious, is there one path that you like more than the other, or is there like a third utopia that we're missing from that picture?
Yeah, I think the kind of takeaway from the last slide is that both have incredibly difficult problems that we need to solve that we kind of don't really like have a clear, this is the perfect IC solution just yet. But I'm of the opinion, of course, that like you should have one big rollup. It is a simpler solution. It is easier to reason about. And maybe like a trend in infrastructure in the past like couple months has been, instead of doing all these crazy, okay, create this infrastructure, this creates this problem, then we create another infrastructure to solve that problem. Why don't we just go back to the base layer and solve the base problem? And that's kind of how we're thinking about it.
What is some of the costs of acquisition that you're seeing right now for blockchains, and kind of how are you also thinking about lowering those through this mechanism and kind of others?
Yeah, cost of acquisition has mostly been around like teams spending money on business development / community building that results in people believing that there is value in aligning and being on and deploying on your blockchain. I think Bera and Monad are good examples here. And then on top of that, like I don't think anyone has specifically quantified, okay, here's how much we spent to get this dApp or to get a single user. But it's something that I think will evolve over time. I think a lot of more, groundwork in terms of, being in different developer meetups around the world, different marketing channels, not only using crypto Twitter as a medium, but branching outside, seeing what's on Reddit, seeing what's on, Stack Exchange, different developer forums. I think that might be more valuable in the future as well.
Yeah, and if you're still wondering if we're early, the fact that no one's done a cost of acquisition analysis yet should tell you that. Any final question? One more? All right, Terry, thank you so much.
Thank you.
And we have another panel, so give us a second to get into panel mode, and then we'll bring up Mert to introduce our guests. Thank you, man. All right, can all of our panelists join us up here? And Mert? Oh, awesome, sorry, didn't see that. Oh yeah, feel free to take a seat under your name. Good to see you.
All right. Do I just go?
Yeah, when you're ready.
Okay. Let's see. Is it like a time thing?
Yeah, you just watch the timer back there.
Oh, shit. Okay, we'll start at 4 because it's 3:57.
Okay.
38 minutes. Huh? 38 minutes. Damn. That's quite large.
Tarun or Nick? That's Nick. I thought you were Tarun. Channeling Tarun.
Oh shit, Nick. Hey, how you doing? That's a great outfit.
Thank you.
Of course. Is that a wig? That's a wig, right?
It's a wig, yeah.
Okay.
It's a modular mullet.
It's extensions.
Yeah. Yes. Modular Mert.
I got another wig for you if you want to remember what it's like.
That actually, okay, yeah. For the roast.
Yeah.
Okay. Sweet. Do you have like the dunce cap that you said you guys were gonna have?
I don't know. We have to find something. I might just wear this.
Okay.
Best I got.
Okay. All right, let's get started. This is very loud. Hello, everyone. Thanks for coming. We're going to be talking about is Solana going modular today? I found out that I was doing this yesterday, so I'm kind of just going to make up the questions. Feel free to interrupt me if you have any questions from the audience, or if you want to dive deeper into a hot take or whatever, just let me know. But to start it off, let's just do some brief intros. Let's start with Andrea and then kind of work our way back here.
Hey everyone, I'm Andrea. I'm the CEO and co-founder of MagicBlock. We are building a high-performance engine for fully on-chain games and fully on-chain applications on Solana.
Hey, what's up, guys? BJ here. I'm the CEO of Eclipse Labs. Eclipse is building the first SVM L2 that settles to Ethereum and uses Celestia for DA.
Guys, Anil, founder, CEO, Rome Protocol. We are bringing Solana as modular services for Ethereum L2s.
Hey everybody, Sven, co-founder of Light Protocol, and we're building, together with Mert and his company, ZK Compression. And ZK Compression scales data storage on Solana, makes it incredibly cheap for applications to build on the Solana L1. And by doing that, also introduces ZK accounts and verifiability on Solana.
Cool. My name is Mert. I run mobile networks on Solana and sometimes payment networks as well, and occasionally post on Twitter. Okay, let's actually first, before discussing if Solana is going modular, let's define what everybody here thinks what the word modular actually means. And then this time we'll start with Sven. Just, in your own words, what does modular mean to you? And does it line up with maybe what everybody else thinks?
When I hear modular, I think a lot of very highly optimized parts of one system. And I think, in the sense of blockchains, that would be, what you'd refer to as like maybe execution, settlement, DA. While I think that matches overall with what others in this room might think is modularity, I do actually think that it's not diametrically opposed to an integrated blockchain. So I think it's sort of like orthogonal. You can be integrated and highly modular at the same time.
Yeah, so for me, it is more like a Lego pieces. That's modularity. You can put those pieces together to create different things. It brings the explorer out of us. When you are modular, it brings the innovation, it brings the searching kind of mentality that we all have as a kid. So it creates a lot of surface area for us so that we can all be explorer and create new things that usually are not visible when we are thinking one directional. So that's what modularity is for me.
Yeah, I would agree with a lot of what these guys have said. I think I would add that, to me, it's unbundling all the components of the stack, right, from execution down to DA and fraud proofs, and really allowing teams to specialize and build kind of highly capable versions of each part of that stack. And I think as a result, you end up with a much more competitive environment where there's a lot more creative destruction. And I think the speed that teams need to execute just becomes a lot faster, and like the quality of like sustained execution as well, because you can now take the best parts of the stack and create these custom implementations. And so the barrier to entry is also a lot lower for the ecosystem as a result of that.
So I'll go by the current taxonomy of separation of execution, consensus, data availability, settlement. But for me, what is most important is what modularity entails. What are the trade-offs between, maintaining, being able to customize your runtime, for example, versus being able to, or being forced to run on a generalized compute layer, or the benefit that you get in terms of state access versus the ability to accrue your own fees. So to me, modularity is really about what are the trade-offs and the spectrum of trade-offs that developers can play around with to really make the best application for the users.
Okay, so let's talk about those trade-offs, right? So maybe there's modular, integrated, monolithic, whatever. I'm going to call it integrated niche, but let's actually dive into those trade-offs. Okay, you mentioned that it's about maybe exploring what those are and where they might make sense in certain kind of application settings. So you're doing a gaming engine. So what are some of the things that you found as a shortcoming of Solana that you felt you needed to go this way?
So by far is the latency. So when it comes to building games entirely on chain, 400 milliseconds is not nearly enough. And it goes down to the question of why am I putting state and logic of my game on chain, but I answered some of those questions before. Is verifiable compute, permissionless composability, and the ability to create games in digital world that persist forever. So if you're fine with those assumptions and you are kind of you want to go down that path, then 400 milliseconds is still too long of a time for players interaction basically. And on the other side, there's an argument that apps do want to capture their own fees, or they do want to be able to, whenever there's congestion that happened in Q1, for example, there was sort of a wake-up call, I think, for many projects in our ecosystem, that even Solana can get congested. And so at that point, you obviously don't want to be constrained by the block time. You want to potentially have more TPS, spin up more block space, and accrue some of those fees.
Okay. VJ, you guys are doing an SVM rollup that settles on Ethereum, uses Celestia for DA. What did you kind of find insufficient about maybe existing rollups such that you felt the world needs something with that arrangement?
Yeah, so maybe from the Ethereum-centric perspective, right? I think if you look at a lot of the existing L2s out there now, they were definitely prioritizing for decentralization and building amazing ecosystems, right? But I think if you look at the TPS of the apps, or kind of the realized TPS of a lot of the existing apps on Ethereum L2s, it's generally at max and sort of like the hundreds, like say in the case of Arbitrum, right? And so for Eclipse, the genesis of what we're building, it actually came out of building app-specific rollups. And we kept on seeing the same construction over and over again, right? So using the Solana VM for execution, settling to Ethereum, which is still the largest user and asset base in crypto, and then using Celestia for DA. And so what we kind of organically realized is if you can really build a very dialed-in version of the SVM and building on a lot of the work that the Firedancer and Anza and other teams are doing, and use that same architecture, you can sort of have this one general purpose L2 that can support the needs of 99% of dApps out there. And so for me, my background is largely in the DeFi and the trading world, right? So I was previously at DYDX and Uni, and what you kept on seeing is that a lot of the leading perps dexes would go the way of a Cosmos app chain, or essentially build something that some might say is effectively centralization masquerading as decentralization. And obviously there's a spectrum there, right? But I think our philosophy is like there's a lot of power to building one shared general purpose L2 that can support the needs of 99% of dApps out there, and where you don't have to worry about the noisy neighbor or hotspot problem that you traditionally have had to worry about on Ethereum.
What about Rome protocol? What gap did you guys kind of see there that exists in kind of the crypto ether that you felt you can use Solana to help bridge that gap?
Right. For us, it was the Solana as a state machine. So we find Solana as a state machine is one of the best state machine. I mean, we compared it to Aptos, in terms of performance. We find Solana well decentralized, bringing Solana's consensus layer as a modular service for sequencing roll-up transaction. So the L2s, they are faced with the ordering of transaction. We see this problem of having to secure enough stake to guarantee this ordering of this transaction. So we want to bring that part of Solana to Ethereum L2s, where the ordering is immutable, where they feel that the transaction finality is reached much faster. So we are bringing that to Ethereum L2s, and we discovered when we were building the sequencer that it is not just the ordering of this transaction. There are a number of services that we can build for L2s so they can become as decentralized, as fast as Solana. So bringing Solana's fastness and security decentralization to L2s, because L2s suffer the centralization problem. And Solana being the third biggest chain and such a performant chain, bringing that consensus as a modular service. Because consensus and DA are so far been treated as a single module. So we want to break that. You can have a separate consensus from DA. So we are bringing Celestia as a DA, consensus of Solana as ordering of transaction to Ethereum L2s. So that's what we are planning to do.
Okay. Okay, so let's get to the easiest question, Swen. Is ZK compression a rollup? Actually, what is it? Okay, maybe start from first principles, describe what it is, and then we can classify it.
Okay. So I'll keep that answer to the very end. Before that answer that, you could answer it for yourself, maybe. So the main thing that ZK compression does is it scales data storage for Solana. So a little bit of context, and Solana is a little bit unique in that sense compared to something like the EVM, where you have compute and data storage and state sort of mingled together. In Solana, it's two separate things. And so compute is really cheap on Solana. Data storage is pretty expensive. And so all the validators on Solana have to keep around the current state of all the different accounts, for instance, token balances, in their active fast memory. And that's pretty expensive. There's a thing called rent. It's actually a bond that if I want to send you all token balances, I have to create that account and I have to pay for it. Currently for a token account, that would be roughly 30 cents or something like this, which is pretty expensive if you think about that compute is magnitudes of order cheaper than that. And so what ZK compression does is it allows Solana and smart contracts on Solana to reason about data and state that is not actually stored in on-chain accounts. So it's stored somewhere else. For instance, on the Solana ledger, which is ledger history, similar to something like call data or blobs, where the validator doesn't keep that data around for a long time. I think it's pruned over a couple days. But you can still index it as long as you have an archival node around. And so ZK compression allows you to store that data outside the on-chain account space. That way it reduces the cost by orders of magnitude. And so that's, and next to latency, that's sort of the second huge problem that builders on Solana have right now is if they create a lot of accounts, they pay a lot of state cost. And so I would say, back to your question, at the core level, ZK compression is much more like what in Ethereum space you would call like a stateless client. That being said, if you look at the system and you take a step back, it looks very much like any stateless execution environment where you have a state root on chain and you advance it through some service, maybe through L1 ordering. This is what ZK compression does. And this essentially allows rollups or validiums to plug into that. ZK compression itself is not a rollup, definitely not in my opinion. But it sort of like opens up the design space for a lot of these different VM designs.
Cool. Anybody have any questions around that? I feel like there was a lot of chatter about it, but no? Okay. Yeah.
But then, like, how do you verify whatever the state is that's like stored off-chain, on-chain? If, like, that just sounds like a roll-up to me, right? Like, is there like a commitment to that state that's stored?
Yeah.
On-chain.
So
it's like a Merkle root of like some other state elements.
Exactly.
But then, how do you prove to that whatever that state is on that is actually on Solana, that the changes are valid? Right, if it's not a rollup. And it also sounds like you're still storing, like the transaction's not being executed, but they're being stored in the ledger of the history of Solana. So you're using Solana as a DA layer. Like, to me, it just sounds like a rollup. So explain to me why it's not.
Yeah,
so I believe you because you know more than me.
There's, great question. So there's two parts to this I want to highlight. So one is typically what you have with rollups, as you know them from the Ethereum space or the modular stack, is that the state transition function of the rollup, which batches together off-chain compute, is happening off-chain, not on-chain. And so you prove the state transition function, which includes more than just the inclusion or validity of state, but also the actual state transition. This is not the case with sort of the ZK compression core primitive. This on-chain VM that we've built with Light Protocol verifies all the state changes on-chain, and then your custom smart contract can decide whether to do an off-chain or on-chain state transition function. But the core primitive that most apps use today, if you have a smart contract that lives on-chain, it's on-chain state transition. So what is being proven is just that, as you mentioned as well, the actual data was previously committed or published on-chain.
right? Like with any timestamp server. And so you have the inclusion state, simple Merkle proofs. They get batched together into a snark. So there's some similarities to rollups, but the actual STF is on-chain. And then the second element that I want to highlight is that with rollups, it sort of also alludes to the batching together of many different transactions into one batch, and then you roll them up. This is also not necessarily the case with ZK compression. You can have individual users executing their single transactions on-chain. They provide this very fast generation of the validity proof because it's just simple Merkle proofs sort of batched together in the end, right? And then you have the on-chain state transition. So not necessarily batching together, so that's why I don't classify it as a rollup.
Do you want to do a follow-up?
Earlier when you were introducing it, you mentioned that you call it ZK accounts. I wonder, are you familiar with Celestia ZK accounts, and do you see any similarities?
Yeah, I'm on a high level, I'm aware. And so, and that's a sort of a more longer term or sort of more sort of division aspect, or another thing that this enables next to just like scaling data storage is that if you have a custom program or smart contract, this doesn't have to be purely on-chain. It can have the STF off-chain. So as long as you can ZK proof your own smart contract logic, then you can plug into all the L1 tooling that Light Protocol provides. You can verify your state transition function on-chain. You can invoke the VM that we have, and you can handle your state changes through this sort of forest of state trees that we maintain. And then this is pretty arbitrary. You can, as long as you can prove your VM in a ZK proof in the end, you can have this sort of stateless execution on Solana. So it's sort of, I think ZK accounts and Celestia are more of even an underlying primitive. So probably Light Protocol would be somewhere in between Celestia ZK accounts and something like an ag layer, but it's not actually aggregating a lot of rollups. So it's somewhere in the middle there with regards to sort of the spec.
Okay, well, so I'll just ask this. I guess modularity kind of fundamentally relies on some pieces of the stack being reliable that you kind of plug into, right? For Ethereum, for example, they've made a decision to say, okay, we're going to scale up your rollups. We'll keep the base layer kind of minimally complex. And then every time somebody proposes something to the Ethereum base layer, people are like, no, 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 we don't want to do that, et cetera. But Solana is kind of the opposite, where we're kind of just, okay, we're just going to ship something, and it's going to work, probably, hopefully, whatever. And which makes it harder for people that are building modular things on top of it, right? Because the chain could kind of change at any moment because it's not necessarily being tailored explicitly towards other people hooking into it. How do you guys kind of think about that? Do you have any concerns around, so for example, with the gaming engine, core changes to Solana kind of affecting your business model, et cetera?
So the way our delegation works is leveraging this native separation of state and logic of Solana, plus the ownership of PDAs. Programs own these PDAs, and so I don't think that's going to change anytime soon. But because it's so intrinsically embedded into the runtime, that is just some core feature of Solana. And there might be changes that kind of affect our current design. For example, we have atomicity. When we delegate and undelegate, we can, in the same transaction, move the ownership into a different program and upload basically the state into the ephemeral rollup session, meaning the ownership is now in the delegation program in the validator. So there might be changes to that, but that doesn't fundamentally affect the way it's an implementation detail, basically.
Okay. Actually, I think this question can be kind of generalized to all of you, which is to say you use some part of Solana stack. Solana doesn't necessarily care about, I mean, Solana is just, I don't know, Solana Labs or Onza or Firedance or whatever. They'll just ship whatever they want without potentially, I don't want to say caring, but like not caring as much as, let's say, Ethereum would about breaking the modularity kind of chain dependency there. So in the case of an SVM rollup, for example, there might be a lot of core changes to the SVM. How do you think about like integrating those and kind of being in sync with Solana?
Yeah, it's something that is very much top of mind for us right now, especially with what's going on with the NZ team and the Agave client, the FireDancer team, and Frankendancer. So I think just zooming out, like it makes for a very interesting ecosystem, right? I think it's a little bit less kind of centrally coordinated and maybe the way it is for Ethereum, but that just leads to, I think a little bit more of like a grassroots vibe and kind of more players potentially coming in over time. And like, sure, maybe there's like a little bit more duplication of efforts that might be happening, right? But I think, for example, like the Frankendancer, which I think is expected to go live before end of this year, maybe by Breakpoint, but where you're sort of using FireDancer networking and the Agave client or runtime, like sort of like a hybrid, and it's not full FireDancer yet, but kind of end up with these things that are a little bit more incremental and allow people to build, while the plane is in midair. And so that's something that we're very much a part of as well, right? And I think for Eclipse, like the implementation we're thinking about long term is leaning into having a pretty centralized sequencer set, right? So just being totally orthogonal to what you see in most of Ethereum L2 land, and potentially even having like a single sequencer, right? So being able to really tap into hardware acceleration in the way that FireDancer is doing with FPGAs, and maybe even over time, like really move towards like ASICs and try and drive and keep driving an order of magnitude improvement in the TPS potential of Eclipse. So that's kind of what we're thinking about. And I think just going back to your point, Mert, like there's definitely a little bit more, I think just staying up to speed with what multiple partners are doing, but it just creates a very interesting kind of research environment where people are able to feed off each other as well.
Yeah, I mean, for Roam Protocol, I feel like you guys actually really depend on Solana base. They're not changing in a sense, but FireDancer will just say, I don't care. How do you plan to deal with that?
Yeah, so for us, it is especially very important to have diverse opinion of the network. So we take splitting of the team and then your team Helios and other dev coming up. It is actually a net positive for Solana, I think, because diverse opinion, diverse people contributing to Solana, and having a vision that is not, let's say, monolithic itself in thinking or linear in thinking. So it brings, I think, the diverse opinion along with respect for what other people want to build more in play, rather than when it is a centralized development environment, development team that is doing it. So there are a number of challenges that we face for shared sequencer in terms of transaction size, having abstraction of the consensus layer a little bit more than what it is. So these are like very important thing for us, and it helps to have diverse opinion talking to other people, like how we can get that. When you have a very high performance chain, it is easy to still build your modular stack on that performance, because that performance of the chain hides, you are able to hide some of the slowness that is caused by making it modular, but eventually you would have to provide some abstraction. So if I were to just throw in like, okay, creating a proof of history as an L2 on Solana, right? So if I want to provide that as an L2 service to anybody who wants to use proof of history. So today I cannot do that, but if there was some abstraction that was available on Solana, it would be very easy to provide that kind of L2, which could be very beneficial to those who wants to use proof of history in some form or fashion.
Okay, Sven, how about you? I mean, maybe one case is like ZK, syscalls not being live on L1, you kind of don't have a control over that. The state kind of cost could be, like, it could actually be enshrined ZK compression to core protocol. How do you think about that?
Yeah, for sure. So there's multiple facets to this. I mean, with regards to the syscalls, it's a funny and long story. I mean, when we started building the first syscall for ZK into the runtime, that was mid-2022. And back then it was like pretty quick to merge something into the runtime, which is sort of, I think that's just a natural process with any successful L1. I just spoke with someone who was there in Ethereum early days. and was able to merge, had like push writes to the Ethereum client code base. But fast forward to today, it's nearly impossible to get something merged into the Ethereum code base. The same is happening with Solana, and there's so there's another whole tangent there, which is that I would say, but I'll get back to that later. To answer your question, ZK compression live protocol is very based. So like unless there's any breaking changes with existing applications on Solana, then we'll be fine. There are some things where you do have, if you're building infrastructure on an L1 for application protocol developers, you're always sort of like at the risk of being enshrined. And I think that's actually fine as a healthy competitive thing, where as a protocol that's building infrastructure on an L1, you just have to sort of outrun the L1 and sort of try to provide more value than what the L1 can catch up with by enshrining you. And at the same time, I think that over the long term, all the good things infrastructure-wise should be enshrined into the L1. I think actually that's, if that's not happening, then you do have a problem from an L1 perspective. So like that gets me back to the beginning of the point, which is like the day that Solana really stops pushing stuff and changing stuff, and in that way like maybe also competing with some of the infrastructure layers on top of it, that's actually sort of the beginning of the decline, I would say, of a successful chain, because like you need both. You need the protocol changes, you need people to actively push the protocol forward, and then you also need, on the application level, you need infrastructure builders of various different sizes and shapes to push the chain forward. And always sort of in total, you always need to sort of remember that the goal is to make it easier for application developers to build on top. And I think as long as everybody's pushing into that direction, and which is also interesting, speaking of like social fragmentation, et cetera, around the incentives around launching your own L1, et cetera. But like, if you can keep sort of a standardized interface and can all sort of, as application and protocol developers, push towards a single decent platform for application developers to build on, then I think that's a long-term success case for an L1. And I think Solana is on a pretty good track so far.
Okay. I want to actually, you said something kind of spicy there, which is that everything that maybe is successful should be enshrined into the core layer, which is to say that if you play out the modular kind of roadmap a little bit, in its end state, you have kind of these pieces that as they fit together nicely and you kind of see a path with success, they actually become integrated. Does anybody have any strong opinions in the audience that disagrees with the thesis that everything should be enshrined over time?
I mean, I think Swain kind of set the point that a specialized team is likely to outpace the team on the L1 because they're doing so many different things at the same time. So I think something that's not enshrined would always outcompete the enshrined thing. So I kind of agree with Zen to some extent on that point.
Okay. Does anybody not agree? Oh, I see a lot of hands over there.
I think you should probably like enshrine stuff, because at some point you don't want like critical infrastructure in the hands of like third-party operators, because that's kind of like something about dealing with in Ethereum. Like even if you have like this business that's really good, that's like censorship resistant and secure and decentralized, but like you have like critical infrastructure operating on top of it, and if that goes down, that affects like UX and stuff. So you want that stuff downstreams like the base layer as soon as possible. So yeah, and you want it also operating as a public good, so free of capture and all of the things, the nice things that come with like base layers as well. You want that for critical public infrastructure as well. So yeah.
Do you agree, disagree?
Yeah, I mean, he made a couple of good points. So there's I would say sort of like the antithesis here is like, you'll always have this like bundling and unbundling, and like everyone who's successful will eventually compete on the same things. So like there's a natural incentive to like you start as a protocol on the L1, and then you eventually sort of try to unbundle and like build your own platform. And so there's like this competition, right? So, and if the L1, so from an L1 perspective, you start out quite fine because all the applications built on top of you. Eventually you hit this sort of negative network effect where congestion is actually really bad for applications building on top. So they try to go away. Maybe they have their own fee incentives. They go away, build their own L1, maybe to increase their fee capture mechanisms to make that more beneficial for them. But if you don't enshrine, then you have lost. Because then the competing L1 has just so many benefits because you're congested, and a new L1 can launch a token, and it's going to be debased in relation. So like you as an L1, from the L1 perspective, you definitely want to enshrine over time. You are also always going to be slower than an L1, so it's like sort of this, that's always the battle there. You're going to be slower than the application building top just because of technical debt, etc. But yeah, I think my point still stands is like, if you're an L1, you need to enshrine, otherwise you lose.
Yeah, I mean, these are pretty complex questions, so let's maybe come back to a super simple one, and I'm going to ask this to every single one of you. Does Solana need rollups to scale? Let's start with Andrea.
Well, I'm kind of biased because I'm literally building ephemeral rollups on top of Solana. But so I think it makes sense to scale or to have rollups. Let's call them custom execution environment, where you can run some computation off chain for many different apps, for fully on-chain games. That makes sense. The question is, what are the trade-offs, right? Because an integrated chain, you didn't ask us what we like about Solana, but pretty clearly we are all building on Solana, or we are building on the SVM because we think that composability is the killer property for blockchain, right? When we start building on Solana, at least we love the idea of building a single composable state machine that could settle globally at the speed of light, where developers, users, primitives were all in the same place. And so you have to pay attention to, leaving behind those things when you're building on a different execution environment. But I think it makes sense for many different use cases, and perhaps for more than we think, to being able to selectively move some of the computation off chain. And so in our particular case, I'm obviously biased, but we came up with this idea of deploying the smart contract on Solana and then execute state transition function for specific accounts in this off-chain environment. So that's kind of my thesis and our approach.
Vijay?
Yeah, I think over a long enough timeline, they will definitely be a part of the fabric, right? I think this is talking about when like the Web 2 developers are coming in with sort of Web 2 scale type use cases, and you're looking to build like these fantastical kind of game worlds that you guys are thinking a lot about, and there's lots of other use cases out there, including DPIN, and so I think definitely at some point like it's still maybe like a bit early, but I think we'll get there. Mostly because Solana as an L1 has to worry about the shared security component, right? And that's what every L1 has to worry about, right? And so as an L2, you don't need to worry as much for that or sort of manage multiple trade-offs, right? You can really lean into the performance aspect and rely on the L1 for the shared security piece. So I think from like a design perspective, like I definitely see that becoming a trend. But I think if there is an L1 that's capable of supporting millions of dApps out there, it's going to be Solana.
Yeah, I mean, I think simple answer from my point of view is yes. People have diverse opinion, developers have diverse opinion, people have different need, and they are expressed in a different way. And having rollup allows you to express that opinion in terms of application, and Solana is no different than, I think, any other chain that would need rollup for the expression of that opinion.
Cool, yeah. If Solana core teams manage to increase the blocks, block size, I think that would lower the value of a lot of these sort of off-chain computation constructions. So I think it mainly hinges on those sort of questions. Can we, when is that going to happen? And then also, I mean, I think Helios as an RPC provider is like currently working on like 0 to 1 slot confirmation times, which is on the L1. So those sort of things, Solana not necessarily being opposed to increasing block size. They haven't really done it yet, which I'm surprised by. But and then also other infrastructure teams working on really fast confirmation times, even within a shared block space, give me a lot of confidence that there are a lot of based constructions you could build on Solana, and also for the time being. And I think if you can have that sort of an integrated developer experience, I think that's extremely powerful to then sort of like get to hopefully new applications that sort of get, can lead to sort of a new wave of action on chain. That being said, I also do think that there are good arguments for, as the L1 protocol development slows down, for sovereign tweaks you can do to your runtime. So I see value in that, and I also see that there is just like this super capitalistic nature to trying to unbundle and like build your own platform if you're a successful application. And so I think rollups are definitely happening on Solana. And it sort of depends on a couple of other factors, as I said previously, whether or to what degree they are sustainable.
Okay, cool. Well, we have like basically no time, so I want to save a minute or two for any general questions to any Solana people while you guys have us here.
All right, great. Any questions from the audience? All right, how about a little poll? Do we think that Celestia? Do we think that Solana is modular? So raise your hand if you think the answer is yes. All right, let's see the no's. All right, well, it's interesting voting participation from all you guys in here, but it sounds like Solana is modular. So if there's no more questions, then I want to say thank you to the panel, to Mert, and let's give them a round of applause. All right, and we are just going to take a 5-minute break here while we switch into presentation mode, and see you soon. Yeah, we're just waiting for you. So.
Sounds good.
Vias? All right. All right, everybody, please take a seat, and we are going to get started with with Vias from EigenLayer to talk about EigenLayer.
What's up, guys? Thank you, everyone. First of all, I want to start off by saying thank you so much to the Celestia team, everyone who organized this amazing event, and the opportunity to be here. Like, we really appreciate that. Good to see some familiar faces. Pleasure as always. Thank you. Oh, lovely. Appreciate that. Today, we wanted to really, first of all, appreciate that we have the opportunity to speak on this event, and we wanted to talk about where we see kind of blockchains going in general in the next few years and where EigenLayer plays a fit. So kind of giving you guys an update on what we're thinking, what we're doing. So we wanted to talk about coordination today, right? We see blockchains as the best mechanisms for digital coordination systems. These, we believe that the rate of innovation of a society directly mirrors people's ability to coordinate with each other. And if we can coordinate more effectively, then the rate of innovation dramatically improves. So just some brief examples, the Roman Empire really dramatically improved the ability for us to coordinate in terms of infrastructure. So we saw rapid improvements in innovation through that dimension. Greek city-states improved civic participation through democracy. Right? So we ended up with far more, involved citizens of society. We saw rapid improvements in art, philosophy, mind share, etc. And eventually we reached this point where as we started improving our coordination dimensions, we got to this idea of information coordination, right? The telegraph, radio, TV, film, etc. But we moved to the internet, and the internet brought with it this completely new paradigm in how we communicate with each other. But the problem was we stayed on the old coordination systems of yesteryear while trying to adapt to this new thing over the last, 20 years, which is where you ended up with, a lot of different issues with coordination across information, right? We see misinformation, we see censorship, we see all these dimensions. So let's take a second to talk about those dimensions, right? You've got financial coordination, which is what Ethereum is working on, what most cryptocurrencies themselves are working on. You have physical coordination, which is, hey, how do we look at all these resources that we have as a society and find ways to effectively optimize those, right? Those would be more like DPINs, decentralized physical infrastructure networks. We also have social coordination, which I think a lot of people are very interestingly working on SocialFi, on GameFi, whether it's social consensus, which shows up in a lot of ways that blockchains fork and make decisions, which I'll get into in a bit, as well as identity. Identity is a huge factor because today we really don't know how to discern whether somebody's a bot, somebody's just farming, somebody's an actual benevolent member of the community. There's very hard ways to distinguish between active users in a community. So let's look at where coordination is at today. And I think there's a lot of cool things that the internet brought with it, right? Open source platforms, right? We can all work on some stuff without even having to talk to each other, and open source code can dramatically improve how societies work on projects together, which I think is quite interesting. Kickstarter enabled the ability for any of us to just go in, pop up an idea on Kickstarter, get some funding from the crowd, and kickstart a project. Let's go, right? Let's build some cool stuff. Scientific research networks, but like I said, there's a lot of broken factors to coordination in these centralized systems, right? Rent-seeking behaviors, meaning somebody can come in and say, hey, I don't like the type of project you're deploying on Kickstarter. I don't like this, so I'm gonna kick you off, right? I don't like the information that you're spreading on this social platform, so I'm going to kick you off, et cetera, et cetera. And so this is why we're trying to rebuild from the ground up to some extent in terms of what types of coordination that we actually want to work on as a society. And hopefully this is why all of us are working in decentralized infrastructure or decentralized applications, because we believe in some of these dimensions being important. So what is the issue at hand is there's really three types of ways to look at the problems where people come to consensus, right? There's objective faults, meaning I can objectively say that I gave you a math question and you got the question wrong, and so like you were objectively incorrect, and that's pretty, verifiable. Everyone can see it. 2 + 2 is not equal to 3. It's equal to 4. We all know that, and so like I can say that you're wrong and I can slash you. An example of that would be deploying some code, and the code was supposed to receive some output, but that's not the output we got, right? However, subjective gets way more confusing because subjective questions are like, what's the best restaurant in Brussels, right? Like we all probably had a completely different experience in terms of what we ate this week, and we all probably have our favorites and our least favorites, and we're never gonna be able to come to some conclusion in saying, hey, what was the best one, right? We're all gonna have our own opinions. So is it even worth verifying that? No, it's not, because it's inherently unverifiable. But there's this like middle ground called like intersubjective, which is, referential to the eigenintersubjective token, but also like this idea in society where over broad agreement, we come together and we say, hey, here are these subjective things, and we need to make them objective truths, and how do we go about the process of that like middle ground? So let's go into some examples, right? Galileo is a really good example of this because we used to believe that, the sun revolved around the earth, and we were grossly mistaken, but the problem is the church and the Bank of Medici really did not like this idea coming out from the scientific community at the time, and they quite literally slashed him, right? He was thrown in jail, he was killed for his thoughts. And what ended up happening is society realized that, hey, here are these subjective truths, and here's this objective fact, and we need to find a way to like bridge this, and we took a moment to recognize all of these things, and we ended up saying, okay, fine, we need to move to the heliocentric model. The geocentric model is broken. Like, we can observe that these moons exist, everyone can see them, whatever, right? Let's go to something more fun and way more recent. Kendrick versus Drake. If you guys watched the rap beef this year or listen to rap at all, both artists put out a bunch of music against each other, right? You can objectively say that like, hey, these artists had this amount of streams, these songs had this level of sentiment analysis, and the sentiment of Drake went down, the sentiment of Kendrick went up. Oh, Kendrick only had a #1 hit after dissing Drake. You have all these opinions, but the reality is you can take something that's highly subjective and make it objective by asking the question, who won the beef? And that's a moment of intersubjectivity in society that we're currently dealing with. And we'll see if Drake responds, but as of now, Kendrick's winning. So maybe it becomes objectively true that Kendrick won the beef. But let's zoom back into crypto and ask ourselves, like, where do these things actually matter, right? Why build an intersubjective token? So you have something like the data withholding problem in blockchains where you ask the question, hey, somebody said the data was available, the data wasn't available. This is like kind of subjective. How do we deal with this? So we want to tackle this with the intersubjective token. But it gets far more interesting with like oracles or rogue AGI. So let's say somebody provides a wrong answer to an oracle. How do you decide whether that was correct or incorrect? There's a period of intersubjectivity there where like someone else has to come in and the group has to decide on what they believed was the real price input. Or, and this is where we see things moving forward, is with the eventual introduction of AGI into our lives, which I don't think is as far away as we think, how do we identify that somebody introduced a rogue variable and decided to mess with it? And somebody, whether it's an external party that is detrimental to our society or somebody who was just messing around, regardless, how do we identify and verify that they were not supposed to include this bad data into the training model that eventually affected the AI, right? That itself is something that we need to be able to objectively verify. We need to be able to achieve a social consensus as saying, hey, this was good, this was bad, and we need to slash those people, right? Because it can have really gross repercussions. So as we look at intersubjectivity, it's not necessarily just about who's right, who's wrong, but it's also this effect that society has on each other that we agree upon. So we want to touch on like where applications are at today, because the reality is most users, most of us, we interact with Web 2 applications still. The user experience in Web 3 is kind of broken to some extent. We end up, most of us end up using applications that are not Web 3 applications throughout the course of our life. And the reality is most applications are comprised of multiple different SaaS modules, right? You log in with Google through OAuth. You pay through Stripe. You have some sort of AI model in your backend that helps Spotify come up with its curations and its recommendations. Those are all different SaaS modules that these builders have to subscribe to. And one of the beautiful things that modularity brought to crypto is it reminded us that the service-based architecture in Web 2 has manifested itself in Web 3, right? We need these modules and we need people to build services throughout the ecosystem to provide value. And I think there's something highly beautiful and important about that because it helps builders go back to this primitive that they're used to, which is, hey, I'm used to plug and play, and I don't have to worry about this like monolithic stack that I'm subscribed to, and I have to only build in this dimension. I can build and just pick and choose what makes sense for me. But while we want builders to experiment, what we saw in the last cycle is there were plenty of dimensions of value escaping the Ethereum ecosystem, right? We had all these projects in order to experiment on one portion of the modular stack needing to do more than just experimentation, right? You needed to not only experiment on the modular stack, but you also had to build your own trust network, bootstrap your token, build your own market cap, and now your security is also primitive to your market cap. And maybe you lose sight of what you wanted to focus on, which is maybe you were just trying to experiment on building the best consensus algorithm possible. But now you got to do all this additional work just to try and experiment on building the best consensus algorithm. And so we wanted to enable Ethereum native development and value distribution because why is all this value escaping the Ethereum ecosystem by starting their own tokens? Let's bring it back into the ecosystem. Let's let people experiment by borrowing security from Ethereum stakers and restakers. And so this is why we built EigenLayer, right? EigenLayer is ETH staking along with custom staking, and now we're introducing these objective, intersubjective faults to be able to build this shared security system. And with the shared security system, now people can experiment across all these dimensions, whether it's roll-up value-add services or co-processors, where you can now, projects like Cartesi allow you to deploy Linux VM directly on Ethereum. Well, Linux already has a ton of applications. So why would we start over from scratch and say, hey, we need to build everything in this new primitive when we could theoretically just bring people over? That's the goal. But the reality is we have a lot of different cryptography and a lot of different solutions that are very valuable to our community because we can provide these very different, very unique value propositions. And so rather than all of these being their own blockchains or their own L2s with their own token and their own market cap, where what ends up happening sometimes is when you need security the most is when it will fail you if it's in your own token. Meaning you saw debt spirals in the last few cycles where, okay, let's say a bridge gets hacked and now there's a complete exploit on the bridge. And now the token security is built entirely around the market cap starts going down, token price starts falling, and then what ends up happening? Okay, we don't use the bridge anymore, someone else rebrands it, they redeploy it, whatever, and we end up with this highly fragmented, highly broken ecosystem. So rather than doing that, maybe borrow security from Ethereum and rebuild these primitives on EigenLayer, on Ethereum, and we bring all the value back to the ecosystem. And as I touch on value, the reality is most of the applications today in crypto are DeFi. And DeFi applications naturally have very, very high value per bit because the value is financial. And we care about our money so much that we want the utmost security when it comes to transactions that involve our money. If money's moving hands, I want it to go through the safest parties. Very natural. The problem with that is we are not thinking about any applications outside of what most of us interact with today, which is, DeFi is made for traders and lenders and, financially driven actions. But social actions don't really care about the security as much. An easy example in gaming might be, let's say, maybe Nick and I are playing a game of chess, right? And, there's a constant state update in terms of the moves I make, the moves Nick makes, and what ends up happening is yeah, all of these moves get written to the chain. Cool. Does it matter? I don't know. I don't think most people care about every single state update. But let's say there's a betting market on the result of Nick and I's game. Now people might care about the result and the finality, because the embedded value in each of those state transitions, aka those moves that we made, is not necessarily the embedded value that's in the end result of the match, because there might be a polymarket bet on it, and that's got way more value embedded than the inherent state transitions. So you end up with this like throughput versus security trade-off where you need high throughput for these social actions, but you might need like less throughput but a lot more security for these value-driven actions. And so this is where we see like a lot of difference in how we need to start thinking about consumer versus DeFi-driven use cases, and whether the DeFi users are our consumers that we're aiming for. Those are all open questions that we have still. So we want to deploy the cloud era of crypto, right? How do we bring all these cloud social consumer applications back into our ecosystem and actually make a dent on the number of users that are involved here? Because the reality is we need to start expanding the scope of our ecosystem. And for context, EigenLayer is live now, and we have a bunch of AVSs in our pipeline. We have a bunch of AVSs that are live. Restakers can deploy, operators can validate, and you end up with this like really effective, benevolent ecosystem where a bunch of people are constantly building and are trying to identify like what is the fit for their products in their market, and they're still inside the Ethereum ecosystem, so they're providing value to all the L2s, which I think makes it quite interesting. The other thing, why L2s, is because L2s can do very cool things for actual consumer use cases, right? The sequencer, if it's, and let's not talk about decentralized sequencers right now because that introduces its own latency and its own complexity while it also has its own value props and trade-offs. But the sequencer can give instant confirmation. You can do gasless transactions. You can do no wallet usage. You can do all these cool things. And eventually, maybe we can deploy Unity VM or the Unreal Engine on blockchains, and we can start porting over like actual games to the ecosystem. So you end up with off-chain gameplay with on-chain incentives, because nobody wants an on-chain game. Like, the user experience will be dramatically broken if I have to wait 12 seconds every time I want to make a move on a game. Like, none of us would enjoy that, right? So we need to be able to do that with extremely low latency while also allowing users to have the on-chain incentive mechanisms that like matter. So what are the problems with rollups today? Throughput, cost economics, security, the feature sets, but each of these dimensions are things that we're tackling at Eigen because we have different teams in our ecosystem that are still inside the Ethereum value props that can like come and solve these situations for us. And what we want to do is enable these rollups to be competitive with L1s so that at some point, EigenDA and EigenLayer can help these rollups outrun the L1 ecosystem. Rather than every project launching its own L1 and that liquidity, that composability, that Ethereum ecosystem value props being fragmented, we end up with this like highly benevolent, self-reinforcing ecosystem. And by bringing these new services, I think we can eventually make a dent across the AI coprocessor space, whether it's more cryptographic encryption, can we bring 2FA authentication? One of the most exciting things I see is the EIP for Face ID. And yeah, sure, you can tell me that there's a high false positive rate in the Face ID, which is why WorldCoin has taken the retinal scan approach. But the reality is, like, most of us love using Face ID, and maybe we need to add a crypto economic cost in addition to a cryptographic primitive. So, there's a high cost of penalty to misbehaving even with Face ID. To close out, I think the most important thing we need to start thinking about is how do we make a dent in the overall adoption of Ethereum and the actual number of users in the space and start tackling some of the UX problems. Big shout out to the entire EigenLayer team, Sriram, our founder, and you know what? Thank you so much for your time, guys. Really appreciate being here, and feel free to find me after to catch me for any questions.
Awesome, thank you. We actually have time for one question if anyone has a question.
What's up, guys? You mentioned a super cool idea around prediction markets affecting the result of certain outcomes, kind of like creating this self-fulfilling prophecy, and then how kind of like intersubjectivity can play a role in the economic security of making sure that these systems, stay solid. Yeah, I think the question is just like, can you expand upon that a little bit and kind of how you see this self-fulfilling prophecy kind of cause some consequences?
Yeah, definitely. This is very much an idea, nothing nowhere near execution, but I'll still share it to like give you an example of what we're thinking about, right? Every year, the annual League of Legends or Dota championships have really massive prize pools. But you also end up pretty constantly with a bunch of cheaters in the space. So imagine a world where like every single gamer at every single gaming competition had to create a cryptographic proof showing that they were running the anti-cheat that was necessary to play that game. And then their earnings were all on a smart contract, right? We want to build a world where eventually the smart contracts, the proofs, the prediction market that's betting on like who's going to win, who's going to lose, as well as like potentially the live streaming ecosystem where like we're watching it on, is all completely on crypto and distributed systems where we have like the Ethereum community participating in that. Why does that matter? Well, maybe we find someone cheating and now rather than incentivizing them to cheat and they can keep their prize winnings, what if we could slash their smart contracts based on like we identified that their proof was incorrect based on they weren't running the anti-cheat, they found like some exploit, and now they've completely circumnavigated the integrity of the game, but they're still allowed to keep their winnings, right? Like let's tackle some of these issues because I think like we build a highly more integral, highly more valuable, highly more like responsible ecosystem. So just an example, Andy, but would love to chat with you more offline and yeah, different ideas on different executions.
Awesome. Well, thank you very much. Let's have another round of applause.
Thank you so much, guys.
Thank you. And now we have Togrul from Scroll to talk about shared security. This is for you.
Hello, everyone. Nick messaged me a few weeks ago. He told me, we need something spicy. Can you come up with something spicy? And I think I haven't pissed off enough people this week, so I decided to come up with something spicy. So my name is Togrul. I don't know, I do something at Scroll. Complain about things on Twitter, I guess. And my talk today is shared security as a PSYOP, or the roast of restaking protocols. I'll just give you a secret. I'm moderating a panel on restaking later on, so it's going to be spicy as well. So let's start with the basics. Security is not a binary construct. So also, it's not a one-dimensional construct. It's a spectrum. And security in the context of distributed systems can be broken down into 3 types. I'm struggling here, okay? Economic security, which basically means it introduces an economic cost to certain types of attacks. So think of proof of stake, of proof of work. They introduce a certain cost. Then there's protocol security, which means that basically the protocol enforces certain rules on the level of full node. So think of, let's say if an Ethereum validator, a proposer for a slot proposes an invalid block, the full nodes will just reject it. So an attack is possible even if you control like 67% plus of the total stake in Ethereum, but all the honest full nodes will just reject that block. So the protocol still enforces the rule even if you manage to overcome the economic security. And then the big boss of everything is social security. So basically, we introduce social coordination costs to the attack. So even if like you manage to break both the economic security and protocol security somehow, the social consensus can just agree to ignore it. So for example, you can socially slash someone or just roll back the chain, etc. Think of the DAO hack, for example. So these guarantees are typically layered in a typical L1. So for example, if the economic security fails, you fall back to the protocol security, and if the protocol security fails, you fall back to the social security. So shared security has been a buzzword for quite a while that is commonly used to describe various constructions. And it is a valid term, but it's been basically co-opted by everyone who wants to use it for anything, anywhere, and it became quite a buzzword. So what is shared security? Or precisely, can protocols share security through economic security? The answer is no. I'll front run it. So imagine a scenario. So a malicious entity attacks protocol B that is economically secured by protocol A. Possible, I don't know. Let's say there's a chain that is secured by an AVS and eigenlayer. So to successfully perform the attack, and let's say all the staked ETH are staked into that AVS. So to successfully attack, you need to control 67% of the economic security of protocol A. And let's say it's objectively slashable. So for example, I don't know, it's a double spend. And basically, when you double spend or do something, protocol A just slashes your stake. So if the profit of the attack is higher than the cost of the attack, then the attack was successful. And basically, protocol A remains unaffected. It is somehow somewhat affected by the fact that a lot of ETH gets slashed on the base layer, but it's unaffected in the sense that basically the protocol continues functioning and it doesn't fail. It just loses a certain percentage of its security. So do protocols A and B share security? No, again, no. No, the answer is no. And so the correct way to say it is that protocol A and protocol B share economic security. So then what the hell is shared security? So shared security is when protocol A and protocol B share protocol security. So what that means is if protocol B fails, so should protocol A every time. So basically, every time there's an attack on protocol B, protocol A fails as well. Like there should be no exceptions. And so if restaking only enables economic security, why does restaking require stake tokens? Well, they do not. It's a lie. That's where the PSYOP comes in. We've been lied to that restaking actually needs stake tokens. It does not. It is literally a PSYOP. You can literally stake any token, and get comparable security guarantees. Obviously, you can argue that tokens that are too volatile or have, like if you launch a meme coin that has a value FDV of like $20 billion but gets rugged in a day, obviously that's not an option. But for any token that has a stable and a liquid market, it is a valid approach. So you can literally stake any other token and get the same security guarantees. So I went through the website of the major restaking providers, and I think it's time to correct their messaging a bit. So, eigenlayer, shared security to hyperscale Ethereum, restake now. Partially shared economic security to hyperscale Ethereum. That's the correct way of saying it. It's symbiotic, permissionless restaking. Symbiotic is a generalized shared security system enabling decentralized network, blah, 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 whatever. It doesn't matter. Symbiotic is a generalized, partially shared economic security system. Doesn't have the same ring, but it's truthful. Surprisingly enough, Grok is actually quite honest. Grok is the universal restaking layer powered by the entire crypto economy across every asset and every chain. Somewhat true, a bit embellishing it, but whatever. I'll give them a pass. Babylon, Bitcoin security. BTC security, it's not Bitcoin security. Come on, guys, you should know better. Sollayer, the shiny new boy on the scene. Sollayer shared security, secure Solana's native security, a restake verification rollbacks utilizing Solana's L1 validators. Genuinely, no fucking clue what they're saying there. Genuinely, like, what is that? Whatever, it's fine. Let's pretend that it's partially secured, economically secure, whatever, it's fine. Now you might rightfully ask, what about rollups? Because a lot of people keep shilling, oh yeah, rollups share security with the underlying base layer, blah, 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 super secure, Ethereum secured, whatever. Is security inherited by rollups PSYOP as well? Well, It's a bit of a yes and no. It depends on how you phrase it. So rollup inherits certain security guarantees from the base layer. So for example, they inherit, So they inherit ordering guarantees, DA guarantees, etc., but they don't inherit full security. And again, when the rollup fails, there are certain scenarios where the underlying base layer doesn't fail. So that's why rollups share partial security, protocol security with Ethereum, because they inherit certain guarantees, as I mentioned before, like ordering DA, etc. And so in certain scenarios, a rollup can fail without affecting the underlying layer. So for example, let's assume a rollup that has fraud proofs, because fraud proofs are more likely to fail. Fails because of the fraud proofs. The L1 still continues functioning as normal, but the rollup has failed. So that's why I would argue that rollups don't inherit full security, but inherit a lot of security from the base layer. So yes, shared security is a PSYOP. Thank you very much. And if you have any questions, feel free to ask.
Awesome. Well, any questions? Behind you.
I understand that EigenLayer as like the primary example doesn't have slashing in the current moment. Does this upset you even further?
Can I be even more upset? I don't know. I think yeah, it's. But to be fair, you can criticize rollups for not having multi-sigs as well. So, assuming that EigenLayer has a path towards having slashing, I wouldn't criticize them fully for that, as long as they're honest about the trade-offs that they currently make. So, if they in like 3 years' time they don't have slashing, then yeah, I would be super unhappy with that.
How did you define shared economic security? Like, I'm confused by that term. Like, what do you mean by that?
So shared economic security is essentially when you have all the tokens that are staked in protocol A securing protocol B as well. That's shared economic security. You can also have partial shared economic security. So for example, assume an ideal version of EigenLayer that has like, I don't know, 30% of all the restaked ETH, staked ETH restaked into EigenLayer, then it shares part of the economic security of Ethereum, but not full economic security because there's more money backing Ethereum.
But is that really like sharing security, or is that just like overloading the same collateral with more risk?
Well, you'll have to wait for the panel now, which I'm moderating, to find out about that.
Yeah, because
I'm not going to reveal all my cards now.
Because I mean, to me, like building off of your other definition of shared security, like what shared economic security, what should be is that like this stake gets slashed only if the other like stake for the other protocol gets slashed or something. Like I don't know. There's not like shared. There's nothing that's actually shared. It's just that you're putting the same capital at risk for two different things.
Oh yeah.
So it's not even like sharing. It's making it more like maybe more capital efficient, but you're just like double counting and like rehypothecating. So Nick, it's not like you're sharing economic security.
Nick, can you please not be harsh? I put the slides last night together. No, I get your point. So obviously, if like the capital opts into multiple slashing conditions, then you increase the risk. I'm not sure if I would say that you double it because certain things are less risky and more risky. But yeah, of course, if you opt into multiple slashing conditions by default, like you increase the risk of your funds getting slashed. So I think there's a comfortable threshold where if you do too much, then I would not be comfortable with that anymore. But I guess for like 2 or 3 relatively safe approaches, I think it's fine. But again, I'm not sure about like where the threshold is there.
Yeah. Why do you think that I don't know, the broader crypto community has allowed this like messaging of shared security to persist so long?
I see.
I'm seriously, I'm genuinely wondering because it's like so disingenuous in my view.
I don't know. People still shield trustless bridges after
That's
like
true.
5 years.
That's true.
Like Avalanche, I think, still says that their bridge is trustless.
That's true. Yeah. Anyway, well, thanks, Togrom.
No worries.
Oh, we actually still have some more time. So more questions?
Yeah, hi, thanks for the talk. Curious what you are thinking, because you didn't mention anything about it. Interchain security, the solution, the shared security solution provided in Cosmos, and also the Cosmos Hub is changing the paradigm there to make it as a launch platform instead of a security solution. So it's just making it easier for other projects to launch off proof of stake. Do you think that makes more sense than to sell it as security?
So I think I didn't mention in my talk because I wanted to make it spicy, but I think there are genuine use cases for staking, or as we call them, restaking protocols and shared security. For example, it's very difficult to bootstrap security for a lot of things. So I don't think the problem is inherently with the protocols themselves or with the idea. It's just one, how much security do we actually need? Do we need billions of dollars to secure everything? And two, how we present it. So if you present it as additional economic security to bootstrap your protocol, I'm perfectly happy with that. It's just my problem is that we over-embellish things and try to present things as what they're not.
One more question? All right, well, Torgo, thank you so much for this spicy talk, and I believe it's about to get spicier. Sorry. Immediately following this, we have your panel where we're bringing on the restaking providers to answer that. So just give us a few minutes while we change up, and thank you. While we're killing some time here, let's just do another quick straw poll. I mean, thoughts on what we heard here. Is shared security a meme, legit? Do we have problems? Do we agree with this presentation? So for the yeses, raise your hand. The no's, raise your hand. All right, well, we still have participation problems in here, but this one's tied at least. All right, and if everyone's in the room, I guess we can just kind of get started early, but Torgo, you're moderating for us. Sunny, Misha, and Vyas, are you all here? Oh, we had Vyas earlier.
Vyas heard my talk and decided to run away.
All right, well, we'll give him a few minutes. Maybe you guys can tell jokes or something.
I don't know. Do you guys have any jokes?
Well, we're waiting for one more.
You can start without him.
Yeah. All right. Yeah. What's everyone's favorite story about Misha? Or sorry, about Vyas?
Oh, there he is.
Oh, that time he was late at Modular Summit.
Yeah. Appreciate that, guys.
Yeah, go for it. That's more fun when people are drunk on stage.
Yeah.
You don't know how much
Belgian
he had.
beer can be pretty.
Also, you don't know how much he had before.
I may be a couple beers deep. You might not be wrong about that.
Were you preparing for the panel?
No, I was a couple beers deep on the last talk, too.
Fair. Makes sense.
Tell?
All right, guys. Welcome to the panel title. What's the title? Oh, yeah. Is economic security a meme? Well, I'll answer yes, but no, I'm just joking. So with our esteemed guests here, do you guys want to present yourself first before we jump into it?
Sure. My name is Sunny. I'm one of the co-founders of Osmosis. It's a DEX app chain, has its own native staking token, but with ability to stake other things other than just the native token, like LP shares and potentially other tokens in the future coming soon. So, yeah.
Hey, yeah, I lost my voice like 2 days ago. So yeah, my name is Misha. I'm co-founder of Symbiotic, permissionless restaking protocol, and permissionless and shared security protocol. I don't think it's a meme. I think it's been used incorrectly in most cases, and I think that information is not spreading efficiently about that. But if we are careful, we can do a lot of good with that.
Hey guys, I'm Vias, one of the founding members of Eigenlayer, and yeah, if economic security is a meme, then we need to touch on whether decentralization is a meme, whether crypto user experience is a meme, and I don't mean to just punt the problem at other dimensions, but it's not the only one we got to tackle here, maybe, Togrul.
I would love to tackle other problems as well. I have nothing against it. So I think let's begin. So it seems that restaking protocols focus a lot on DA and finality. Why is that? And also, do you think there are a lot of other use cases that restaking can offer in the future, and potentially like some stuff that is revolutionary?
Maybe I'll start off because we are building EigenDA, and again, very gracious to the Modular Summit guys for letting us come here and talk about EigenDA when obviously, we should be talking about Celestia. But at the same time, there's always a lot of questions on whether DA is just a proof of concept for us, whether we're just dogfooding the protocol, right? What it is, why it matters. And, a few of you are familiar faces from my talk right before Togrul's talk. And, one of the points I had to make was, today we have a lot of DeFi actions in the ecosystem, and for them, security matters a lot, but throughput really doesn't. But as we onboard more and more consumer use cases and social use cases where the actual users are in applications today, the security footprint might go down and the throughput footprint might go up. And so are we building EigenDA for being a core integration into the Eigenlayer protocol? Yes. Are we building it because we believe that infrastructure is required to be able to scale and actually make a difference in onboarding users? Yes. But at the same time, is that the core value prop to Eigenlayer as a totality? Absolutely not, right? Economic security is its own dimension, and I think that's what we're going to get into today. But DA is a way to make a dent in terms of what are the throughput applications that we can eventually onboard. So EigenDA is at 10 megabytes per second today on mainnet across 200 operators. We have a vast operator set that we're actively expanding. We just hit 17 megabytes per second on public mainnet, and we have an internal roadmap to go far beyond that by the end of the year. But and to touch on fast finality, there's a bunch of other services building fast finality across the ecosystem to provide value-add services to rollups, but I don't think it just stops there. I think the point is, let's make sure that these projects are building in the Ethereum ecosystem, and the value is not being distributed to their own tokens and their own ecosystems, but rather is conducive to growing the overall pie, rather than distributing the pie into multiple subsets.
Yeah, the shared security industry, it hasn't been started yet. So it's way, way too early. Like, we don't have any production protocols on shared security beyond Polkadot, I think, and Cosmos mesh security as well. But they're doing it for their own ecosystems. But the main goal for us here is not to limit the space in any way. Because data availability is a really nice angle, but it's like you're expecting something that haven't been created yet to support something that's not useful yet. So you create layered abstractions that it's really hard to evaluate. The goal for I think successful shared security protocols and initiatives is to be as flexible as possible to accommodate. And that's it. Our opinions doesn't actually matter in any way.
What was the original question again?
I can't remember actually.
DA and finality on restaking.
Why do most of the restaking protocols focus on DA finality for now?
Those are the easiest things to build.
That was the right answer. It was quick. Okay. But why does economic security actually matter? And for example, why is EigenLayer or Symbiotic in the position to be the prime provider of that economic security?
Yes, that's a loaded question. Like,
I'm here to
yeah,
ask
yeah,
the
it's
loaded
fine.
question. Sorry.
I'll take the first one. Yeah. Well, economic security matters a lot, and it matters not from the. I think the hype perspective is like a bit overblown, but beyond that, there is an actual use case. People like this is like product 101. People are doing the same stuff over and over and over again, and like they're delaying the go-to-market and safety, like diminishing their safety by a lot. While doing the same stuff, they need to create a foundation, create a token for it, pump up the token, list on exchanges, get yourself like your friends validators or like the brother that like you have that you never talked to like for 5 years, and who's doing like a great job validating some stuff. And yeah, after that, you don't have a stable token. You don't have a good operator set, and like if anyone here like launched a network, you know, like if you fucked up on validators, it's gonna cost you, because like they will be down a lot. They will ask you questions that you don't want to answer ever. They might even like create some conspiracy and like bring your network to the ground. And this is millions upon millions of hours spent inefficiently. Shared security as a really useful primitive can help you with that, because it will be a center of expertise. The platform that you can use to really create a robust framework to onboard hundreds of networks, not just like one-to-one. I talk to you, you become our network. No, like just scoring technical stuff, like tech stack and tokenomics and like risks and everything like that. Yeah, so this is the point like that is really important, and we just need to pay for it. And for that we need scale. And I think the protocol that is going to be eventually successful we'll still have a lot, but like the successful in mass adoption is the protocol that can be as accommodating to networks as possible. You don't want to like create a protocol that you need to like, yeah, you've shortened your go-to-market by like 16 months, and then you spend the 6 to 16 months adapting your protocol to the de-staking, to your network to the de-staking protocol. That wouldn't do it like good. So they need, the networks need a good instrument to onboard themselves and to be like in a pipeline that is efficient. If any protocol will be successful with that, they'll immediately solve like hundreds or not thousands problems per year. Just imagine like it's nothing fancy. You just enable the protocol to test traction. They don't need like $1 billion for that. They need like from the start like 20, 30, 40, but the stable ones. The ones that are not going to do like 10x in a day or like to do 0 in a day. That's the important stuff. You solve that, and yeah, like nobody cares. The protocol start innovating, start iterating like quicker. It's nothing sexy. It's just like infrastructure.
That's actually a good tagline. Nothing sexy, just infrastructure.
I like that a lot. I can't help but agree with pretty much everything Misha just said. I used to think I was an Ethereum maxi, but I realized I was just a coordination maxi, because I think like coordination and innovation are directly tied with each other, and shared security is about how can we coordinate more effectively with the same set of resources. And to the final point that Misha just made, which is like innovation, right? If you wanted to experiment on just one layer of the modular stack, you needed to build your own trust network, you needed to bootstrap your validators, pump your token, build a market cap, and still be susceptible to token debt spirals. And yet now what's possible is you have dramatically reduced the rate of innovation dramatically increase the rate of innovation while reducing the rate of deployment, right? Which is the most important factor, where like people can just focus on what they do best, which is, hey, let's say I know how to build a great consensus protocol that I think is better than Comet BFT maybe. Okay, cool, let me just go work on that rather than trying to figure out how to launch a token and like launch an L1, because like that's incredibly difficult and like incredibly outside of my zone of genius. So if we can just enable people to operate inside their zone of genius more, then economic security and shared security makes sense.
Is there some, because I see it a lot that people are like, oh yeah, just put everything into restaking protocols, like Babylon is gonna go to 100 billion staked, etc. Is there such thing as too much economic security?
Yes, I think like, you probably want to know what, it doesn't, security has a cost, economic security costs money, and like, something like Osmosis, we have like, I don't know, like $1 billion of assets on chain. Like we don't need $10 billion of security. That's like, I'm sorry, actually really, we don't even care about what's on, we shouldn't even count the Osmo value, right? We have like, $300 million of bridged assets on chain, right? So it's like, okay, let's like, we don't need billions of dollars of economic security. We just need like, we should set a security threshold of like, hey, we want this much economic security. Osmo is already providing us like enough economic security, so like maybe we don't need anything else. Now, if we get into a situation where somehow Osmo isn't valuable enough to like provide us the, whatever the target is, let's say it's 50% more than bridged assets, right? Then we can be like, okay, we'll give like a little bit of staking rewards to bring in external security, but like you should like minimize that as much as possible.
I think you're touching on something very important, Sunny, which is like, yes, there is a cost to economic security and you're gonna have to pay out emissions and yield. But the one area where I would disagree with you is it highly depends on the use case. Like I want my bridge to have way more economic security than my like gaming VM, Those are two dramatically different things and with two dramatically different like value propositions. So I want my bridge to be like far more secure because it's managing my assets in transit than I want my gaming VM to be deployed, right?
Yeah, of course. I just mean that like even the bridge has a target economic security, right? Like it
That's
is
right.
possible for a bridge to have too much economic security.
Depends on how much volume is transacting on the bridge, no?
Yes, but based off that volume, you can set a target.
Sure.
Like it,
Yeah, I agree.
Yeah, I don't understand the question. Like, you have a network, they are paying for the whole party, right?
Yeah.
Well, in a stable condition, you can like push points and like create like layer of five different points from 5 different companies. But like beyond that, like networks are paying for their security. And like they select how much security do they need. They can be pushed to get more, and we need to figure out a way for them to again, like the framework of scoring and like understanding. So the ideal way, like, not ideal, but the current thinking on my part is that our protocol will have curators, like really expert people that are going to like going to come to networks and like, yeah, this is the best operator set for you, and we can give you like $1 billion for your economic security. They are going to be the ones who are going to be limited that with networks, because like if the network is great, they're going to be pushing for more. If the network is not so great and they want to limit the risks, that's going to be their problem because they're going to be losing money on that. So like if the incentives are allocated, like they're like built correctly, we will see the push and pull motion between the networks and money managers and operators as well. But it's only be effective if it's on scale. Like we can't limit ourselves to 10 networks per month. That's like way too low.
So it's basically all about aligning the incentives, right?
Yeah,
Okay.
it's not going to be a problem. If your incentives are dysfunctional, yeah, you'll have like protocols that have like 1 TPS with 100 bill of economic security and like 5 users without bots.
Bitcoin.
Well, the question also,
I haven't said that.
One of the questions that you're touching on, Togro, here is like, how much economic security does a new service need, right? And I think there's 2 dimensions to that, and one of them is completely broken today, which is like, oh, if I get more economic security, then I can, theoretically get more alignment from the ecosystem, make my token pump further, like distribute that better, and now my market cap goes up, and value accrual, and all these factors, right? Rather than thinking about the perspective of like, okay, what is the value prop that I'm actually like trying to solve, and how much security does my protocol actually need, are two completely different dimensions. But the problem is, like, you have 3 dimensions of things that you can do with value. You can create value, you can capture value, and you can distribute value. And the reality is most people focus in that order: create, capture, then distribute. But I think, you know, decentralized systems should be operating from the counter approach, which is you create, you distribute, and then you capture. And so what ends up happening is you end up with, sure, a smaller piece, but of a much bigger pie, rather than like a really big piece of a small pie, right? And it's up to you on what you want to have. But, you know, I think if we start implementing rent-seeking systems and decentralized systems, then we've really lost the plot.
There has been a lot of talk in the past year or so about whether or not restaking protocols introduce systemic risks to the underlying base layer. Any thoughts on that?
They might. Yeah, like like are cars dangerous? Some of them have like 1,000 horsepower and no brakes. Some of them are like, I don't know, like Ford Focus. So yeah, like it depends on how you design them. If you want to validate every service using sidecar to Ethereum validators, it's not probably gonna go great. Like we designed a protocol that like I don't see any risk for if the system works as intended. Like they don't usually do, but like it's why? How can you do that? Like yeah, if we have like I don't know how much, like 1 billion, like 100 billion or 200 billion Ethereums staked to 1,000 networks that have like a really loose slashing conditions. Yeah, but Ethereum will survive that. Like it's gonna be slashed. It can be like recovered by I don't know some social mutiny or something. But yeah, I don't see that. Like it was scary when we were like at the early Ethereum days, or like shared security Ethereum days, where people thought that like yeah, we have like validators for Ethereum, but people like, they don't know their stuff. Like Ethereum validators are like calculators by like computing power, maybe like smart ones. But they can't do anything else. Like they can't do ZK co-processing or something like that. It's not a risk. It's impossible. And yeah, so I don't think that's a huge risk, but we need to keep that in mind.
I think, I mean, yes, they have the potential to harm like the incentive of the L1, but I think actually that's probably actually the more exciting thing is the ability to like impact how the L1 works. Like I feel like today most of the restaking protocols have been about like external ABSs, but like what makes restaking actually interesting to me is like the ability to change how the L1 works. So I probably should have mentioned this. Along with Osmosis, I'm also an advisor to Babylon, and like the Bitcoin staking was like something that I worked with David on, like coming up with the idea for. And one of the main reasons I wanted this to exist were, well, 2 reasons. One, it's my way of backdooring proof of stake into Bitcoin one day. But the other is I wanted to use it to build a zero-conf network for Bitcoin, where like you have a way of having Bitcoin miners stake and like attest to that, hey, we will include your transaction in the next thing, so you don't have to wait 10 minutes for your transactions to get integrated, right? And so eventually we can build a fast bridge from Bitcoin. So, but it's like, I think the interesting thing about building a restaking system on Bitcoin and involving the miners in it is that we want to get we want to change the L1 properties.
I would agree with both parties. I think it's very interesting to start experimenting with what features the L1 has. I think the second aspect of AVSs or whatever services, whatever we want to call them, that are building on top of these restaking protocols is rather than experimenting directly on the L1, maybe it becomes too risky, right? We talk about things like don't overload Ethereum consensus. And so we need to offload them to a different ecosystem. We need to test them out. We need to create this playground for them to innovate and experiment. And then we start enshrining these features into the main protocol. And there's like this graduation phase of like, okay, you've reached product market fit, you've reached value accrual to the L1, and so you get enshrined into the protocol. So kind of a hybrid response to both of those, where I think they both matter, but it's, you know, we're really tackling this like stability versus agility trade-off, right? Like you don't want to break the system, so like you don't move too fast, so you like rock the boat too much. But at the same time, like if you don't move fast enough, then like you're just getting further and further away from your like end goal. So how do you tackle that? Yeah.
Another thing that I was thinking about is I've personally been spending a lot of time thinking about objective versus subjective slashing and slashing in general. And what are your opinions? Should restaking protocols limit themselves to objective slashable conditions, or is it fine to introduce some kind of social consensus that does subjective slashing?
I think it's fine to introduce some sort of social consensus and just be upfront with all the validators that this is what we're doing. And like in Osmosis, like I think there was like, hey, if like people are like sandwiching at the transaction layer, I'm like, you know, it's hard to prove that right now, but if like governance, if like 2/3 of validators like, no, this person is clearly like running sandwich attacks and here's all this evidence, like, yeah, we'll slash them.
I mean, I felt like that was a tee-up question for me, Togrul, because, you know, we did announce the intersubjective token and did put out the white paper, and yes, the talk right before yours was about the intersubjective token to some extent. Again, it goes back to, does every single social consensus moment need to happen on the L1 layer? How expensive is that? How much bloat does that put on the ecosystem? If we can agree that that's inefficient, then we need to offload it. And I think that's kind of Sunny's approach as well.
Yeah, I think it's a really narrow way of looking at things. Not offloading, like, it shouldn't be like considered like L1. It might be entirely off chain. Like I got approached a couple of days ago, but like by the person presenting a huge insurance concern that are like that would require a slashing committee on arbitration layer that is going to be like a consortium of lawyer firms and like appraisers and everything like that. As long as it has operators, as long as it's like can benefit from like some clear framework and strong smart contracts, yeah, like flexibility is infinite. Again, we're just starting up. I'm not like 100% sure that I know what intersubjective is. But
I don't think anybody knows.
Yeah, like this is like 3 hours of my life. I'm never getting back. Right. Yeah, but like even the Augur ones, like I think that's the inspiration for intersubjectivity. The prediction market ones, they have their own place. It's not going to be for consensus of L1, probably for like at least the conventional one. But yeah, both of them they need to be. You just need to like you never should use one size fits all. As long as like you have consent from like 3 participants, operator, staker, and network, it should be fine. Like all of these guys are doing some risk analysis. Otherwise, they're going to lose their money, and it's going to be fine.
If you believe that you shouldn't do one size fits all, then that's also why we need to go and try and build something different, which is the intersubjective design as well, right? Like those two things are contradictory to some extent because like we're just making an attempt at saying, hey, here are these problems, and maybe the example outside of prediction markets that to me makes the most sense is like, okay, what happens with all these decentralized AI projects? If you believe that some of them are a meme, that's fine, but if you believe that some of them actually matter, how do you identify whether somebody introduced a rogue variable to the data model? How do you identify that the variable was rogue, right? That's a highly subjective question, but at some point we need to make that objective and slash them if we're gonna build these decentralized AI systems. So that's a moment of intersubjectivity right there. And if we don't come up with a way to try and tackle that, then we're just going to let the problems persist and let them just manifest themselves in the ecosystem. So I agree with you that, like, to some extent, one size does not fit all, and we need to come up with custom solutions. But at the same time, like, Ethereum itself just moved from proof of work to proof of stake a few years ago. We're all just trying to attempt new systems.
Okay, so like with the intersubjectivity stuff, like this works like until you have if everything is in like a small internal closed system, right? As soon as like this is sort of the idea of like, hey, okay, if this chain like disagrees, like okay, we'll split the chain in half, right? But that as soon as you have any bridged assets or anything, it all like so I don't know, like what is actually like the use cases of intersubjectivity that doesn't rely on like some external thing, like even for like a prediction market case, right? It's like yes, it splits Augur in half, but it like it doesn't matter. There's still some USDC unless all the like bets are being made in Augur, and it's like that's not going to happen, right? People want to bet in USDC.
Totally agree, but right now, if that fork was to happen, it would happen directly on the L1, right? So not only would Augur be split and the USDC would be split, but as well, we would end up with like essentially a fork on the L1 chain of people choosing one branch saying, hey, this was the correct state transition, and hey, this was the other branch saying this is the incorrect state transition. And if we want that to happen on the L1, well, either we need to say we're comfortable accepting the cost and we're comfortable accepting social consensus happening on there, which is highly expensive, or we find ways to do it either on other systems, which for us is like restaked ETH, so we have a subset that we're working with, or like Misha mentioned, off-chain. But then the question becomes, who is doing the computation off-chain? How do you verify off-chain and bring it to on-chain? Open questions there, to be fully transparent. But again, very much something that's still in design and about to go into effect, and we'll have more and more docs on this explaining some of these use cases and actual like integrations as we come forth with the execution of the design.
I have a question for you, VS, specifically, and you guys can weigh in later. Was there any technical reason for limiting the protocol, at least for now, to ETH and certain versions of staked ETH only? Or is it purely a business decision?
That's a great question, actually. Have we considered the idea of doing it on other ecosystems? Yes. Do we think, is it a business decision or is it an operational decision? Because like the amount of time that it takes to build these protocols is not trivial. And so like, I don't think that we would be able to execute on multiple ecosystems simultaneously, quite frankly. It takes a 70, 80 person team on labs, plus a foundation team, plus the like man hours of multiple people over years to do it on one ecosystem, much less multiple. So if you want to classify that as a business decision, for sure, but also like a strategic one and also a like time-driven execution one, like a focus theory problem. Like you can't focus on multiple ecosystems at the same time. It just becomes very fragmented and very difficult. Who do you have your smart contract engineers like work on? Like we would need to scale to a such massive team in order to just have contract engineers on Solana, on Ethereum, on each of these ecosystems. So that's kind of the problem also.
But I also meant in general, like within ETH, accepting tokens that are non-ETH token, not ETH denominated tokens, like maybe even some random meme coins. I don't know how far you want to push this field. That's what I meant.
Yeah, as in what can be deposited into these restaking protocols? Yeah, that's an interesting one, right? For us, it's about the ability that Ethereum provides in terms of native slashing on the L1, right? And when you introduce meme coins, it's not clear that you would be able to identify ways to slash those systems.
Can you just send to the zero address?
Sorry?
You can just send to the zero address, no?
Yeah. No, that's fair. But at the same time, like, is there enough economic security in those systems to be able to be viable where like the stability versus agility problem? Like, is there enough stability on those meme coins for things to be built on top of and for you to like undermine your entire protocol on these, you know, highly unstable systems? Whereas like ETH is a far more stable asset.
Yeah, we talked about like flexibility and the vision that needs to be as wide as possible. Yeah, like meme coins won't be interesting for people for a long time, but like restaking is again restaking is not something a lot of people understand correctly, I think. it's not just like we have a stable asset and we use a lot of networks to secure it with this asset. For bigger protocols, restaking works completely differently. Like Uniswap, when they're going to be building their like off-chain parts, won't expect other networks to use the Uni token for their security. But like the big protocols can use their own token to restake multiple off-chain parts. DeFi is getting really complicated. And they need that token to align every off-chain part to be secured within the ecosystem. So it's not that like, yeah, we don't have enough security in Ethereum, we need to add some like other tokens. It's not about that. It's just the bigger protocols that the tier ones that want to use restaking because it's useful, not because it's hyped or market-oriented. They don't want to use Ethereum. Why would they? They have billions of circulating supply of their own token. They want to create additional utility for that while securing the network. So like, it's not about like just like ETH or not ETH. It's about giving the industry as wide a chance of success as possible.
So in your vision in the future, we'll see like a basket of different assets securing different...
We already have them.
Yeah.
Yeah, like the INA case, the FINA case is like the demonstrator case. They want to create an interop with their governance token and the stable coin as a base. And then after they create interop, they will, like, restaking is actually vertical for these protocols. You have a governance layer that is like zero risk of slashing, everyone can join. The other layer is like, you have an app chain with like sequencing or something like that. You can get slashed. The risk is like really minimal, but you can get slashed. It's used for attestations, it's used for scheduling. But if you have scheduling, you have MEV, and you might want to stake that as well. And if you have like scheduling, your confirmations are not the same as like one entity SQL database. So you need probably pre-confirmations or some like finality gadgets or something. You can stake there as well. And then you need oracles, market makers. In the FINA case, they use exchanges, so they need a lot of off-chain workers that do stuff for them. And you can smoosh it together and call it staking. But you lose a lot of people because the risk profiles for each activity are completely different. Like, institutions would never like go to MEV, the big ones. But again, they can use voting and scheduling or something like that. So when you do each layer as opt-in, what's that called? Restaking, cross-staking, shared security.
Yeah. Can I ask a question? That I think kind of goes more at the heart of what I thought maybe the panel would be about is, you know, I feel like economic security definitely matters in a world of like actual proof of stake. Where like everyone is staking their own tokens, right? And I think that's actually much more similar to what proof of work actually is, right? Because every miner is actually spending their own hash rate. In proof of stake, in the reality, we've just seen that like the operators are not actually staking their own tokens anymore, right? It's all delegation basically for the most part. And so at that point, everything is just reputation based anyways. So why are we even bothering with this proof of stake thing at all, right? Like, I think the real question is like, does proof of stake matter? Should we have just actually switch to some more like POA kind of system instead? And does the economic security behind each operator actually matter?
Who's going to be gating this POA?
Some initial set, right? Like, wait, why? Every token starts with some initial. Every proof of stake system started with some initial distribution, right? So you just start any POA system with some initial distribution, and then that initial distribution votes on the change, right? Like you can say, hey, okay, I started with these 20 initial entities, and now we vote to change those, add or remove entities.
Yeah, in US, it's the same. If you like in US, you take electoral college, you get to the first election, and then stop asking people. Like you already have your delegates, right? why would you need people after that? No, we need in a lot of cases. I agree with you completely. In some cases, like the reputation already superseded the staking as an actual like source of stability and security. But like I still like in mainstream cases, I think the stake is really important by gating the operator list still. in the systems where like there are hundreds of thousands of participants. Otherwise, it's super easy to get to oligarchy.
My question is to you, Sunny. Isn't it better to just have DPoS, which is permissionless, but is also kind of POA because you delegate to the people who have the best reputation, etc.?
Yeah, but like, I don't understand why I actually have to like stake on them. I can maybe have it so like, oh, my token holders can vote to add in people, but like, I don't know. Why not do the DPoS, right? It just opens yourself up to attack vectors that can be, if you don't have enough economic security, you can be exploited by it, right? So let's just like close those attack vectors by not even being like fully permissionless, right? Obviously, this depends on the application, right? I'm just saying that in practice, most proof of stake systems have, like, unless you're operating with like anonymous, like enforcing anonymous validators, which, like, that I think that would be interesting, right? Like some chains have actually, like Thorchain did something in that realm, right, where they like tried to enforce all the validators be like anonymous, and now you could do something where like, oh, okay, every validator is staked, and use some intersubjective slashing to say that, hey, if someone can dox the identity of a validator, we'll slash them or at least kick them out of the validator. That's interesting, right? But that's not what most chains are doing, most proof of stake systems are doing today. Definitely not what like most AVSs and stuff are doing today. So like, why are we bothering with that?
But I would argue that this system is not very scalable because any proof of stake system at some point degrades to delegate a proof of stake. It's just not sustainable for everyone to run their own.
Exactly.
So the approach that you mentioned with anonymity and stuff, I don't think it works on like the scale of Ethereum, for example. You kind of need delegation, and I think it was a mistake for Ethereum not to enshrine delegation into the protocol because it introduced a lot of like third-party risks, etc.
Yeah, look, I think there is like a case for like, maybe the L1 to have it. I'm just talking like most applications, right? Like most things I see like trying to be AVSs right now, those are the ones I don't think actually need there. Like, or would probably be better off as like POA system. But like, sometimes I wonder if like Osmosis should just switch to like a POA system rather than proof of stake.
But isn't the argument there that slashing kind of adds additional security that POA wouldn't have? The economic security on top of that?
Most of the security right now is like coming, like all the top validators of Osmosis, but also of Ethereum, but also they're all like the same entities with a lot of reputation at stake. And I think their reputation is more like valuable than actually like the stake amount that's slashable.
I would agree that the reputation is valuable initially, but my question is more that because if you have slashing, you can always fall back to it. Whereas if there's no slashing and you have POA, essentially, if the reputation is not enough, you're essentially screwed.
There's no economic cost to misbehavior, right?
There is economic cost, you can argue, if you can get sued, etc. But it's just like, it's a very long and like arduous process. It's in slashing, it's like basically, especially with objective slashing, it's one condition and that's it. You get slashed and that's it.
Yeah, I mean, I think it's like, it depends on the type of fault, right? And how much coordination there is to do an attack, right? Like, if it only takes one entity to do an attack, I actually think that their economic security matters more, right? But if it takes like a coordination of like a larger set of entities, I think like the coordination cost is like exponential, and the chance of like someone ratting you out or like, it is just so high that I think that's what actually like, I think what stops like, we always say like, oh, what if Coinbase and Lido just colluded to attack Ethereum? And I was like, there's massive reputational like costs to them doing that kind of thing.
Yeah, I guess.
And none of the assets are there. Once again, this goes back to the point that none of the assets are actually theirs anyway. So it's not their economic cost to stop them from misbehaving. It's their reputation that's stopping them from misbehaving.
Yeah, I guess there is a point there, yeah.
Cost as well.
But not the operator's cost, right? That's the point.
Operator's cost.
But it's not the economic stake that's slashable. It's not their stake.
Yeah, it's a time value of future cash inflows for operator business.
Exactly. So that you don't actually need the economic stake there, right? That's all like.
Then you're paying validators too much.
Okay, so that doesn't answer the question.
Yeah,
but
like
the stake doesn't matter then.
the amount of risk, it influences the amount of capital inflows. Like if you decrease the amount of economic risk, you decrease the amount of economic inflows to a validator business.
So can you explain that?
The more you're risking, the more money you can get for this, for the operation of a lot of stake. If you decrease the risk model for stake, you can like basically, yeah, the amount of money the businesses of validators can extract will decrease as well. This is like basic theory, game theory.
Is that a good thing?
No. You want to pay your operators enough. That's how it works. Do you know, like, DevOps are really expensive.
Okay, so you're saying that by making people give money to others, right, you're increasing the money that they can earn off of it? Why? What are they doing with it? Like,
they're risking it.
They're risking it.
Well, I think
Okay, but
operators that are validating for services that are naturally more risky should be compensated for the additional risk that they're taking on, right? Is that your point, Misha, to some extent?
One of it, yeah. Like, there is a lot of research on like proof of governance, where basically the main risk for you is to get kicked out of the list just, and it makes a lot of sense. But I think in open-ended systems that require thousands, if not hundreds of thousands of operators, you still need this base of risk, like billions of risk, because like that brings like actual good risk managers that can be paid by it, because like the base of the risk is quite big. If it's like only $100,000 this operator gets in 1 month, the talent that you can acquire into validator business will be not as great as it is right now.
So I agree if it's 100,000 operators, right? That's more what like Bitcoin mining is. That's not what any actual proof of stake system is today.
Unfortunately, we've run out of time. I really enjoyed this conversation. I was trying to intervene for the last 2 minutes, but I was like, this is too interesting. I can't intervene. Yeah, unfortunately, we've run out of time, but thank you for coming. It was a great conversation, and thank you all for listening. And give them a round of applause,
Another
please.
round of applause, please. Thank you.
Thank you.
And we're switching out from the panel, so just 30 seconds here, but Misha will ask you to stay up for the next thing. And also, if any Bitcoiners are around, we learned that Sunny created Babylon with Professor C to get proof of stake in there. So
It'll happen next 30 years.
yeah. I'm with you on most of this stuff. All right, yeah, I'll see you soon. All right, Misha, whenever you're ready.
Yeah, let's start early. Slides are gonna be semi-related to the point of the talk, so you don't like need to look at them, but it might help. Shared security. We talked about it a lot for the last like couple of hours, I think. But the goal is, as I told you on the panel, is to reduce the amount of wasted time and effort, and to optimize for the innovation, to make it safer and to make it more efficient. The same example, like the example that I use is usually you can start faster. You can get a stake. You can get stake of stable tokens. You can use it for your economic security. You can get the best operator set for your use case, because like for coprocessors it's one thing, for oracles is the other. For L1s or L2s, completely different as well. Yeah, and you get it in a month, hopefully, or in a week, not in 16 months or like 20 months, something like that. And after that, you can phase in your token. You might want to switch to, like not switch, but phase in the token and use your own token, if you ever have one, to create the basis for your economic security as well. So like just imagine every protocol, every network, when it decentralizes, it's 10 months earlier, and they can start testing their traction. So like, how do you actually deliver that? Because like, yeah, restaking is easy, right? You just pump your expectations of the market and you get billions of dollars of stake. Okay, yeah, that can be done. But like, you need to pay for it. That's the hard part, because you can get 20 billion, 40 billion, 50 billion, and like, who would pay for that? You need an actual inflow of fees for the networks you've helped. And for that, you need to onboard a lot of them. The good ones, the bad ones, the middle ones. And how do you onboard a lot? You need a sophisticated framework. Better competing frameworks that are going to be optimizing each other, shit-talking each other, and like really having a great time competing for the networks. And like, again, who'll pay for that? Who will actually pay for that? The networks, right? But how do you get the networks? Like, we need hundreds, if not thousands of networks, and the good ones as well, like every type of them. Because like, if you only do rollups, you're going to be great for launching rollups. If you only do oracles, you're going to be great for launching oracles. Same goes over and over again. Yeah, how do you get the money? That's like to pay for the party. You can like pump up the points or tokens or something like that, but that's not sustainable. Yeah, first, you need for your contracts to be immutable, because like if they're not, there's this like, we've been there before. You pump up the protocol, you give them power, they're your best friends and they're neutral, and then they change. And they try to utilize their position as a market leader to make networks do stuff for them, right? It might be angel investing, it might be like other stuff. There's a lot of things to be done. This is like for tier 2 and tier 3. For tier 1, yeah, they're not gonna use you, like at all. Because like if you have a multi-sig or you have like even the DAO, it's a risk for them. They have like big security teams that are doing the analysis of risks. And if they have misaligned DAO, they don't control, upgrading their contracts that control their consensus, yeah, that'll never pass. So you need to be immutable. It's 10 times harder, like if you develop the contracts, immutable contracts ever, it's 10 times as hard as like developing the upgradable ones, because they can't be really complicated. Otherwise, you're hardwiring the behavior like while creating an industry that doesn't make any sense. You're like limiting yourself a lot. So they need to be flexible, they need to be really strong, but they need to create an abstraction layer strong enough and flexible enough so you can like accommodate cases that come to you after that, and you don't upgrade to V2 between like in like 2 months. So this is the first important part. Otherwise, you won't get like all of the networks. You'll get only the portion of it. So we are already like filtering. The second one, yeah. Yeah, like I talked about that. You need to enable people to do what they want. So if they don't want to use Ethereum, like again, like case Uniswap, Arbitrum, Optimism, Maker, something like that. Ethena. If they don't want to use Ethereum, they need to have a point. They need to have ability to do so. They already have their own like good teams, developer teams working on that. They can create a restaking protocol for themselves. Yeah, for their own token, it's going to be fine. You need to create, but again, like they're not going to be creating a framework, and that's what we need. So we need to accommodate them, and we need to make this protocol really useful for them and for exactly their use case. Okay, so you need any token. Our protocol like has a collateral abstraction that basically enables you to use any token on almost any chain. You don't even have to transport it to Ethereum. So the alignment opportunities are infinite. You just need to have it somewhere and being able to reliably prove that you have these assets there and that it can be slashed within the slashable window. If you can prove that, great. And networks are okay accepting that. We accept that as well. So yeah, I touched on this point like a few minutes ago, but yeah, you need to be neutral. Like if you want to be big, if you want to get to the point where you actually have an inflow of networks significant enough for somebody to build competing frameworks of scoring and onboarding, and to pay for that as well. Like you need a lot of networks, and for that you need to be neutral. You can't ever show the networks that you might be a competitor. That's the important part. If they ever have like somewhere in their mind that at some point in the future, you can launch your own rollup, you can launch your own Oracle, you can launch your own data availability solution, that's gonna be competing with their actual clients. Yeah, why would they help you? Why would they use you? Because like at some point, you can be Amazon Basics. You like something, you copy it, you brand it on your like site. And it's bad. Because like again, tier ones are not gonna launch on you. They don't trust you when you do that. Tier twos and tier threes are apprehensive. You need to avoid that at all costs. You need to be as neutral as possible, as unopinionated as possible. Your role is infrastructure. You don't have opinion. You do what you're told, and you do it in a reliable manner. Road, like if you get in your car and use the road won't ask you like, your makeup looks like something like have you like, are you okay? No, you just like go on the road. Everything's great. If the road is great, yeah. So yeah, network builders need flexibility. Yeah, that's the important part. You can create a really complex systems like intersubjective stuff and like prediction markets, or like some committee that's centralized. It doesn't matter. One is like super vague. The other one is like really stupid and basic. It doesn't matter. You need to have all of them. Because otherwise, what? You don't get money. Networks don't, like most of the networks, they don't need to rewrite their own system and they reverse their plans and they redevelop the slashing to accommodate the two solutions you've presented. They need to be able to use any of them. Quorum, fraud-proof based, ZK based, I don't know, like even the random ones, yeah, like for some degen stuff. Yeah, you just need to be able to enforce that. Yeah, so like flexibility. We have multiple protocols working on resolvers, which is like the arbitration layer, resolvers for slashing, because we already have that. Like we use fraud proofs to get out of the layer 2s. We have ZK proofs, we have committee proofs. We had oracles for a really long time with 4 different quorum systems and everything like that. We just incorporate that. Yeah. Alignment, yeah. That's the important part. We don't I've talked about that, so I'm going to be talking about something else. We don't need to be limiting the protocols in any way. Restaking and shared security beyond the actual UX and onboarding is a really simple primitive. We have 3 participants, like if we simplify, 3 participants. One is operator, one is staker, and one is network. Network, staker, and an operator, they come to the agreement. Network received stake with the operator that they select, that opt-in, and with slashable conditions that they select. When the agreement is reached, the role of the restaking protocol is to make sure it's followed. Everyone, like if push comes to shoves, people needs to get slashed. If operators or stakers want to get out, they'll wait for a slashable window to pass. That's it. You don't have to like make them do stuff. But when the consent is reached, yeah, they'll have to follow it. The alignment I've talked about in the previous talk, but like I'll reiterate. Not all of the DeFi is getting really complicated. That's the whole point. They have off-chain modules, they have runners, they have like keepers, networks, oracles, interop, some like other layers. For those big players that need that, they will use their own token. Because like doesn't make sense. Like I don't know, like Uni has like 8 or even more, like $10 billion in their own token circulating supply. They don't need Ethereum for that. They will be using their token to align. And if we talk about ecosystems where there's L3, multiple networks, like ecosystems of rollups and everything like that, they want to use restaking as an alignment mechanism as well. Not just pure, like I don't care what it is, it's like stable, it's fine for me. They're not going to be using Bitcoin. And like, why would they? But yeah, like some Bitcoins roll up might. And again, we can help with that because we are not limiting collateral to be on Ethereum chain or even the AVM chain. Yeah, basically that's it. That's how you get money, hopefully. That's how you get money to pay for all the experts, all the entities that we'll need to solve the problem of native launches. Okay, yeah, questions?
Yeah, great. We have time for questions?
What's the plan of next like 100 networks, where AVSs? Where will like onboard them? So what will be the spectrum of next networks from your point of view?
Spectrum?
You will have 100 of them, and will be like AI networking, like maybe other chains. What will be the spectrum of these next 100 networks from your point of view?
Just the ones that are going to be launching soon, like their schedule. We have FHE networks, we have rollups, we have a couple of data availability. Yeah, all of them. That's the whole point. We don't want a piece of it. We want all of it. That's how we designed our protocol. Like you should like that's the whole point. If we are successful, you should never have a need to build your own, because it's permissionless, it's without fees. We don't control it in any way. We don't make you do anything that you don't want to do. Yeah, like another like really interesting point I get a lot. Like if you start with the restaking protocol and shared security protocol, and your token is getting strong, you're getting a lot of traction, you will leave, right? Why should you pay for something if you're only using your own token? First, the example that I showed you, the alignment part, once you grow, and for our protocol, you won't ever need to leave. Why would you spend, like I'll spend like probably close to $1 million just for audits alone. Why would you ever leave? You can write it yourself, even if you're like super big, but you'll have to like do a lot of job. And you like the idea here is to create a protocol where you don't ever have an incentive to leave. We can't change anything in this current version. We can't add fees. There is no DAO to control you. Yeah.
All right, great. Thank you very much. Can we get a round of applause for Misha? And we are going back into panel mode, so just give us 30 seconds. And thank you very much. Oh, sorry, give the clicker. How you guys doing? Woo! Last panel of Modular Summit. Actually, I don't know what's going on the other stages. This is a good one, though. Should be spicy. All right, Mike, are you in the room? No. You can take a seat if you want. All right. Oh, look who decided to show up. No, it's okay. We're running a little early. Nick's not even in here.
Well, at least I'm here.
Oh, do you have slides? Oh.
What's up, Mustafa?
The ceiling. Sorry, that's a bad joke. But I think you have to like drink a bunch of shots or something, according to this.
Is that what you need in order to get through a roast?
I mean, that's what I've been told. But I'm British. I'd rather drink tea. But
It's not going to be that bad. You won't need the tequila. But if you insist.
Oh, we have some. Yeah, we've got some. It might get spicy. It might get spicy. We're waiting for Nick and the guest of honor here, Mert. How's the conference been for you guys? Eric, is it bright in here for you, or what's going on with the
It is
sunglasses?
bright. The lights are like straight in my face.
That's actually a pretty good point. Yeah, that's very fair. What have the highlights been before we get into the roasting? Give us the highlights before we go to the lowlights.
Right now, it's the Prada glasses for me, honestly.
All right, that's the fashion highlight. Yeah, we'll give you that. Moose, what about you?
well, I think this is going to be the highlight, and then I think I heard there's going to be Algo Rave tonight, and I think that's also going to be a highlight.
Weren't there supposed to be more beers?
I was told that there were going to be beers. Yeah, but we've
honestly
got.
shop
I think that's Aperol that we've got.
It's probably
there.
on the way.
Yeah, it's on the way.
We are waiting for Mert, but Solana is having an outage at the moment, so.
There's a liveness issue with Mert. Yeah, his presence. How's everyone in the audience feeling? What's the energy? What's the vibes like out there? All right, that was like a 6 out of 10 at best. Give me more energy. I want to see like this is the coup de grace here. Give me energy. Woo! All right, that was very good. That was very good.
So, Mike, are we gonna do shots?
I think we're gonna do shots. Yeah, I've actually never done an Aperol shot. Has anyone done shots of Aperol before? I actually don't know how I feel about that, but we can. Why don't we wait till the roast flow a little bit, and then we can pour some of the alcohol.
Is there any alcohol in it, or just?
Yeah.
Oh, there's alcohol. Oh,
Yeah,
okay.
there's
So
alcohol.
I guess he mixed Aperol.
Yeah. All right. Beautiful. All right. While we're waiting for Mert here, while we're dealing with his liveness issue, I'm sure everyone here.
Apparently he's walking in
Okay. Beautiful.
just now. Well,
All right.
very soon.
All right, why don't we, here, I'm going to give everyone a little bit of an update on the format here, because this is not like a regular panel. This is a fun panel. This is a roast, all right? Everyone said very nice things about Modular so far today, but we're going to say some slightly not nice things, and then Mustafa, Nick, you're going to defend Modular and the idea. In terms of rules, so we're going to go through a couple of slides here, where one of our panelists has maybe not said such nice things about Modular on Twitter. We're going to point out some of the flaws, and then we're going to banter back and forth.
I'm sure Eric has also said some not nice things about modular. Right, Eric?
I'm an investor in Celestia. Why would I say something bad about Celestia? Come on.
True story, I actually looked and I could not find one bad thing that Eric had said about modular.
That is rare.
Yeah.
Well, I have said one bad thing. I mean, you know this sort of mean like you had one job.
Yeah.
So if you take a data availability layer, what is the one job that a data availability layer should do? What is the one job that you have?
I know where you're going with this.
Data
and you're wrong.
availability.
What is the one job that you have?
To publish data.
To make data available.
See, I knew you were going. I knew where you were going with this. That's why I want to rename data availability to data publication.
Okay, so you want to rename in order
Yeah.
to not get owned by my argument. You're going to rename the whole thing?
No, because so that people like you don't get confused.
They are confused because you confused them by calling it the data availability
Well,
layer.
it wasn't me. It was actually Vitalik that called it that.
Guys, is
But-
this the first time at a crypto conference that we've ever debated about semantics? Has that ever happened before?
Thank you.
Oh, thank you. All right, excellent.
Here we go.
Here we go. Now the roast can start.
Now we're talking.
Holy, okay.
All right, now finish these. We'll get you another one.
All right, guys. We're going to start in here with some. Well, actually, can we just do a super quick round of introductions here in the rare instance that there's someone in the audience that doesn't know? Nick, can I call on you here, Mr. Modular himself with the modular mullet, to give us the first introduction?
I'm Nick White. I'm the COO at Celestia Labs.
I'm Eric Wall, and yeah, I'm an investor in Celestia. And yeah.
That's called a disclosure, by the way.
And yeah, I'm the co-founder of Taproot Wizards, which were responsible for the largest spam attack on Bitcoin in its history. And we're running out of space to spam, so we need more data that we can spam. So that's why I like the modular space.
I'm also the co-founder and CEO of Celestia Labs.
I'm Mert. I am the chief shitposter at Solana.
That is an apt resume, because we're going to see some of your resume's best work, Mr. Chief Shitposter.
Oh, God.
And you're got to do the lion's effort here of the criticisms of modular, and then some of these guys are going to defend it here. And this is the same roast, the same rules as the Tom Brady roast. So everything is on the table except no jokes about Rubbercraft getting hand jobs. That is the only thing that we cannot talk about on this stage. All right, that was a little bit of a whiff. All right, we're going to get right into it here. All right.
Oh, fuck.
L2s are a scam. EVM L2s are just a scam invented by Big Etherscan to sell you more block explorers.
Do they charge? Do they charge for deploying more explorers?
They certainly do.
They charge.
Like
yeah.
millions of dollars every year.
Millions,
something like
yeah, per L2. But
that's why Block Scout exists.
Yeah, that's why Richard Hart's Pulse chain does not have an Etherscan explorer. They have Block Scout.
Is that true?
That is true.
Didn't Richard Hart make a lot of money?
But he's not using that money to his ecosystem.
He's buying Louis Vuitton.
That is his money now.
All right, guys.
I'm not joking.
It went to the G-Wagon and the Louis Vuitton.
Yeah, pretty much.
All right, that's one use case for Hex.
I mean, I'll be impressed if a block explorer invented L2s and rollups and fraud proof and validity proof. So if that's true, I'm not even mad.
All right, Mert, say some words about L2s here. What are your thoughts on L2s?
I love them. They're the best thing that's ever happened, and it's the only way crypto can go forward. Okay, the context behind that tweet is obviously a shitpost. Actually, I was cross-posting to Farcaster, and I was like, I wonder where they will resonate more with this. And actually, the Farcaster people liked it, so.
Yeah, they're the ones paying for Etherscan.
But no, I mean, maybe, okay, let's get serious. We're not that serious, but the context was that, okay, maybe there's more apps, or there's more chains than apps in crypto. And so, okay, what's a fun way to kind of frame this? And that was it.
You're kidding me.
Is Etherscan an app?
It's not, no. Oh, well, actually, is it? Okay, are Block Explorers apps? No. Yes, no? Okay, let's do a vote. Yes? Okay, we have 4 people, I think. No? Oh wow. Okay. So.
All right.
Mert, I think you don't have to apologize. I think this tweet is 100% true. I see no lies there. No lies detected.
Yeah, exactly.
So what do we think? You know, Mert, when we go into this future, I saw many talks that there are going to be 1 million L2s or thousands of L2s in the future. Are these things great? Is it a good way for us to be scaling the industry, or should we be thinking in a more integrated way? What do you think?
Well, I mean, you know, my fundamental problem has been, are we actually solving any problems with these new chains, or are we kind of just throwing them out there so we can raise a round and then upsell it by another VC in the next round, and then kind of just keep doing that circle jerk and have these tokens that don't really do anything for the chains? Or are we, you know, can we actually solve some real problems that exist? And I mean, you can absolutely solve problems with L2s, right? For example, Solana got congested. That's why I was late, actually. It sucks. Like, you literally could not land a transaction. I couldn't, you know, do extremely valuable things like, you know, ape shitcoins with hats and stuff. And then, you know, people were complaining. Actually, Nick commented on one from Vib, who is the founder of Drip, who they kind of just spam NFTs on chain. And maybe the problem with, or one of the problems with an integrated chain is, like, you have to share that block space with other people who kind of shit in the public pool. But with like sovereign rollups, which I don't know if you have a tweet, but I've tweeted, I was like, if I weren't working on Solana, I'd probably do like sovereign rollups or something, because I hate other people, so I'd rather just own the block space myself. And so that's like a good use case.
Mustafa and Nick, what do you guys think about that? Are you guys fans of sovereign rollups? You like that idea?
I mean, I coined the term sovereign rollup, and I kind of regret doing so, because no one's actually read my blog post to see how I define the word sovereign rollup, and everyone has their own definition of sovereign rollup. And I have to explain to them that if you read my original blog post, the distinction between a sovereign and non-sovereign rollup is not a technical distinction. It's a social distinction. Like, it's a very minor social distinction that basically says in a sovereign rollup, it's the community that decides the canonical fork choice rule. And that could be the case for any rollup. And that's the OP stack people have argued that optimism is a sovereign rollup. And if they say so, it is. You know, so it's not really, so I kind of avoid saying that now because everyone means something different by it. But I think the main point of, I guess like the main point of coining that term is basically, like from the Celestia's perspective, we don't see rollups as a solution just to scale some layer one. Like, we see rollups as cool things in their own right. And if you look at today, like, why are people deploying all these rollups? At least in the past year, developers aren't deploying rollups because they want to scale Ethereum. They're deploying rollups because it's a cool way to deploy stuff. You know, like, we see all these application-specific rollups. Developers don't care about scaling in layer one or Ethereum. They care about developing an application in the best way possible.
What are some of those applications?
These applications, are they in the room with us now?
Well, this is my main criticism. Like, look at Mustafa's shirt. It says, build whatever. I would like challenge that and say, like, come up with one thing that's worth building. Like, the reason that this whole tagline, like, build whatever, exists is because you thought about it, like, okay, what are some cool things to build? I don't fucking know. Build whatever, just build something. Yeah. But it's already built, right? So I saw this picture of you the other day, like you were smoking a hookah, and like there was complete, like your eyes were completely blank, and you had this shirt on which said like build whatever. Like you're like reached the maximum nihilism of the roll-up centric roadmap. You don't know what people are supposed to build, so you're just like build whatever. It's the worst tagline I've heard in my entire life. Come up with one good thing to build, and tell people to build it.
I mean, it's cooler than you know. The reason why we call it build whatever is because it's like whatever, you know. It's like, because you could have some cringy corporate tagline like build, you know, like what's Avalanche?
But your tagline is basically like, I've given up. I don't know what you're supposed to build with this shit. We have so much block space. I don't know. Can someone just make use of this, please?
Well, isn't it crypto dick butts? That's what we need, right? Just fill the block space.
That's a cool thing. that's a cool thing.
Yeah, maybe you should hire us, and we'll come and we'll build some dick butts on your chain.
All right. There is simply nothing dumber than the monolithic versus modular debate right now. So we've probably seen many monolithic versus modular panels over the years. Mert, why is this not the correct framing of this question?
Okay.
I did not tell Mert what tweets I was going to be pulling for this.
Yeah. What's the question?
Why is this the dumbest thing that we could be talking about right now?
Okay. Well, this is a roast, but I'll get maybe a bit more serious. The reason it's dumb is because actually what we just talked about, which is that the only thing that fundamentally matters is you need to build something that people want. And it doesn't matter, how your cloud infrastructure looks or what it's called or, the name of your database and all this shit. All that matters is like people want some block space, they want to access it, they want to write to it, they want to read from it. That's it. Now, saying that, let's say you build on Solana and they're like, oh no, that's a sin. How dare you do this? How dare you go into the high priest of the church? Build modular instead. It's like, okay, but first of all, the person's actually building something, which is a start, which doesn't happen that often. So let them build first, and then if there's something that fundamentally doesn't work or scale about it, then maybe they can kind of consider doing something else. But fundamentally, you kind of need to take that first step, which just doesn't happen. And maybe on a more technical level, I feel like the modular stuff has been called modular, but it's actually more like a distributed monolith if you actually play it out a bit more, which is to say that the parts are actually kind of tightly coupled, and you can't actually swap them out. Like if you have like an EVM thing or something and you want to change the execution environment, that's not an easy lift. I don't even know how the SVM works that well. And then people will say, okay, like Solana is monolithic, whatever. But then we just took a vote today, actually, and everybody agreed that Solana was modular. But nothing changed about the chain in that time since we called it monolithic at all. People just kind of deploy shit, usually it breaks the chain, and then totally says, no, it's not broken, whatever. And then Liam from Firedance will be like, no, it is broken. And then they'll just argue on Twitter for like 5 days. And it's like, okay, it doesn't work. And then we just iterate based on that. But fundamentally, nothing has actually changed about the architecture here. I always say that like integrated is just modular but enshrined to the core layer. And I just fundamentally think it doesn't matter the name of your cloud architecture. What matters is you work backwards from the problem, and some certain apps benefit more from shared state. So like price discovery, DeFi, et cetera. And some of them, like a game, for example, they don't give a shit about dog with hat, right? They don't need to access that liquidity. They can just go do whatever in their rollup.
What do you guys think about this? What are the advantages of building in a modular way?
I mean, the kind of original purpose of this monolithic versus modular debate is not even just purely because of the technical architecture, but because every cycle we see these new layer ones. Like in the first cycle we did Ethereum, the next cycle we had Tron, Cardano, and then this previous cycle had Solana and Avalanche. This cycle we have Aptos and Sui. So it's like every cycle, like there's these new layer ones that do an incremental improvement over the previous layer ones, and each layer one tries to replicate the entire ecosystem of an entire layer one. Like every layer one has some DEX, every layer one has some NFT app. And maybe Solana is the end game. I don't know, it could be. But the point of this was like, well, why don't we try to make it so that instead of having a negative sum ecosystem where everyone's fighting with this tribal layer ones trying to compete with each other, why don't you make it that it's possible to make incremental improvements without doing that? And yeah, it's not perfect. Like there is a criticism that there is too much modular infrastructure, so there is, and Solana does have an app culture, so that is kind of like a good thing. But who knows if Solana is the final layer one? Everyone thinks that they're the final layer one. So that's the kind of point of it. And the fact that there are L2s on Solana kind of proves that there is no final layer one.
Well, like, there used to be more in L1s and whatnot, like incremental. I do agree they were mostly incremental until Solana. I might be a bit biased.
Right, you actually tweet about Solana a lot.
Yeah. I haven't noticed. But then the alternative is you have a bunch of L2s that are actually worse than the previous L2, or actually definitely worse than the L1. I mean, if you don't believe me, you can kind of just go to l2tobeat.com and just look and make a judgment after that. And so I think now the incentive is to launch chains instead of actually looking at any problems that exist and solving those problems.
So I did, like 2 days ago, I tweeted something very controversial, or like that sparked a lot of debate, and I asked the question why, like the original use case of crypto was, like everyone's talking about apps. You asked me, what apps can you build? And like the original purpose of crypto, the original app is payments. Like Bitcoin is peer-to-peer digital cash. So like we haven't even succeeded at the most basic use case, which I consider to be the hello world of what crypto should be. So it's like now we're talking about like doing more complex apps when we haven't even succeeded at payments. And there is this saying that there's too much infrastructure and not applications, but actually I don't think so. I think there isn't enough infrastructure. Because even Solana, I don't think even Solana is Visa scale. Like 2K TPS is the limit right now, right? So even Solana cannot like handle the world's payments. You know, so I thought we succeeded at this basic application with the payment, which is payments. And yeah, people are saying, well, that should be the last application, but I don't agree with that. I think payments should be like the goal, the basic application that everyone should be trying to get to.
But payments with what? Like
I see people buying coffee.
TIA token or stable coins, or like what are they supposed to pay?
Anything, just please.
Well, they're not going to pay in TIA or Bitcoin or Ethereum because they're
USDC. Even USDC.
Okay, so we'll build a modular chain for people to transfer bank assets.
Sure, but anything like if you can start anywhere, then that's better than nothing.
I'm just grilling. I actually agree with you that we should be like stablecoins are like an order of magnitude better than banks, and we should be. I think that's maybe the only thing in crypto. Like after all of these mother, Iggy Azalea twerks and Daddy Coin, like the only thing like that remains is that stablecoins are better than banks. And we should use them more. And I don't even think we have to do anything. They're spreading on their own. That's the only like chart that goes straight up. And we should build better infrastructure for it and make it happen. And then people will actually use their stable coins and lending applications to get yield and all that. So I kind of agree with you. We got to solve for payments first, and like no one's really doing that.
I don't think the bottleneck for payments is infrastructure. I think it's mostly regulation and actually the merchants giving a shit to accept the coins in the first place. People do this on Solana today. I'm actually the CEO of Helio, which is a payments network on Solana. And for example, when you pay for breakpoint tickets, you can use Helio and whatnot, and also which uses Helio's RPCs, by the way. But the problem is no one really gives a shit, right? They're like, okay, whatever. Why should I accept this coin? It's maybe going to go down in value.
Yeah,
maybe
but you give a shit, right? Would you rather imagine that we didn't have to make our investments through our bank accounts? Like you would prefer stablecoin, though, right? Yeah. And so I think that's the fundamental principle. We prefer stablecoins over the banking industry. Let's just scale that intuition. And there's not that many regulatory hurdles. I can receive stablecoins from you. There's no one stopping me. Yeah, maybe businesses, there's small hurdles, but I don't think they're like insurmountable.
Well, it just needs to be like if you're okay. So these merchants need like a 10x reason to change and learn all these new systems and give a shit about why should I accept this? What can I do with it? Why is it easier for me? Maybe it's like marginally lower take rates or something, but then they kind of maybe lose some of the insurance benefits and like the other kind of boomer security kind of model, which has been established for some time now. And so I don't think any infrastructure solution actually helps move payments forward as much as, first of all, giving people a reason to use it, giving them a reason to switch over. I don't think infrastructure is a bottleneck.
Global Venmo is a 10x improvement over local Venmo.
Like yes. Venmo is newer than Bitcoin. It's got 50 million users in the US. It's got 700 employees. Like the amount of capital that has been poured into blockchains is at least like 100x more than Venmo. There's at least like 20x as many people working on crypto infrastructure than Venmo. Probably, I'm guessing.
Okay, this is boring. Switch tracks.
I agree. I agree. All right.
You mentioned Venmo.
All right. I want to skip here and actually talk about what is the right way to build an ecosystem.
These just all my tweets?
These are all your tweets. These are all your tweets. All right, I want to talk about what the right way to build an ecosystem is, and maybe to editorialize a little bit in my position as roast master here. I think that one of the challenges with modularity is this idea of like fragmentation. This is what people have been talking about, especially in Ethereum land, but also in modular writ large. One of the advantages of modular is that you get to be much more specialized. But you also have this kind of fragmentation problem, both in terms of tech,
you're fragmenting who has to take like a value add percentage, but you're also fragmenting narrative, and everything feels a little bit more disjointed, as opposed to something like Solana, a more integrated approach, maybe feels a little bit more cohesive, but maybe in the end state it's limited at scale. So like we're in the battle here to win hearts and minds, right? I don't think we want to be here, and maybe if there's not enough infrastructure now, I don't think we want to be here with the same group of people in 10 years. Everyone in this room is great, but I don't think we want this to be exactly the same in 10 years as it is right now. So what's the right way to build an ecosystem? How do we go out there and coordinate people to win hearts and minds? It wasn't really a roast. Now I'm just curious what you guys think.
I mean, I'm not one to dictate the right way to build anything. I think something I say pretty consistently is that you must explore all paths to maximize the probability of a crypto future, because one path might not work, but then there's a lot of other people in parallel innovating. So that's actually why I like modularity, because it allows people and capital to get into the space and kind of do their own thing. This particular tweet is more so about
Yes, Eric, good.
Is that an Aperol?
This is, yeah.
It has alcohol.
It's got alcohol, that's all we need to know.
Okay.
That's the special cup.
Are we doing this?
Yeah, well, we'll wait for everyone, solidarity.
Yeah, I don't know the right way to build anything. Okay, we just.
All right, how do we say salud?
All
Do
right.
we cheers?
All right.
But whatever.
Cheers.
All right, cheers.
To Solana.
To the roll-up centric roadmap.
The Bitcoin's roll-up centric roadmap.
Yeah, I mean, the point here isn't to actually roast, or in that tweet at least, I mean, now the point is to roast modularity, but in that tweet it's not. It's more so to defend the notion that integrated chains can't innovate. Because there's like a common thing where it's like, okay, if you're an integrated chain, you must rely on Tolly's word, and then you must get permission so you can, whatever, build something. But we just released ZK compression, and we just proved that wrong directly, right? We're now scaling Solana's storage costs and account allocation costs by like 6,000x. And we did not need to, raise a token and raise this $100 million round and whatnot. We just kind of did it. And then I posted on Twitter, and then of course, Adam Cochrane told me it's a Validium, therefore it must be a Validium. But fundamentally, it's just, there is no right way to build things. People will do kind of what they want. And as long as people are trying to push the mission forward, I think that's all that matters. I don't think, I don't think you need to have some badge of alignment to actually ship something that actually is the only way to do something. You can kind of just build whatever.
But the point is that that permissionless innovation you just cited on Solana is modular, right? Like ZK compression is, in my opinion, still basically a rollup. And the problem with a monolithic chain is that there is only one roadmap. There can only be one roadmap. And in modular, there can be, you talked about like all these different, we have to explore as many paths as possible, right, to get to the end game. And that's what modular enables. We can, in parallel, be exploring every single possible path. Yeah, some of them suck. Some of these L2s, most of them are going to fail, right? It's about creative destruction. It's about, like, failure is, like, when people talk about entrepreneurship, it's like failure is actually a good thing because you learn that doesn't work. And that helps you find the thing that does work in the end.
Yeah, like I used to be a big believer in this, but then I actually tried to build an application. So this was on the Ethereum base layer. I had a project called Orbland, and we realized that people can ask questions and get an answer from like an influencer, whatever. But the fees on the L1 got high enough that we needed to migrate to an L2. And then we needed to make a choice. So which L2 are we going to migrate to? And then we were like, okay, so Arbitrum is a good, that's the best L2. Let's go over there.
You should have done a sovereign rollup.
Right. No, I'm not going to make it my own. I just want to deploy. Okay. Arbitrum, that might be where the liquidity is. So we were thinking about Arbitrum. And then, no, actually, like friend tech is over at Base, and maybe there's where the SocialFi app, so maybe I should go over to Base. But Base is like a completely centralized chain, maybe, and actually maybe it's happening over, and Blast has talked about that they're going to be the L2 for NFTs, so they're going to build like a native bridge for NFT. All Upstack L2s has this, but the Blast was supposed to build a way for you to like bridge in NFTs like ERC 721s. And then we just got stuck because there's all these L2s and it's really hard to pick one. And we just, so the company's now bankrupt and doesn't exist anymore because we basically got stuck in this like decision deadlock, like which fucking of these L2s are we gonna pick? So that's the, so modularity, the roll-up centric roadmap, like I feel like a fucking idiot because I did this exact same mistake with Bitcoin, that Lightning, you know, I'll just buy inbound liquidity for all my payments, and then when I actually had to do it, it's like, wait a minute, this sucks ass. And then with the roll-up centric roadmap, it's like, okay, now I gotta deploy an application, but how do I choose which roll-up to build on? So I'm like so we were actually looking into let's build Solana orbs, because then we just have one decision, like, and everything works in the Solana ecosystem.
It's debatable.
So yeah, how do you guys respond to that? Like, what should I have done? Like, what did I do wrong?
Yeah, and let me just add one element here of there is a path dependency and a timing element to this, right? Where even if the end game might end up being something that's more modular and distributed, who's to say that we should go 100% modular right now? Like, how do we trade off this feeling of fragmentation and Eric's orb project going bankrupt because he has to decide between so many L2s? Maybe we need that once we actually have users and applications, and then we have many different chains. But for the amount of applications that we have today, maybe one chain is better because it actually eliminates choice. And what's to say that we couldn't just modularize later?
Yeah, I just want Colgate, like as a toothpaste. I don't want like 40 different ones and get stuck there and like one choice makes things easier.
I mean, for what it's worth, I don't actually, like, there will absolutely be multiple chains and there will be multiple winners, and I don't think one chain could possibly, actually totally might kill me for that, so I'm not going to say that. So Nick actually said, okay, Solana's modular, and I actually agree. But kind of the point here is it's always been that way. Nothing has changed. We just didn't say it on Twitter because it doesn't help anybody build things on Solana. It's like, build on Solana because it's modular. It's like, no, build on Solana because it's fast block times, large quorum, thing go fast. That's about it.
Twist. Solana's modular.
Yeah, but what were your, like, how do you, like, what was your light nodes that you do, like, in Paris or an airplane or a toilet seat?
Well, I mean, that's actually a good point, because you say that anyone can, Solana chains can move fast, and there is a team that wants to implement light nodes in Solana, but Solana doesn't want to make the changes on the core protocol to support that. And things like data blobs, like Eclipse wanted to use Solana as the A layer, but they couldn't because there's a Solana improvement proposal to add data blobs, and that's moving extremely slowly.
Well, you don't need the blobs to post the data. I mean, it's already cheap enough. Furthermore, like ZK compression is a good example of we didn't need anything from the High Council to ship something that actually scales the blockchain. And then there's actually a new client coming called Mithril, which basically takes out all the weird parts of like gossip and all those sorts of weird nerdy stuff. And you can just run it locally on whatever, Nokia, BlackBerry. And you can verify these blocks at home without needing to be a data center chain. And so I think a lot of the nuance gets lost by just saying monolithic, modular. I think it's more like engineers who want to help ship things to improve the state of the space.
So we're almost out of time here, but I would just be curious, like, if that's the end state, right, and what we should be building is that the infrastructure should meet the needs of the apps, then what are the apps saying today? Are we doing this for payments and merchants, and is that who we should be, like, what blockchain should be used for? Are we doing this for, WorldCoin or whichever chains are built? That, like, what do the apps actually say today, and how should that dictate what the infra should look like?
Well, I think that's the question, right? Like, in fact, in the second last tweet where I said like the debate is so dumb, and the next reply is like, what should actually matter is we need to keep looking for apps and then understand their problems. So if there's like an analogy, what we've currently done is, let's say there's like 10 doors with different keyholes. We just made a key at random and just try to just open all of them at the same time and just say like mass adoption or the next billion or something. And then just try to just basically punch the shit out of the door to make it fit. But what you need to do is you need to look at all the doors and the keyholes and then study them and then design something that uniquely can open them, right? And so you need to work backwards from the market in the problem space that exists and then see like, okay, does a modular architecture here make sense, or can they kind of just be all on the shared state machine? Maybe they need composability, maybe they need Tolly's blog post, I don't know, Tolly's shit post or something, maybe some marketing help. And so that's kind of the fundamental question that's just, I think that's unanswered. I also run another company, Helium, does mobile networks, and that's like a pretty good example of something that's just like, you know, it's just mobile networks, but then they can kind of use the same shared global state machine and then integrate with DeFi teams to kind of strengthen a product. So like Deepin makes sense, but you know, we don't really know the answer.
Oh, first of all, I just want to say I think we can keep it rolling if we want to.
All right. Cool.
Use your discretion, Mike, as the
MC.
master
here. All right.
But my response is like, I do think obviously you should listen to user and developer needs, right? But you also can't predict in advance what those are. And so the best thing you can do is build infrastructure that covers as many possible potential bases as possible. And that's exactly what I think modularity does, right? It means that like, we don't know what the killer apps of crypto are going to be. Yeah, payments is definitely going to be one of them. I think.
It was supposed to be Orbland, but it died at the it died at the altar of the roll-up centric roadmap.
Yeah, but I feel like in any like infrastructure application sort of dynamic.
Name 10 books. No, sorry. Name 10 apps. It's hard, right? It's hard. Orbland was one of them, and
well, let me just finish my point.
Becoming fewer and fewer.
You are trying to build in anticipation of something in the future, but you can't know what that is. So the best thing you can do is build for as many potential futures as possible, and then the thing that sticks is the thing that happened to be right. But you can't know in advance, and that's why I think modularity is the only answer.
Well, I mean, I think Ethereum kind of did that, but then now there's, the Paradigm guys are like, wait a minute, actually, maybe this doesn't make sense. Do we shorten the block times? Do we make some other, client changes, whatever? And I think fundamentally a blockchain, there's certain things that are shared between them. And like, as long as you're like, okay, we need to increase the number of full nodes in the quorum size, make it faster, make it cheap, make it such that a Bored Ape mint in some part of the state doesn't affect me buying a shitcoin somewhere else, local state markets, whatever. And that is, technically you can label that modular. I mean, all good software really is modular. But the way I like thinking about it is like integrated is actually just modular, but enshrined to the core. So yeah.
Maybe that's a really good way of framing the question is, what are the limits of the creative destruction, Nick, that you described? Like, when do we say, all right, we're just going to let the free market compete it out, and the best solution is going to win, versus does there need to be some steward of these ecosystems? Maybe it's the original founder who does blog posts or something like that, or the role of a foundation, right? But ultimately, there need to be some forces or structures that kind of set the guardrails. So do you see any limitation to the force of like creative destruction and capitalism and all these VC projects that just get to compete and win? Or should there be some sort of organizations that sets guardrails, maybe thinks about things like enshrining things at the base layer, dealing with interop, that type of thing?
I have no idea what you just said, but I have another point. I have one point to make. I have one point to make.
All right.
And I think, like, fundamentally, we got to change the tagline from build whatever to fucking build something.
I'll run that by our head of marketing and see what he says about that. But for some context, the source of build whatever is less cringy than build with no limits, or some corporate tagline like that, which is what like people like Avalanche have.
Okay, so we're less cringy than the cringiest.
So that's our main USP. That's for sure.
Okay. All right. That's a wrap, folks.
All right, you heard it from Eric. All right, guys, that's the end. Thank you all very much. Guys, give a big round of applause for our panelists here. Mert, thank you very much for allowing us to pull some of your previous work. And big round of applause to Celestia for putting all of this on. Guys, thank you for putting on a wonderful show.
Thanks, Mike.
All right, thank you guys. We are going to pull apart the panel, and then we got closing statements. And thank you guys for coming to Modular Summit.
Got it.
Crushed it. Do you remember SwiftKey?
SwiftKey, yeah.
Yes.
Yeah, I actually had more too. I had like 7 or 8 of them.
All right, we got it.
A lot of people are complaining about. We have a close.
Oh, sorry.
Hi.
Hey.
G Modular.
Wow. A lot of people. Did you
Hey,
guys
guys.
have fun the last 3 days? Yeah!
It's been 3 days. It's been 3 days.
Yeah. Traditionally, closing remark, you got to stand up. But honestly, we really need to sit down right now. Right?
Yeah, we need to sit down.
We really need to take a big break and stuff. But we just, have to do some closing remarks and shout outs. Now, you want to start?
Yeah. Thank you guys all for coming here. It's been amazing to see everyone here. Me and Yaz, we flew in here for 10 hours in February, and it was a vision. We had this vision to make Modular Summit 3.0 here. The vision is real now, and it's all because of Celestia Labs, Maven 11, and our mostly main sponsors, Astria, Anoma, Hyperlane, and Initia, and other sponsors.
Yeah, and shout out to all the other sponsors, curators, Anna Rose, Tina, the Blockworks team, and L2B, great tracks. Shout out to all the speakers, you guys are great. And shout out to Nicholas and Marie, you guys have been amazing in making this dream come true. Modular Summit 3.0, the theme was modular expansion, which was coined by No Sleep John. You see that at the beginning of the silo.
Half of it. Just half of it.
Yeah. And now that the modular thesis is expanded, we see a lot of great projects benefit from the modular stack, which all started with a paper called Lazy Ledger. But what is next? Let's find out at Modular Summit 4.0 next year. Now, let's all get a drink. There's food, and there's an after party sponsored by Hashflow. So get off your seat and let's go party.
Surprise DJs. Thank you, guys.
And finally, everyone should thank Yaz and Matt for organizing a big chunk of this. They put a lot of effort into this. It's taking 6 months of work. So everyone, great applause.
Thank you.
Thank you.
Shots.